In this video, you're going to learn how to develop a Spring Boot application using microservices architecture. This is going to be a highly practical tutorial, so to follow along, I expect you to have at least a basic understanding about Spring Boot and basic understanding of what microservices architecture is and why we use them. So we'll be building a simple online shop application using microservices architectural patterns, using mainly Spring Boot and the latest Spring Cloud technologies. So we're going to cover all the interesting and important architectural patterns like service discovery, centralized configuration, distributed tracing, event-driven architecture, centralized logging, and much more. If you're not aware of what are these fancy terms, don't worry, we'll cover this in the tutorial. So before going ahead and implementing our microservices, let's take a moment to understand what is Spring Cloud. Spring Cloud is a project under the Spring Projects ecosystem. So it's another project like Spring Boot, Spring Data, Spring Security, or any other Spring project, but it mainly concentrates on helping us to build the reliable and robust microservices. It provides us a common set of design patterns which are implemented already, like the configuration management, service discovery, circuit breakers. And there are many other patterns which are implemented into the Spring Cloud project. We'll have a look at it in depth in this tutorial. You don't need to worry about that. We are going to use Spring Cloud to mainly develop the microservices. That's what you need to know. As you understood what is Spring Cloud, now let's go ahead and check what are the different services we're going to build in this tutorial. So the first service we're going to build is going to be a product service. So this service provides us an API to create and view products in our application, and it also acts like a product catalog where we can view all the products inside our application. So the next service is going to be an order service where we can order the products which are available in the app, and after that we are also going to have an inventory service where the order service can check if the product is in stock or not before submitting the order. And lastly, we're also going to have a notification service where we can send email notifications after the order is placed successfully. And out of these four services, we are going to mainly have the order service, inventory service, and the notification service talk to each other. We mainly have the asynchronous and as well as the synchronous communication as part of these three services. So now let's go ahead and check the overall solution architecture of our project. Alright, so this is how the solution architecture diagram looks like. So mainly we are going to first look at the services we are developing. So we have the product service, which is talking to MongoDB, and an order service, which is talking to the MySQL database, and the inventory service is also talking to the MySQL database to store all the inventory information. And we have the notification service, which is like a stateless service, which it does not have any database, but it is responsible to just send out notifications to the users. If you're talking about a microservice architecture, you cannot call it as a microservice architecture if the services are not talking with each other, right? So here the order service is talking to the inventory service. So whenever an order is being placed, we will first check whether the inventory is available or not by making a synchronous communication. And after that, we are also going to send out the notification once the order is being placed successfully. So for that, we are going to make an asynchronous communication with the notification service. If you're not sure what is synchronous and asynchronous communication, don't worry, we will also cover this in detail in this tutorial. Coming to the asynchronous communication, we are going to make use of two softwares, like we will call it as message queues. So we are going to see how to deal with both the popular message queues in the market, like the RabbitMQ as well as Kafka. So we will see how to configure both of these message queues to do the asynchronous communication. And coming to the outside world, we have the surrounding services which enable the microservice architecture. We have the API gateway, which acts like a gateway to send the requests from the user to different services. So for example, if I am a user and I want to communicate with the product service, I don't want to give the host name or the IP address of the product service to communicate with it, right? So the API gateway acts as like a gatekeeper to send out the requests to different services we like. So our applications are also being secured using the authorization server called as Keycloak. We'll also have a look at it in the detail. And other than that, we also have different services like Eureka, the config server. We're also going to use Vault to store the secrets. we're going to use Zipkin to do the distributed tracing, and also to do the logging, to do the centralized logging. We're also going to use Elasticsearch, Logstash, and Kibana. And again, don't be overwhelmed with all these details. We will have a look at each of them in detail in this tutorial. Alright, so if you'll have a look at the logical architecture of each of the services, we have a controller, service, and a repository layer for each of the services. So in the controller layer, we will be receiving the HTTP request from the clients, and from there the business logic is being executed on the service layer. And in some of the services, we are also going to communicate with a message queue. So that's why we have this message queue communication, and mainly in the order service we are going to make use of the message queue and also the notification service. And after that, we are also going to store the information in the database. So for that, we are also going to maintain a repository layer which mainly talks to the database. So we have a Postgres and also the MongoDB database. So both of them will follow the same pattern. We'll have a repository which talks to the database. This is how almost all the services are being structured. So we'll follow the same process for all the services we have. Alright, so let's start coding. So first we are going to develop the product service. For that, I'm opening the website start.spring.io where you can generate the initial version of the code. So for that, I'm going to select this latest Spring Boot version as of creating this tutorial, that is 2.6.4. And for the group ID, I'm going to provide the text com programming techie, and the artifact is going to be product service, and the description is going to be also product service. You can enter whatever description you like. I'm going to use Java 17, and for the dependencies, I'm going to first make use of Lombok to reduce the boilerplate code, and I also need access to Spring Web, so that we are going to make use, as we are building a REST API, so I'm going to use Spring Web. And lastly, I'm also going to add Spring Data MongoDB, as the product service is going to communicate with a MongoDB database. After adding all these dependencies, I'm going to click on generate, and the product service is going to be downloaded to your machine. So I'm going to first unzip and open it on my favorite IDE. The first thing we have to do is to configure the MongoDB URI inside the application.properties file. I'm going to give the database name as product service. If you want a detailed explanation on how to configure Spring Boot with MongoDB, have a look at the Spring Boot MongoDB playlist in my channel. You can also find this in the description section. After that, we have to create our domain model, which is the product class. So let's create a package called as model, and inside the package I am going to create a class called as product. To define this product as a MongoDB document, I am going to add the document annotation to the top of the product class, and I'm also going to add the Lombok annotations to generate the getter setter methods and the constructors. Inside the class, I'm going to create the required fields, which are ID, name, description, and price. And to the field ID, I'm going to add the ID annotation from Spring Data to specify that this is a unique identifier for our product. And to store this product inside the database, we have to create a Spring Data repository. For that, I'm going to create a package called as repository, and inside this package, I'm going to create an interface called as product repository. And I'm going to extend this interface with the Spring Data MongoDB's Mongo repository interface, and I'm going to pass in the generic argument as product, and for the identifier, I'm going to pass a string as the second generic argument, because this is the type of the ID field in our product class. Now it's time to create the controller class. So for that, I'm going to create a package called as controller, and inside the package I'm going to create a class called as product controller. As we are exposing a REST API, we have to add the REST controller annotation to the top of this class, and also the request mapping annotation with value /API/product. So now let's create the API to create the products. So for that, I'm going to create a method called as public void create product, and this method, as this creates some products, we are going to send a post request for this method. So I'm going to add the post mapping annotation, and as a response we are going to type in response status, and we are going to send out the HTTP status as created. So I'm going to select HTTP status created, right? And as a request body, we are going to receive the product information. For that, we are going to create a new class called as product request, right? So this is going to act as a DTO. So I'm going to create this class inside a new package called as DTO, and also this class is going to have a Lombok annotation to create the getters and setters called as data. I'm going to use the builder annotation to create the builder method, and also the allocs constructor and the noaux constructor. So inside the product request, we're going to mainly have 3 fields similar to what we have in product. So I'm just going to copy paste these 3 fields inside the product request. Alright, so we'll have name, description, and as well as the price. So now we have the product request, and let's go back to the product controller, and we are receiving the product request as the request body. And to actually create the product, we have to do the processing, like the processing of the business logic in the service layer. We can't do it on the controller layer. So for that, I'm going to create a new package called as service, and in here I'm going to create a new class called as product service. So as this is a service, we are going to add a Spring Boot annotation called service, and we are also going to create a new method inside here called as public void create product, which takes in the product request as the method parameter. And inside here we have to first map the product request to the product model. So for that, I'm going to create a variable of type product. So let's also import the product from the package, from the model package, and create a reference variable called product. And I'm going to make use of product.builder method, so to build the product object. So for that, I'm going to type in the name as product request.getName, and the description as product request.getDescription. Lastly, the price as product request.getPrice. And once we have set up all these information, I'm going to call the build method so that it will create the object of type product with all the requested details. And lastly, we have created the instance of the product object. Now we have to save this into the database. So for that, we need to access the product repository. So I'm going to inject the product repository into a service class, the product service class. Mainly I'm going to make use of constructor injection. So I'm going to type in private final product repository. And after I have added the declaration of product repository, you can see that IntelliJ is already complaining that the product repository is not initialized. So I'm going to add the constructor parameter here. So you can see the constructor is automatically generated. So instead of doing this manually for all the classes, what I can do is I can just remove this constructor which is generated, and I can add the annotation required args constructor from Lombok. So what this will do is at the compile time, it will create the constructor for us, which all the required constructor arguments, right? So this is something handy which we can use. So now I'm going to save this product inside the database by typing product repository dot save product. So after doing that, the product will be saved successfully to the database. We can also add some logs here by making use of SLF4j. So I'm going to type in SLF4j. So this is coming from Lombok, and to add the logs, I'm just going to create a new line under the save method. I'm just going to type in log.info product is saved, right? So we also have to give the information which product is saved, right? So maybe a product ID would be useful. So for that, instead of concatenating the product ID like this, like product.getID, something like this, Using SLF4j, we can actually make use of a placeholder. So I'm just going to add a placeholder like a double curly brace, and after that I'm just going to type in comma and add product dot get ID. So what this will do is it will dynamically it will get the ID of the product and it will replace it on the placeholder. So when you execute this, you will get product followed by the product ID is saved, right? So we have the create product method. So now let's also create let's call this create product method from the product controller. So as we did similarly for the product service, we also have to inject the product service inside the product controller. So for that I'm going to type in again private final product service, and to inject product service I'm going to make use of again the required args constructor from Lombok. So now we have the product service. I'm just going to call inside the create product method product service dot create product, and I'm going to pass in the product request. So this will create the endpoint to create the products. So now I'm going to create another endpoint to retrieve all the products. So for that I'm going to create another DTO called as product response. And similar to what we did for the product request, so I'm just going to copy everything we have inside all the annotations we have defined for product request called product response. And inside the product response we are also going to send the ID in addition to the name, description and price. So for that I'm just going to copy everything we have inside the product model class. So I'm just going to type in product response. So now you may be confused why I have created a separate class called as product response, right? So maybe why can't we directly use the product class from the model package instead of creating the product response? This is because it's a good practice to separate your model entities and the DTOs. So ideally you should not expose your model entities to the outside world, because if in the future in this product class if I've added some other two fields which are like necessary for the business model, we should not expose these two fields which are not necessary outside to the outside world, right? So for this reason it's a good practice to separate your model entities and also your data transfer objects. So in this case the product request and the product response acts as the data transfer objects. So now I've created the product response. So to create the get endpoint, so get all products endpoint, I'm going to first type in a get mapping annotation, and this response status annotation is going to send a response status of HTTP status OK, right? And now I'm going to type in public list of product response, and I'm going to call it as get all products, and I'm going to import this list class from java.util package. And now I'm going to create a method inside product service to get all the products. So I'm going to call in product service dot get all products. So I'm going to create this method as this is not existing yet inside the product service. So this get all products should return a list of product response. So I'm also going to import this list from java.util package again quickly, and in here I'm going to type in product repository dot find all, because I want to first read all the products inside the database. So I'm going to store it inside a variable called as products, and now I have to map this product class into a product response class, right? So for that I'm going to type in products dot stream dot map. I'm going to make use of Java 8 streams and the map function, and I'm going to map each product into a product response object. So for that I'm going to create a new method called as map to product response. I'm going to create a new method inside the product service. So this is should not return an object but should return a product response, right? So here I'm going to create a object for product response using the builder method. So I'm going to select response.builder.build, and as part of the builder I'm going to provide the ID as you know what, we don't have the product as an input argument, so let me add the product as the input argument here to the map to product response method. So now we have the product, so I can just map the ID of the product to the ID of the product response by typing in product.getID, and again name as product.getName. So let me just scroll down to make it visible clearly. So again we have the description, so I'm going to type in product.getDescription, followed by the price, so I'm going to type in product.getPrice. So now we are creating the object of product response and returning it back to the getAllProducts method, and in here IntelliJ is suggesting some changes here. So as we are using a method inside the class, we can actually make use of the method reference instead of lambda. So I'm just going to select replace lambda with method reference, and now after we mapped it, we are going to collect it into a list. So I'm going to call toList method, and finally I'm going to return this list back to the controller. So we have the getAllProducts, which is returning a list of product responses, with a list of product response objects. So now I'm going back to the product controller, and I'm going to add a return statement here. Alright, so now we have both the create product and the getAllProducts endpoint implemented. So now let's start the application and check whether the application is going to start without any errors or not. Alright, so you can see that we are able to start the application on the port 8080 without any problems. So now let's quickly go ahead and test whether our application, our REST API is working correctly or not. So I'm going to open Postman. So here I prepared a post request for the URL http localhost 8080/API/product. So this is going to be a post request. So for that I'm going to provide a request body raw in the type of raw JSON, and here I'm going to create a request body of name as iPhone 13, description as iPhone 13, and price as maybe $1,200, right? So I'm going to send this request, and we can see that we got 201 created response back from our application. Now I'm going to copy this URL, and I'm going to create a new tab and paste in this URL, and now I'm going to send a get request to our API, and you can see that we received the product which we have created in the previous step. So our product service is working correctly, but we are doing this testing manually. The ideal situation would be to have some automated tests in the project. So let's go ahead and write some automated tests for our product service next. So to be able to write tests for our product service application, we can open the package source test, and under Java we have the test product service application test, which is auto-generated by the Spring Initializer for us. So we are going to write the test in this class, but before going ahead and writing the test, we are mainly interested to write integration test for this product service test, right? So we are not going to write a unit test, but we are going to create an integration test where we will spin up the application context, the whole application, and we will test whether the post API and the get API is working or not. So before going ahead and writing our tests, I'm going to first install a library called as test containers in our project. So if you're not aware of what test containers library, this is a Java library that supports us to write JUnit tests by providing some throwaway instances of common software we need, like databases, web browsers for Selenium, and RabbitMQ, message queues, and so on and so forth. Whatever external infrastructure we will be relying on, we can use that external infrastructure software as Docker containers, and we can run integration tests in our project, right? So some examples are, you can test the data access layer integration tests using the Docker instances of MySQL, Postgres, or any other database. And you can also use the Docker containers for message queues, web servers, and also this can be used in the UI and acceptance tests using Selenium. So it provides many different Docker containers so that we can use this in our tests. So that's why we have the name test containers. So if you have a look at the modules which are supported, you can see that it has different databases, Elasticsearch container, gcloud module, Nginx module, Kafka containers, so on and so forth. We have a lot of modules which are available. As of now, in our tests, in our integration tests, we want to have a container for MongoDB. So for that, I'm just going to click on the databases and select the MongoDB module. And here you can see the documentation, like the usage example, how we can use this MongoDB container in our tests. Right? So before we go ahead and use this MongoDB container, we have to first install test containers in our project, right? So for that, I'm going to click on Home, and I'm just going to scroll down until I find the section Maven dependencies. So if you want to install the test containers individually, you can just click on Maven and copy the whole dependency. So you can use this particular dependency. The other thing you can do is we can have, if we want to have multiple test container dependencies, right? If we want to have one test container dependency for MongoDB, one for Kafka, and one for, I don't know, any other module. It's a good thing to have a bill of materials, something called as a bill of materials, where you can just provide the version as in one place, and all the dependencies, all the other dependencies you use for the test containers will take the same version. I'm just going to copy this particular section, and I'm going to open my pom.xml, and I'm going to paste this particular code about the build section, right, inside the dependency management section. And I'm just going to load the Maven changes. Alright, so once this is done, now I can install the MongoDB container in our application, in our project. So for that, I'm just going to go back to the test containers website, and I'm going to click on modules, databases, and MongoDB module. And here I'm just going to scroll down until I find the adding this module to your project dependencies section. I'm going to click on Maven and click on copy, go back to my pom.xml, and under the Spring Boot starter test dependency, I'm just going to paste in the MongoDB test container dependency. And again, I'm going to load the changes. So once this dependency is downloaded to your machine, I can remove the version, because as I'm already defining the version inside the dependencies management for the test containers bill of materials. I don't need to explicitly create the version one more time inside the dependencies section, right? So I'm just going to again reload the changes. So in this way, if I want to, no matter how many modules I use for the test containers, I can just define the version only in one place here inside the test containers bill of materials, right? So this is the advantage of using the bill of materials inside the dependency management section. And apart from this, as we are using JUnit 5 to write the tests, we also need to add the JUnit 5 supporting module for test containers. So for that, I'm going to open again the test containers website, documentation website, and I'm going to click on the section test framework integration and go to JUnit 5. And in here, all the way down in the adding test containers to JUnit 5 section, I'm going to click on Maven, and I'm going to copy this particular JUnit Jupyter dependency one more time. And going back to the pom.xml, I'm just going to paste this below the MongoDB dependency. And similarly, I'm just also going to remove the version tag from the JUnit Jupyter test container dependency, and thus I'm going to load this Maven changes. So now let's go ahead to the product service application tests class and start writing the integration test for our product service. So to get started, I'm going to add the So to get started, the first thing I'm going to do is to add the test containers annotation on top of the class, so that JUnit 5 understands that we are going to use test containers to run this particular test. And after that, I have to define the MongoDB container inside our tests, right? So for that, I can type in MongoDB container and create an object for the class MongoDB container. And to this MongoDB container, you can see that this MongoDB container class is deprecated because the noah constructor, we cannot use the noah constructor anymore. We have to manually specify the version of the MongoDB we want to use. So for the argument constructor, we have to provide the Docker image name for whatever software we want to use. So I'm going to provide the Docker image name as Mongo, and I'm going to provide the tag as 4.4.2. right? So this is the Mongo version I want to use for this test. So I'm going to add another annotation on top of this declaration called as container, so that JUnit5 will understand that this is a MongoDB container. And I'm also going to add the static declaration because I want to statically access this particular MongoDB container and fetch the URL of the MongoDB database URI, right? So because as we are going to use this we need to set the URI of this MongoDB container in our test properties. So let's do that by first adding a method called as static void set properties, and this method is going to take a class, an object of type dynamic property registry, and inside this method I'm going to type in registry dynamic property registry dot add, and I'm going to type in spring dot data dot mongodb dot URI, and I'm going to here pass in the MongoDB container get replica set URL variable. So in this way, at time of starting the integration test, first of all, the test will start the MongoDB container by downloading the Mongo 4.4.2 image, and then after starting the container, it will get the replica set URL and add it to the Spring Data MongoDB URI property dynamically at the time of creating the test, right? Because if you remember, if you have a look at our source main resources folder, we have defined the Spring Data MongoDB URI manually in the application.properties file, right? But as here we are doing an integration test, we also have to provide the Spring Data MongoDB URI dynamically at the time of creating the test, because as we are not using the local MongoDB database, we are using a MongoDB Docker container. We have to provide the Spring Data MongoDB URI property dynamically. So to be able to provide this property dynamically, we also have to add another annotation on top of this set properties method called as dynamic property source, which will add this property to our Spring context dynamically at the time of running the test, right? So after adding all these configuration, we can go ahead and start writing our integration test. So the first test I'm going to create is for the product controller create product endpoint, right? I want to send a product object, a product request object, and I expect the response status to be created, right? So that's what I expect whenever I send a product request object. I expect the status to be created. So let's test this behavior. I'm going to open product service application test, and I'm going to change this context loads test to should create product. And to be able to make a request from our integration test, I'm going to make use of something called as a mock MVC, some object called as mock MVC, which will provide us a mocked servlet environment where we can call our controllers, where we can call our controller endpoints, and we can receive a response as per the response which is defined inside the controllers, right? If you want a refresher on the testing concept of Spring Boot testing concepts, you can have a look at this Spring Boot testing tutorial crash course I have on my YouTube channel. It will provide a nice overview about what are all the aspects you need to know to be able to write tests using Spring Boot. right? So for now, I'm going to make use of the mock MVC object to make requests to the product controller. So for that, I'm just going to auto wire the mock MVC object into our test, right? And you can see that we are getting an error, could not auto wire, no beans of mock MVC type found, because we have to auto wire, we have to auto configure the mock MVC in our test. So for that, I'm just going to add an annotation called as auto configure mock MVC. Now you can see that the error is gone. That means our mock MVC is auto configured, and then now we can auto wire mock MVC in our test, right? So now I'm going to make use of mock MVC object, and I'm going to type in mock MVC.perform. This perform object, this perform method will take in a request builder and an object of type request builder. So for that, I'm going to type in mock MVC request builders dot post. As I want to do a post request, I'm choosing the post method, and in here I'm going to just type in /API/product, because this is the root URL of the product controller. I'm just going to copy this particular URL endpoint and provide it as the URL template. And after that, we also have to provide a request body of type JSON. So for that, I'm just going to type in dot content type as media type application JSON, and I'm going to provide content as a string, right? I want to provide the content as a string. So for that, first we have to create the request body of type product request, because as we are taking a request body of type product request, first of all I have to create an object of type product request. For that, I'm just going to create a method called as get product request. I'm going to create a method inside the test class, and in here I'm just going to return product request dot builder dot name is going to be iPhone 13, and description is going to be also iPhone 13, and the price is going to be big decimal dot value of $1,200 maybe, right? And I'm going to finally call the build method to be able to construct an object of type product request. And let me also just format this correctly, and also this method should return an object of type product request but not void. Alright, so now we have the product request object ready. So I'm just going to also store this particular return object inside a local variable called product request, and now I want to send the product request object as the request body, but this content method will only take the object of type string. So now what I have to do is I have to convert this product request object into a string, right? So for that, I'm going to make use of something called as an object mapper, private object mapper from Jackson data bind package. So what this object mapper will do is it will convert a POJO object to JSON and JSON to POJO object. It will help us to convert this particular objects to JSON and vice versa. So I'm going to make use of object mapper, and I'm going to type in object mapper dot write value as string, and I'm just going to pass in the product request. And this write value as string is going to throw an exception. So I'm just going to add exception to the method signature. And finally, I'm going to store this written object into a local variable called as product request string. I'm going to provide this now into the content method. And finally, I'm just going to also define another exception from the perform method. Alright, so now we have provided all the required input for calling the create product API. Now the next thing I want to do is I want to verify whether the request is going to be, the response status is going to be 201 created or not, right? So for that, I'm just going to type enter and type and expect, and I'm going to type in status. This is going to be a static method which is coming from mock MVC result matchers. I'm going to import the mock MVC result matchers dot status method, and after the status method I'm going to type in is created, right? So in this way, mock MVC will make a call to the API product create product endpoint by providing the product request string as a request object, and it will expect whether the status is created or not, right? So let's go ahead and run this particular test, whether it's working correctly or not. I'm just going to run the product application service test. Now what you're going to observe your very first time here is the test containers is going to, if it's not already available, it's going to pull the MongoDB image from the Docker container registry, right? So it will take some time as it needs to first pull the Docker image and then start running the test. And here you can see that the test has successfully created the MongoDB container and then started running the test against this MongoDB container, right? So if you go to the should create product, you can see that it has triggered the product service. Product with this particular ID is saved to the database. And let's do one verification whether the data is really saved or not. I'm just going to auto wire the product repository, right? And I'm going to verify product repository dot find all dot size is going to be 1, right? Because we have inserted one product, we expect that we should have one product inside the repository. So for that, I'm just going to type in assertions dot assert true, and I'm going to add this product repository find all size method call inside the assert true method, and just I'm going to verify whether the size is going to be 1, right? So after making sure that the create product endpoint is triggered successfully, we are also making another assertion that the product repository contains the product or not, right? And here you can see that the IntelliJ is suggesting us to, we can simplify this assertion. I'm just going to use assert equals here. So in this way, we can have the expected value and the actual value as the second parameter. So now let's make sure that we run the test again to verify whether everything is working fine. Yes, indeed. So the test is working fine. So in this way, we can have some automated tests in our microservice so that we are not always relying on the manual test. We can also have some automated tests in our microservice. So I'm going to give an exercise or a homework to implement also the test for the get product endpoint. I've created the test for the create product. Now it's your turn to implement the integration test for the get product. As this is going to be a microservice project, a microservice course, I'm not going to go in depth about the testing part. I've just provided you a hint on how to write the integration test for the microservices. Now you can go ahead and implement the required test for the other endpoints by yourself. I'm also not going to implement the test for the other services like order service and the inventory service. But if you are stuck when writing the test, you can find the test inside the GitHub repository. So I'm going to give an exercise or a homework to implement also the test for the get product endpoint. I've created the test for the create product. Now it's your turn to implement the integration test for the get product. As this is going to be a microservice project, a microservice course, I'm not going to go in depth about the testing part. I've just provided you a hint on how to write the integration test for the microservices. Now you can go ahead and implement the required test for the other endpoints by yourself. I'm also not going to implement the test for the other services like order service and the inventory service. But if you are stuck when writing the test, you can find the test inside the GitHub repository. So you can refer whenever you want and whenever you are stuck while writing the integration test. Alright, so now it's time to create our second microservice, that is the order service. For that, I've opened the website start.spring.io, and here I'm going to go ahead and create another microservice, our order service. So I'm going to type in inside the group ID, programming techie, and the artifact is going to be order service, and the name is also going to be order service. And I'm going to select Java 17 as the latest stable Java version. And coming to the dependencies, I'm going to add the dependency for Lombok and also for Spring Web. And as we are going to use MySQL database for the order service, I'm going to scroll down and add the dependency for Spring Data JPA. And lastly, I'm also going to add the dependency for MySQL JDBC driver. Once you have all these dependencies, you can just click on the generate button. As we are going to create more and more services, we have to maintain these services. We have to run these services parallelly by opening multiple IDE windows. So that will create a lot of load on your machine, right? So to get around that, what we can do is we can maintain all these services inside one project. So for that, I'm just going to create a new folder called as microservices parent, something like this, and I'm going to move this product service and as well as the order service into the parent project. So in this way, I just need to open the microservices project microservices parent folder inside IntelliJ, and I will have both these projects inside one ID. Alright, so now I opened IntelliJ and I'm going to click on open and select the microservices parent folder which I've created before. Click on OK, and now you can see that we are able to access both the product service and as well as the order service inside one folder. So now let's open the order service and let's have a look at the pom.xml. We have the Spring Boot Starter Data JPA and Spring Boot Starter Web, and two dependencies for the dependency for the MySQL JDBC driver, Lombok, and the starter test dependency, right? So now first what I'm going to do is I'm going to create a package called as controller, and I'm also going to create some other packages so that we will have this structure called as controller, service, repository, and the DTO, right? Like how we did for the product service in this way, right? So let me create the package for repository, another package for DTO, and lastly we need another package for model, right? And for the order service, the model we are going to maintain in our database, now MySQL database, is going to be to store the orders. So for that, I'm just going to create a new class inside model package called as order, and this class is going to be a JPA entity. So for that, I'm just going to add the entity annotation from JavaX persistence package, and I'm also going to name this table as t_orders, and I'm going to add a getter and setter annotation followed by noargs constructor and allogs constructor for the order class. And coming to the fields inside the order class, I'm going to add a primary key as ID with data type as long, and I'm going to add the ID annotation from JPA and also the generated value annotation with strategy as generation type dot auto. And I'm going to also create a string variable, and I'm also going to create a field called as order number, and followed by I'm going to create a list of order line items, right? So each order contains some items inside the order. So each order contains some order line items. So I'm going to create the order line items list, and we have to also create this order line items object class. We have to create this order line items class inside the model package. So I'm just going to create this class inside the model package. And this order line items is going to again have an entity annotation from JPA. This is going to also be a table. So I'm just going to add the table name as order T underscore order underscore line underscore items. So similarly to order class, I'm just going to add the getter, setter, allogs, and the noaux constructor from Lombok. And I'm going to also add the ID of type long, and I'm going to add the ID annotation from JPA, followed by the generated value annotation with strategy as generation type identity. And the next field I'm going to create is going to be order number of type string. And after that, we are going to have a list of order items inside the order. So for that, I'm just going to create a list of order line items. I'm going to call this as order line items list. I'm just going to import this list class from java.util package, and we have this order line items. And let me create this order line items class inside the model package. So this order line items class is again going to have the entity annotation from JPA, the table annotation, and I'm going to name this table as T underscore order underscore line underscore items. And I'm going to add the getter annotation and setter annotation from Lombok, followed by allogs constructor and the noaux constructor. So inside the order line items, I'm going to again have a primary key called ID, which is of type long, and I'm going to add the ID annotation from JPA as this is a primary key, and I'm going to add the generated value annotation with the strategy as generation type dot identity, because then it will be, as this will be auto incremented the primary key for each value, for each new record which we are saving to the database. And next in the order line items, we are going to maintain the SKU code. So I'm going to type in the field of type string called SKU code, followed by the field price, which is of type big decimal, and lastly we will maintain the field called as quantity, which is of type integer. We have our basic model created, but we did not define any relationship between the order table and the order entity and the order line items entity, as this is going to be, as the order and the order line items is going to have one-to-many relationships. I'm just going to add one-to-many annotation, which cascade as cascade type all. So now we are done with the model part. So let's go ahead and create the controller and the endpoint, which will help us to create orders inside the order service. So for that, I'm just going to create a class called as order controller. I'm going to add the REST controller annotation on top of this class, and inside the request mapping, this is going to take the value /API /order, and inside the class I'm going to create a post mapping, and I'm going to call the method as calls public string place order, and this method is going to just return a string called as order placed successfully by default. And this place order method is going to take a request body of type order request, and we don't have this order request class created yet, so I'm just going to create this class called as order request inside the DTO package. And here I'm going to add a data annotation so that we will have the getters and setters and all the default boilerplate methods for the class. And I'm also going to add the allocs constructor followed by the noaux constructor. And this order request is going to have a list of order line items DTO class. So this is going to be order line items DTO, and this order line items DTO is still not existing in our, we have to create this order line items DTO. So let's go ahead and create this order line items DTO class quickly inside the DTO package. And I'm going to just quickly copy and paste the whole annotations from the order request class and paste it on top of the order line items DTO class. And for the order line items DTO, I'm just going to open the order line items class and I'm going to copy everything there is inside the order line items class and paste it inside the order line items DTO, because we'll basically have the same fields inside the order line items DTO also. And coming back to the order request, I have to fix the compilation errors by first importing the list class from Java util package into the order request class. And now the next thing is to create a service so that it will create the orders inside the database. So for that, I'm just going to create a new class inside the service called as order service. And this order service is going to have a service annotation on top of the class. And in this class, I'm going to create a method called as place order. And this place order method is going to take the order request which is coming in from the controller, and from this order request I now have to create an object of type order. So for that, I'm just going to create new order object of type order, and I'm going to say order dot set order number as UUID dot random UUID. I'm going to provide some random UUID as the order number. And now I have to map the order line items which is coming in from the order request as order line items DTO to the order line items inside the right. So for that, I'm just going to say order request dot get order line items dot stream, and I'm going to call the map function so that I can map the object of order line items DTO to order line items. So I'm going to type in here order line items DTO, and I'm going to create a method called as map to DTO and provide the order line items DTO as the method parameter. And I'm going to quickly create this method called as map to DTO inside the order service. And instead of returning an object from this method, I'm going to return an object of type order line items. And inside this method, I'm going to create an object of type order line items, and I'm going to just map all the fields which we have. Right, and finally I'm just going to return the order line items back to the place order class. And inside this map method, you can see that we can replace this lambda with a method reference. So I'm just going to replace it with a method reference, and I'm going to convert this to a list of order line items by using the .toList terminal operator. I'm going to introduce a new local variable called as order line items, and finally I'm going to set this order line items to the order by typing order.set order line items and providing order line items. And now we have constructed an object of type order. Now what we have to do is to save this order inside the database. So to save this order to the database, we need to create a repository. For that, I'm going to right click and go to new class, and I'm going to create a new interface called as order repository. And this order repository is going to extend JPA repository of type order, and the primary key is going to be of type long. Right. So now once we have the order repository, I can just inject this order repository into the order service. So I'm just going to type in private final order repository, and as this is going to be a constructor injection, I have to create a constructor parameter. For that, instead of creating the constructor manually, I can add the required args constructor annotation from Lombok. So then it will create a constructor automatically based on the parameters during the compile time. And I'm going to use this order repository inside the place order method, and I'm going to type order repository dot save, right? So in this way we are receiving the order request from the client to the controller, and the controller is passing the order request to the order service, and inside the order service we are mapping this order request to an order object and finally saving this order into the order repository. So now let's go back to the order controller class, and now we have to call this order service from the order controller, right? So for that I'm just going to inject this order service by typing private final order service, and I'm going to also add the required args constructor, so that will have a constructor parameter for order service. And inside the place order method of the controller, I'm going to type in order service dot place order request, right? So whenever the user places the order, it will be saved to the database and it will return the text called as order placed successfully. And I forgot to add the response status, and the response status is going to be http status created. So let's test whether this is working or not. So I'm just going to open order service application, and I'm going to run this order service application, and you can see that we are getting an error because of course we did not define the data source attributes inside the application.properties. We did not define the database URL and all the related properties inside the application.properties file. So I'm going to do that now. So inside the application.properties file, I'm just going to type in spring data source.driver class name. This is going to be com.mysql.jdbc.driver, right? And spring.datasource.url is going to be my JDBC URL. So just I'm going to type in JDBC MySQL localhost 3306. This is going to be my port on which MySQL server is running, and I'm going to call the schema as order service, right? And I'm going to type in spring.datasource.username as root, spring.datasource.password as MySQL, jpa.hibernate.ddl-auto is going to be update, and spring.datasource. And lastly, I'm also going to add the server.port as 8081. As on 8080 we are running the product service, we want to run the order service on port 8081. Right? So let's go ahead and start the application now, and you can see that the application is started successfully, but we see a warning that the class MySQL JDBC driver is deprecated and the new class is com MySQL CJ JDBC driver. So I'm going to use this driver instead of the other one. So I'm just going to paste this inside the application properties, and I'm just going to restart the application one more time. And now you can see that the application is started on port 8081. So now it's time to test whether the endpoint is working correctly or not. So I'm just going to open the Postman client. I'm going to open the Postman client, and then now I'm going to type http localhost 8081/API/order. And I'm going to send a request body of type JSON, and in this request body I'm going to type I'm going to send the fields for the order request. So it's going to be an array of order line items DTO, right? So I'm just going to create an order line items DTO array, and inside that array I'm going to first send the SKU code, price and quantity, right? And instead of order line items DTO, it should be order line items DTO list. The name of the key value of the JSON is going to be order line items list, and inside the object I'm going to create a SKU code, price and quantity, right? So I'm just going to create an object for SKU code and an object for price, and this is going to be 1200, and quantity is going to be 1, right? And for the SKU code, I'm just going to type in iPhone underscore 13, and I'm going to just click on 13, and I made a mistake here. It should be localhost 8081 but not 8082, and also I have to send a post request to the order service. So now with this request body, if I click on send, I should receive a success response, order placed successfully with status as 201 created. That's perfect. Now the next thing we have to do is to create the inventory service, which will check whether the products are in stock or not, right? So let's go ahead and do that. All right, so now I'm in the start.spring.io website, and it's similar to the other two services. I'm just going to leave the defaults for the Spring Boot options and also the packaging, and the Java version I'm going to add it as 17. The only change I'm going to do is to change the artifact name to inventory service, and I'm going to add the dependencies similarly to order service. I'm going to add the dependency for Lombok, dependency for Spring Web, dependency for Spring Data JPA. I'm just going to scroll down until I find Spring Data JPA, and the dependency for MySQL. You know what? I'm scrolling down. I can just search for MySQL driver here. So I can just select MySQL driver, and once everything is done, I'm going to click on generate. All right. So open the inventory service project inside your favorite IDE, and after that, I'm just going to open source main resources, and the first thing I'm going to do is to configure the MySQL database properties inside the application.properties file. So for that, I'm just going to leverage on the changes we did for the order service. So I'm just going to open the order service and just copy all the properties which you have defined inside the application.properties, and I'm going to paste it inside the application.properties of the inventory service. So one question you may have is, why did I not add the inventory service already inside the microservices, microservices parent, right? Because at this moment I'm facing some issue to add the inventory service to the microservices parent, but we are going to add them to one project by creating Maven multi-modules further down the project. So you can just continue by opening the inventory service in a new IDE, and we'll do the refactoring later, right? And the next thing I'm going to do is to change the server port to 8082, because 8080 is taken by the product service, 8081 by the order service, and 8082 will be assigned to the inventory service. So now the next thing I'm going to do is to create a package inside the root package called as model, and inside this package I'm going to create a new class called as inventory, and this inventory class will act as the model where the actual inventory which we are storing in the database. So for this reason we are going to add the entity annotation from JPA, and we're going to add the table annotation also with the name as t_inventory, and we're going to add the getter annotation, the setter annotation, all args constructor, no args constructor annotation, and inside the inventory class I'm going to add a primary key called ID with ID annotation from JPA, and generated value annotation with strategy as generated value type dot identity. And after that I'm going to add the field called as SKU code, which represent the product. And lastly, I'm going to add another field called quantity, which will provide the number of items which are in stock for this particular SKU code. Right? So the next thing I'm going to do is to create the repository for this corresponding JPA entity. So for that, I'm just going to create the repository package and create an interface called as inventory repository. And this inventory repository is going to extend JPA repository, because as we are using Spring Data JPA and Spring Data JPA to store for the persistence, and for the JPA repository we have to provide the inventory as the first generic argument, as the JPA repository is going to take two generic arguments. The first one is going to be the type of object which you're going to store, and the second one is the type of the primary key. And here the type of the primary key is going to be long, so I'm going to add the type as long. So the next thing is to create the controller where we can create our endpoints, right? So I'm just going to create the controller package and create the inventory controller class. And similar to all the controllers we have created, I'm going to add the REST controller annotation and the request mapping annotation with value as /API/inventory. And in here, in this inventory controller class, I'm going to have only one method, and this method is going to be a get mapping. So we're going to make a get call to get the inventory status, and this response status is going to be http status dot OK, and the method name is going to be public boolean is in stock, right? So what this particular endpoint is going to do is it's going to take in a SKU code, and it's going to verify whether the SKU code, or means the product, is in stock or not, right? So for that we have to take in the SKU code as a request parameter or maybe a path variable, right? So for that, first what I have to do is I have to add the path variable to the get mapping annotation. So I'm just going to type in slash and type SKU code, and I'm also going to add the path variable annotation here. It's going to be string SKU code, and as this is not going to be as part of this naming conventions, I'm just going to add the path variable as SKU code. So now inside the isInStock method, I have to query the database to check the inventory. So we are not going to access the inventory repository directly. We are going to create a service class. So for that, I'm going to create a package called as service. And inside the service, I'm just going to create a class called as inventory service. And this inventory service is going to have an annotation called as service, because this is representing a Spring Boot service, right? So inside this inventory service class, I'm going to create a method called as public boolean is in stock, and this is going to take in the string SKU code as an input parameter. And inside this is in stock method, I'm going to query the inventory repository, right? So for that, I need to inject the inventory repository into the inventory service, where private, I'm going to type in private final inventory repository, and I'm going to add the constructor parameter by typing the required args constructor annotation from Lombok. And inside the isInStock method, I'm going to type in inventory repository dot find by, and I don't have any method with the find by extension, so I'm just going to type in find by capital S SKU and capital C code. So this will going to be an extension method from Spring Data JPA. So I'm going to create this method in the inventory repository. So Spring Data JPA is going to automatically implement the logic for this find by SKU method. So at the runtime, Spring Data JPA will generate the query to retrieve the inventory by the SKU code, right? So this find by SKU code method should not return a type of void, but it should return an optional of type inventory, right? So I'm just going to import the optional class from Java util package, and let's go back to the inventory service. And here I'm just going to return this optional dot is present value, right? As the find by SKU code method is returning an optional, I can just type in dot is present to check whether the object is present inside the optional or not, and I can just return the value from the is in stock method directly. And lastly, I'm going to add the transactional annotation on top of this method, and this transactional is going to be read only transactional annotation from Spring Framework, and I'm going to add the read only attribute as true. I think we have forgot to add the transaction annotation on the order service, so let me check once. So I'm going to open source main Java service order service, and yeah, we didn't add the transactional annotation, right? So I'm just going to add the transactional annotation on top of the class by typing transactional from Spring Framework transaction.annotation package, right? So in this way, Spring Framework will automatically create and commit the transactions. Once this is done, I'm going to go open the inventory controller class, and I'm going to now call the inventory service.isInStock method from the inventory controller. So for that, I'm just going to type in inside the inventory controller private final inventory service, and I'm going to add the required args constructor from Lombok, and here I'm going to type in return inventory service dot is in stock, and I'm going to pass in the SKU code. So in this way, we have created an endpoint which takes in a SKU code as the path variable and queries the database based on the SKU code, and will return the response whether the inventory is whether the product is in stock. And one last thing we have to do is we have to create the data inside the database, right? So if we try to run the application and if we try to query this particular endpoint, of course it will return false by default because there is no data inside the database, right? So for that, what I can do is I can create a bean inside the inventory service application class. So what this bean will do is it will try to load the data at the time of application startup. So for that, I'm just going to type in bean definition. So I'm just going to add the bean annotation followed by the method public command line runner load data. I'm going to name this method as load data, and this bean is going to take the inventory repository as the method parameter. So this will be injected through the method injection, and inside this load data method we are going to create a supplier, and inside this supplier I'm going to first create an object for the inventory class. So I'm going to first set the inventory SKU code as iPhone_13 and the quantity as 100. So I'm going to now create another inventory object called as inventory1. So here the SKU code is going to be iPhone 13 red, and for this inventory I'm going to set the quantity as 0, right? So after defining these two objects, I'm going to save these two objects into the database. So for that, I'm going to type in inventory repository dot save inventory, and for the inventory1 object, I'm also going to do the same thing, inventory repository dot save inventory1. So at the time of application startup, this bean will be created, and as part of this bean, we are going to create both these objects and save to the database. So before we test whether this is working correctly or not, I'm just going to open MySQL Workbench, and I'm going to first create a schema called as inventory service. I'm going to click on apply and also apply. This will create the schema inventory service. And now let's go to the inventory service project inside IntelliJ, and start our inventory service application. So you can open inventory service application and just click on this debug option, and at the time of startup it should execute this particular piece of code where it will save the inventories to the table, to the repository, inventory objects to the repository. So let's check whether this is executed correctly or not. Yes, it does. So we have two objects, iPhone 13 and iPhone 13 red, inside the database. Alright, so before I've said that instead of maintaining these two projects, inventory service and microservices parent, we're going to club everything into one project. We are going to create one parent project, and we are going to maintain all our services into that parent project, right? So let's try to do that now. So what I'm going to do now is I'm going to create a new Maven project, completely new Maven project inside IntelliJ. So for that I'm going to go to File, New Project, and I'm going to select the option Maven, and make sure to select the version you like. I'm going to select JDK 17 here, and I'm going to click on Next, and here I'm going to provide a name called as microservices new. So this is the project name I'm going to give. It's like a new parent, and in the artifact coordinates I'm going to name the group ID as com.programmingtechie, and the artifact ID I'm going to leave it as microservices new, and I'm going to click on Finish, and I will going to click on new window. It will ask whether to open the project in this window or in a new window. I will click on new window, and now you can see that it created an empty Maven project which contains just an empty source main, Java folders, resources, and the test resource folder and the test folder, and it's just a complete empty Maven project, right? So what I'm going to do now is I'm going to create three modules, one for the product service, one for the order service, and the other one for the inventory service. So inside this Maven project I'm going to create a Maven module. So for that I'm going to right click and go to New Maven Module, and again select the SDK as JDK 17, click on Next, and I'm going to name this module as product service, and I'm going to check whether the artifact coordinates are similar to the group ID we have provided for the root project. And the artifact ID is going to be product service. Click on Finish, and this product service module is now created again with a pom.xml file. You can see that the artifact ID is product service, and if I open the pom.xml for microservices new root project, it's also added inside the module section, the product service. So similarly I'm going to create a module also for the order service and the inventory service. Alright, so now we have all these three modules inside our root project. So as we have these modules, we don't need the source folder anymore. So I'm just going to delete this source folder. And now what I'm going to do is, now I'm going to migrate all these three projects we have before inside this microservice parent and in the inventory service. I'm going to migrate this into the microservices new project. First thing I'm going to do is to open the pom.xml of the product service. So inside the microservices parent, I'm going to open the pom.xml of the product service, and I'm going to copy everything under the dependency section. So I'm going to copy everything which is inside the dependency section. So all the way down here I'm going to copy the dependencies tag, and I'm going to paste it inside the pom.xml of the product service. So just beside the properties, just below the properties, I'm going to paste in the dependencies section, right? So after adding this dependencies section, so now what I'm going to do is I'm going to do the similar thing also for the order service. So go back to the microservices parent, open the POM XML of the order service, and again copy the dependencies inside the order service, and go back to the order service inside the microservices new and paste them just below the properties tag. Alright, so now we have the dependencies for the order service. Let's do the same thing also for the inventory service. I'm going to open the inventory service, pom.xml, and copy everything inside the dependencies, right? So copy it and open the inventory service inside the microservices new folder, and again similar to the other two projects, I'm going to paste in the dependencies just below the properties tag. So now we have the dependencies in all three projects. Now what we need is the inside the product service of the microservices parent. I'm going back, right? So I'm switching a lot between these two projects. I hope you are understanding. So I'm inside the product service of the microservices parent, and in here we have the dependency management tag, right? So this is where we are defining the version of the dependencies for the test containers. So I'm going to copy this dependency management tag, and I'm going to add it inside the root folder. I'm not going to add it inside the product service, but I'm going to add it inside the root of microservices new project. So you may get the doubt why I'm adding it in the root, because if I add it in the root, and if you want to have the test container dependencies inside the order service and as well as the inventory service, you don't need to repeat yourself, right? Inside the product service, before we are adding the dependency management tag, and instead of repeating them on each module, I can just define this inside the parent module under the dependency management tag, and this dependency will be like propagated to all the child's services like order, inventory, and the product service. So that's the main reason we are adding it in the parent. And another important thing we have to do is to open the microservices parent. Like you can open any of the pom.xml, and you can see that the parent is defined as Spring Boot starter parent for each of the services like product service, order service, and the inventory service in the old setup, right? So what I'm going to do is I'm going to copy the parent, and if I open for example product service, you can see, if I scroll up, you can see that the parent is microservices new project, right? But to be able to download all these dependencies to our project, we have to define the parent as Spring Boot starter parent. So for that, what I can do is I can go to microservices new project, and I can define the Spring Boot starter parent as the parent of the microservices new project, right? So in this way, if microservices new project is the parent for order service and the inventory service, so this Spring Boot starter parent will be the grandparent of order service, inventory service, and the product service. So in this way, all the version will be downloaded without any problems to our project. So if I click on the load Maven changes icon, all the dependencies will be downloaded without any problems, right? And one last thing I have to do is now to add the Spring Boot Maven plugin, right? If I open the one of the old setup, so if I go to product service, we have this plugin information here, right? Like the Spring Boot Maven plugin, and also in the order service we have the Spring Boot Maven plugin, right? So I'm just going to copy this whole build tag where we have the compiler plugin and the Maven plugin, and similar to dependency management, I'm going to add it inside the root project, inside the microservices new pom.xml. So in this way, the Spring Boot Maven plugin and the compiler plugin will also be added to all the child projects, right? So again, I'm going to load the Maven changes to make sure that there are no problems in the setup. So to be able to test whether everything is working correctly or not, we have to also copy the source code, right? So now if you check the services, we don't have any code inside. We have already developed the code for this one. So what I'm going to do is I'm going to first delete this source folder. Delete this source folder inside the product service. I'm going to do the same thing also for the order service and the inventory service, right? So what I'm going to do now is I'm going to copy the source code from the old projects. So I'm going back to the microservices parent project, and I'm going to copy the source folder from the product service. Just right click, copy, and just paste it under the product service. Right click, paste. New name will be source. Click on OK, and everything will be copied without any problems. Similarly, I'm going to do the same thing for the order service. So go back to the old project, microservices parent, copy the source folder, paste it inside the order service. It's fine. And now open the inventory service, copy the source folder, and paste it inside the inventory service. Click on OK, and everything should work without any problems. Now, just to verify that everything is working fine, what I can do is I can run a command called as maven clean verify. So I'm going to open the Maven tab to the right side of the IntelliJ IDEA, and I'm going to click on this M icon to execute a Maven goal. And here I'm going to type maven clean verify, right? So what it will do is it will just run the compile. So it will try to build the project without trying to install everything. And finally, you can see that the build is success, and it took total of 29 seconds on my machine to execute this. And lastly, let's check whether the applications are also working correctly or not, like are also able to start up correctly or not. So I'm going to open source main Java product service application, and I'm going to run the product service application. So you can see that the application is started without any problems. The product service application and the order service application. Let's start this one more time, and it started successfully on port 8081. Lastly, the inventory service. Let's start this application, and also you can see that it started successfully on port 8082, right? If you are facing some problems, if you're not able to replicate the same result as I am, you can download this whole project from GitHub. I will upload this as a starter project for this particular series in GitHub. You can download this project and you can start working from that point, right? So again, you can check the initial setup branch inside the Spring Boot microservices new repository, and there you'll find the complete setup, the initial setup, which we have just did before, right? So just download this project if you are facing any problems, and then you can start coding along with me from now on. Alright, so before we go on, there is a small bug inside the inventory service, application class. So we are running this load data method multiple times so we are running this load data method whenever we are starting up the application, right? So that means whenever we are starting up the application, we are inserting this two inventory objects into the database. So that means for sure we have some duplicates inside our database. Let's go open our MySQL workbench, and I'm going to run the select query, and you can see that this particular iPhone 13 and iPhone 13 red SKU code inventory objects are duplicated. So to prevent this, for now, what I can do is I can just select all these duplicated records, and I can just try to delete them manually. Delete and click on apply, and this will delete all the records from our table, right? And to make sure that it won't occur one more time, what I can do is I can go to resources, application.properties, and as this is not a production application, I'm just going to add it as create drop, the DDL auto as create drop. If you are using it in a production setup, please don't use create drop. You have to use DDL auto as none, and you have to use a database migration library like Liquibase or Flyway to do this kind of migrations. So please don't use create drop. This is just used as a demo purpose, and please don't take this as a recommendation to add this inside your production code, right? So having said that, let's restart the inventory service application. And now if you open the inventory service, click on select, you can see that we still have the two records. We are not duplicating it because it's creating and it's first dropping and then creating the schema again. So in the previous part, we have developed all the required services for our project. So we have developed the product service, the order service, and the inventory service. But what is still missing is like we don't have the services communicating with each other in our project, right? Usually in a microservice architecture, if I open the architecture diagram again, we want our services communicating with each other, right? So this kind of communication can be of two types, as I've already mentioned before. It can be of type asynchronous communication or asynchronous communication. So let's have a look at this kind of communication in detail. So we have our order service, and imagine that we want to make a call to the inventory service whenever a customer places an order. We want to check whether the product is in stock or not, right? So for that, our order service will make a call to the inventory service. It will make a HTTP request, and the inventory service will respond status of the product, whether the product is in stock or not. So based on this response, the order service will either place the order successfully, or it will throw an exception or show an error message that the product is out of stock to the customer, right? So this kind of communication where the service A is talking to service B and is waiting for the response from service B. So this kind of communication is called as a synchronous communication. So the exact opposite, where order service will make a request to the inventory service and it doesn't care about the response from the inventory service, then this kind of communication is called as asynchronous communication. So it's kind of a fire and forget pattern where the service A fires a request for service B and it won't care about the response from service B. So this kind of request, like the synchronous communication, is usually done through the HTTP clients, right? So the HTTP clients we have in our Spring Boot ecosystem are the REST template class, which comes by default from the Spring Boot framework. And we also have another alternative called as web client. So this web client class is coming from Spring Web Flux project. We can either use REST template or web client, but if you open the documentation of REST template, you can see that it is as of 5.0, Spring Framework 5.0, the REST template class is in maintenance mode. So Spring Boot is recommending to use web client as an alternative because it has a more modern API and it also supports synchronous, asynchronous and streaming scenarios. So for this reason, we will go ahead and use web client to make a synchronous request from order service to the inventory service. So let's go ahead and implement this in our project now. So I'm inside the project. So let's make so to be able to call the inventory service from the order service. So first let's open the order service class, and here while placing the order, we want to make a call to the inventory service. So let me add a comment here. Call inventory service and place order if product is in stock, right? So we want to implement this functionality now. So for that, as we have said before, we are going to use web client. So for that, let's first create a new package inside the order service package called as config. And in here, I'm going to create a new class called as web client config, right? Let me add this class to my Git repository. And I'm going to add a configuration annotation on top of this class, because as we are going to maintain the configuration about the web client class, so that's why I created a new class. And inside this web client config class, I'm going to define a bean of type web client, right? So for that, I'm going to add the bean annotation and type in public web client. And you can see that we don't find the web client class because this is not part of the Spring MVC project, but this is part of the Spring Web Flux project, right? So to be able to use Spring Web Client in our project, we have to add the Spring Web Flux dependency to our order service. So let's go ahead and do that. I'm going to open the pom.xml file, and right below the Spring Boot Starter Web, I'm going to copy this dependency information and just going to press enter and paste in the text I've copied. So instead of typing Spring Boot Starter Web, I'm going to say Spring Boot Starter Web Flux, right? If you type in, IntelliJ will already show us the recommendation. I'm going to just select the Spring Boot Starter Web Flux dependency, and I'm going to select on and click on this load Maven changes icon so that IntelliJ will download this dependency to our project. So once the dependency is downloaded, you can see that the red text around the Spring Boot Starter Web Flux is gone. That means the dependency is downloaded successfully to our project. And now let's go ahead to the web client config class and continue what we were doing before. So let's try to import this web client class from Spring Framework Web Reactive Function Client package. So you can see that this web client class is now available in our class path. And I'm going to call this method name as web client. And in here, I'm going to type in return web client.builder.build. Right? So what this will do is it will create a bean of type web client, and we are going to define that bean with the name of web client, right? So whenever we add a bean annotation, this bean will be created with the name of the method name. So whatever method name you have given, it will create the bean with this particular name, right? So if you want to use this particular web client bean inside the order service, we have to define this web client bean with the same name. So I'm just going to copy this web client name and go back to the order service. And now I'm going to inject this web client into our order service class by typing private final web client and just paste in the web client reference variable name. And now inside the place order method, I'm just going to type in just below the comment, I'm going to type in web client dot get, because the inventory controller, if you open the endpoint inside the inventory controller, you can see that we are exposing a get endpoint, which will take in a SKU code as the path variable, and it will return a Boolean variable as a response. So for that, we have to make a get call. So I'm going to type the get method, and in here I have to pass in the URL of the inventory service, right? So as we already know, inventory service is running on port 8082. That means I have to add the URL as http localhost 8082/API/inventory, right? So we're going to make a get call, and to be able to retrieve the response, I'm going to type in the method name .retrieve. And for the web client, we also need to add define what is the type of response we are returning from the inventory service, right? So for that, I can type in body to mono. So mono is nothing but data type in the reactive framework. I'm not going to go into the details of what is mono. To be able to, so just you have to know that to be able to read the data from the web client response, you have to add this body to mono method, and inside this body to mono method, we have to provide the type of the response, right? So we are returning a Boolean value as a response. So for that, I'm just going to type in Boolean dot class. And finally, by default, web client will make a synchronous request, right? But we have to make a synchronous request. So to be able to make a synchronous request with web client, we have to add one more line of code called as dot block, right? So if we add this piece of code, then web client will make a synchronous request to HTTP localhost 8082 to the inventory endpoint, right? Because I think I've got the syntax wrong. We should not provide the URL inside the get method, but we have to add another method called as .url, .uri, and then we have to provide the actual URL we want to call, right? So it should be like web client.get URI and then retrieve the response. So now we have to save this response into a local variable. So I'm just going to introduce a new local variable called as boolean, and I'm going to call it as result, right? And if this result is true, that means if the product is in stock, then we have to place the order, or else we have to throw an exception, right? So for that, I'm just going to type in if result, then order repository dot save order, else throw no illegal argument exception, and I'm going to type in product is not in stock, please try again later. Alright, so we are not yet done with the implementation. You can observe that our inventory controller is expecting a SKU code as a path variable, right? So for whatever product we want to make inventory check, we have to pass in the SKU code also as part of the get request. But here is one tricky thing. So if you observe the order object, you can see that each order can have multiple order line items, right? And each order line item contains a SKU code. So for example, if a customer orders 100 items as part of the order and it contains 100 SKU codes, should we make 100 calls to the inventory controller? Does it make sense? No, right? Because making 100 HTTP calls is very time consuming, and the request will also take a lot of time for the customer. The request processing will also take lots of time, right? So for that, what we can do is we can collect all the SKU codes which are present as part of the order, like take it as collect these SKU codes as a list, and then we can provide this list to the inventory service API, right? So we have to make the changes in the inventory controller. So instead of taking one string, one SKU code as the parameter, we have to take multiple SKU codes as a parameters, right? And this is how the usual HTTP request looks like if you are using so this is how it looks like. The HTTP localhost 8082/API/inventory and iPhone 13 would be the SKU code. And what happens if you send multiple values as part of the path variable? So this looks something like this, right? iPhone 13, iPhone 13 red, right? This is how the path variable format looks like. And what happens if we want to display it like a request parameter? So instead of path variable, we can also choose to define this as a request parameter, right? So in this case, the request parameter looks something like this, right? The SKU code equals iPhone 13 and SKU code equals iPhone 13 red. So for each element inside the list, it will create a separate request parameter and it will append it to our URL, right? I would like to go with this format because this is a more readable format, right? You can see that we have two different request parameters instead of the first one where we are just appending all the values with a comma, right? So for this reason, what I'm going to do is I'm going to remove the path variable. So I'm just going to remove everything inside the get mapping definition, and I'm also going to remove the path variable and add the request param annotation, and I'm going to change the string to a list of string, right? And I'm also going to import this list from Java util package, and of course the inventory service will complain that this SKU code should be a string instead of a list of string, right? So for that, I'm going to also change the is in stock method inside the inventory service from string to a list of string, and I'm also going to import the class list from Java util package. And similarly, I'm also going to do a change for the find by SKU code method, right? And in the string data JPA, we want to find the inventory, which we have to find all the inventories with this given SKU code, right? So instead of find by SKU code, I want to type find by SKU code in, and I want to provide all the list of SKU codes. Of course, this method does not exist yet, so I'm just going to create this find by SKU code in method, and this find by SKU code in method should return us a list of inventory objects, right? So we are providing a list of SKU codes, and Spring Data JPA will return us all the inventory objects which match this SKU code, right? So I can remove the first find by SKU code method as we are not using this anymore, right? And I'm going to go back to the inventory service, and now the isPresent method doesn't make any sense because we are returning a list from this find by SKU code in method, right? Now what we have to do is we have to also change the return type of this is in stock method, right? Before we are just returning a boolean, but now we have to return the stock information for each SKU code, right? So for that, what I will do is I am just going to remove the isPresent method, and I'm going to type in .stream, and now I'm going to map this list of inventory objects which are coming as a response to a different type, right? I'm going to create a DTO called as inventory response. So first I'm going to create a map method, and in here for each inventory I'm going to create a inventory response object. So for that, first I have to create the inventory response class inside the inventory service, project. So I'm going to create a package called as DTO, and inside the DTO I'm going to create a class called as inventory response, right? I'm going to add the data annotation from Lombok, all aux constructor, no aux constructor. I'm also going to add the builder annotation, and inside the inventory response I'm going to have two fields, private string SKU code and private boolean is in stock, right? We are going to store the information about the SKU code and whether the SKU code is in stock or not, right? Go back to the inventory service, and inside the map method I'm going to type in inventory response dot builder dot SKU code, and I'm going to type in inventory dot get SKU code, right? And coming to the is in stock boolean variable, I want to check whether quantity of inventory, right? So I'm going to type in inventory dot get quantity, and if this quantity is greater than 0, then we can say that the product is in stock, right? So I'm just going to add greater than 0, then it will return a boolean variable whether the quantity is in stock or not. And finally I'm going to type in the build method. So in this way we have created the inventory response object, and we want to send this as a response, send this as a return variable from our is in stock method, right? So for that I'm just going to type in .toList, and I'm going to remove the brackets here and also remove the semicolon. So in this way we will return the list of inventory response from our method, and instead of boolean we have to change the return type as list of inventory response, right? Now you don't have any compilation errors, and what we have to do is now we have to adapt also our inventory controller is in stock method. So I'm going to go open the inventory controller and change the return type also here from boolean to list of inventory response. So we are taking the list of string as request parameters, and we are passing this SKU code list of string into the is in stock method and querying the repository to find out all the inventory objects for this given SKU code, and then mapping the inventory objects to the inventory response object, and then finally we are sending this list of inventory response object as the response, right? I hope this is clear. Now the next part is we have to call this new enhanced get endpoint from our order service. Right, now inside the order service, and now what I want to do is I want to first collect all the SKU codes from the order object, right? So for that, what I can do is I can type in order dot get order line items list dot stream dot map, and for each order line item I want to map order line item dot get SKU code, and I can replace this lambda with a method reference. So I'm just going to replace lambda with method reference, and what I'm going to do is I'm going to collect this to a list. Now what I have is, if I try to store this into a local variable, I will get a list of strings, right? So I'm going to call it as SKU codes. Now I have a list of SKU codes with me. What I have to do is I have to enhance this web client API call to include this request parameters SKU codes as the request parameters, right? So for that, what I can do is right after the URI, I can type in URI builder, and I can type in URI builder dot query param. Let's add this in a new line so that it's visible. So as a query param, I'm going to provide the SKU code, right? So call it as SKU code, and I'm going to provide the list of SKU codes as the value, right? And I'm going to finally call build method so that the web client will build the URI with the query parameters as SKU code. So in this way, as I have said before, web client will construct the URI in this format. So it's not SKU code with hyphen, but it's going to construct it as SKU code with capital C, because as we have provided the variable name as capital C, so this is going to construct the request in this format. So now once we have made the call, we have to also change the return type of this get request, right? We are not returning Boolean as a variable anymore. We are returning an inventory response, right? So to show this inventory response inside the order service, we also have to create the inventory response class inside the order service, right? So let's go ahead and do that. I'm going to open order service, and inside the DTO, I'm just going to copy this inventory response and paste this inside the DTO package. So if you're confused why I'm creating this inventory response class one more time, because this inventory response, we have created it inside the inventory service, right? The class inside the inventory service, we cannot access it inside the order service. So that's why I'm duplicating this class inside. I'm also creating this class inside the order service. So now let's go back to the order service class. Instead of Boolean, I'm expecting a list of inventory response object, right? So I can also define this inventory response list as an inventory response array. So for that, I'm going to type in inventory response array dot class. So in this way, web client will parse the response to an array of inventory response objects and will provide it as a result, right? And we are getting a compilation error because we are trying to assign the result of this web client call to a Boolean variable. So instead of Boolean, I'm going to call it as inventory response array. So let's also rename this variable as inventory responses, or maybe inventory response array. And now we have to verify whether the products are in stock inside the each inventory response or not, right? So for that, I'm going to say inventory response dot stream, and what it will do is it will create a stream from the array, right? Using the arrays.stream method, it will create a Java 8 stream from the array so that we can easily call the all match method, right? And I'm going to type in inventory response dot is in stock, and I'm going to replace this lambda with a method reference, and also I'm going to store this inside a new local variable, and I'm going to call this local variable as all products in stock, right? Let's step back and see what we are doing here. So we got this list of inventory response array. We are converting it to a stream, and we are calling the all match method from Java 8. It will check whether the is in stock variable is true inside the array or not. If all the elements inside the inventory response list contains is in stock as true, then it will return as true. Even if one of them is false, we will get the all products in stock as false. So what I'm going to do is I'm going to copy this all products in stock and replace it with the result. And if all products are in stock, then we are going to save the order to the database, or else we are going to throw a exception. I hope this is clear. So now what I'm going to do is I'm going to restart the order service. So open the order service and click on this rerun order service button. And also for the inventory service, I'm going to open the inventory service, go to console and click on the button again, rerun inventory service application. So once both the inventory service as well as the order service is up and running, I'm going to open Postman, and I've already created a request here. So I'm going to make a call to localhost 8081 API order. This is going to be a post request, and inside the body I'm going to provide two items, right? Inside the order line items. One is going to be iPhone 13 and one is going to be iPhone 13 red, right? So iPhone 13 red is, we have set the quantity as 0. If I open the inventory application, and here you can see that for iPhone 13 red, we have set the quantity as 0, and for iPhone 13 we have set the quantity as 100, right? So if we try to place this order, we should get an exception, right? So let's try to see whether we are getting an exception or not. I'm going to click on send, and yes, we did get the exception. Let's go to the console and see whether the exception is correct or not. So you see that we are getting a response like product is in stock, please try again later. Product is not in stock, please try again later, right? So let's try again with a happy path. So I'm just going to clear this console, go back to the Postman client, and now I'm going to remove this iPhone 13 red object, right? So let's check whether we are able to place the order successfully or not. I'm going to click on send again, and now you can see that order is placed successfully. That means our order service is able to successfully communicate with the inventory service, and we are making it happen only with the one REST API call, right? We are not making multiple API calls, we are making only one REST API call. So with this, we have completed the development of our services. In the next part, we will have a look at the Spring Cloud ecosystem and how we can introduce the services in the Spring Cloud to our project, right? So I'll see you in the next video. Until then, happy coding techies. So in the previous part, we had a look at what is inter-process communication and how this works in our microservices project. So we have our order service calling the inventory service through the web client class, and we are making a call to the inventory service at the location at the URL localhost 8082/API/inventory, right? So let's also look at this here. So we are making a call directly to the inventory service by hard coding the URL. So the problem here now is this works as we are running is in our local machines, right? But usually in the microservices environment, everything will be deployed on a cloud environment. And in a cloud environment, we cannot have dedicated IP addresses, right? Everything will be dynamic. We will have dynamic IP addresses, and it will run on maybe different ports. Usually the microservices runs on port 8080, but it can run on different ports, right? We cannot make any assumption that an inventory service will be available in this IP address, right? In addition to that, we can have multiple instances of the given microservice. Like in this diagram, we can have multiple instances of the inventory service, and each instance can have a dynamic IP address. For example, we can have 10.120.23.1, 23.2 and 23.3. Now in this instance, how our order service will know which instance of the inventory service we have to call, right? It cannot understand which instance we have to call. Even though we try to hardcode one instance, IP address of the one instance, this instance can go down anytime, right? It can be stopped and shut down anytime, and we have to make a call to the other instances. So how do our order service understand which inventory service we have to call, right? So for this reason, there is a pattern called as service discovery pattern. And we are going to discuss this in detail in this video. So the service discovery pattern is nothing but creating a server, something called as a discovery server, which will store all the information about the services, right? The service name and as well as the IP addresses, like you see in this particular table, right? A discovery server is nothing but a place where it stores all the information about the services. When we are using the discovery server, what our microservices will do is they will first try to register at the time of starting up the application. They will try to register with the discovery server by making a request, right? Whenever the services are making the request, it will add, the discovery server will add the entries of these services into its local copy. We call it as a registry. So that's why it's also called as a service registry. Once all this information is present in the discovery server, when our order service wants to call the inventory service, so let's see how the communication will happen. Here in this diagram, when the order service wants to call the inventory service, the order service will first make a call to the discovery server asking where I can find the inventory service, and then the discovery server will respond with like particular IP address to call the inventory service in this particular IP address, and then the order service will make the call to the inventory service. In this way, we can avoid hard coding the URL of the inventory service by making use of the discovery server. How we can do that exactly, we will have a look at it later, but this is what you need to know to understand the service discovery process, right? And another thing which you have to know is when making the initial call to the discovery server, what the discovery server will do is it will also send its registry as the response to the client, right? So what the client will do is it will store also the local copy of the discovery server in a separate location. So if for some reason the discovery server is not available, it will first check the local copy, right? Because as it already has information about the inventory service, it will check the local copy and it will make a call to 10.12.123.1, which is the inventory service. So what happens if this 10.12. If the first instance of the inventory service is not available, right? It will try to check the next entry in the local copy. So it will make a call to 10.12.123.2. So likewise, it will go through all the entries of its own registry, and if all the instances are down, then it will fail the communication saying that the inventory service is not available. So we are going to see all this theory in practice. So now let's go ahead and create the discovery server. Alright, so the first thing I'm going to do inside our project is to create a new Maven module called as discovery server. So for that, I'm just going to right click on our root project and going to new module, and in here I'm going to select the Maven module and just click on next, and I'm going to give the name as discovery server, right? And I'm going to click on finish, and let's just check the artifact coordinates. We have the group ID as com programming techie, artifact ID as discovery server, right? And let's click on finish, click on add, and you can see that a new module, Maven module, is added, discovery server. And if I check the root pom XML file, the discovery server is also added as one of the modules of the root pom XML. So the next thing we have to do is we have to add the necessary dependencies to make this a discovery server. And to be able to create the discovery server, we are going to make use of the library Netflix Eureka. So let me open the Spring Cloud documentation, and in here, if I scroll down until I find the Spring Cloud Netflix project, you can see that we have a module for service discovery called as a Eureka server. So we can make use of this Spring Cloud Netflix Eureka server in our project to enable the discovery server capabilities. So for that, I need to add some necessary dependencies in our discovery server project. So for that, I'm going to make use of start.spring.io website. Here we have the good option to explore the repositories after we added the dependency, and we can just make use of the dependency information which is displayed here. So let me close this, and first of all, what I'm going to do is I'm going to add a dependency called as Eureka server. So this would be the Spring Cloud Netflix Eureka server. I'm going to add this dependency, and I'm going to click on explore, and I'm going to scroll down, and you can see that we have the dependency Spring Cloud Starter Netflix Eureka server, right? I'm going to copy this particular dependency and open my IDE, and under the pom.xml of the discovery server, I'm going to add the dependencies tag, and I'm going to paste in the Spring Cloud Starter Netflix Eureka Server dependency, right? The one thing you can observe here is this is coming from Spring Framework.cloud, but not org Spring Framework.boot, right? So for this reason, as this is coming from a different group ID, we have to add some additional information to our pom.xml. So if I go back to the start.spring.io website and just scroll down until I find the dependency management section, here we have the dependency management section, the BOM version of the Spring Cloud dependencies, right? So I'm going to copy this information, the dependency information. I'm not going to copy the dependencies. I'm just going to copy the dependency information, and I'm going to open my pom.xml here, the root pom.xml, because I'm already maintaining the necessary information for test containers inside this dependency management. I'm also going to add Spring Cloud dependencies to the dependency management section, and here I also need to add the Spring Cloud version. So for the Spring Cloud version, I'm going to add a property here under the properties tag called as Spring Cloud version, and this Spring Cloud version, this is going to be 2021.0.2 as of creating this tutorial. So I'm going to use the same version here, and I'm going to click on this Maven icon so that the necessary dependencies will be downloaded to my local machine. And you can see that the red text is gone, and that means the dependency is downloaded successfully to our machine. And the next thing I'm going to do is I'm going to open source main Java app, and I'm going to right click and create a package called as com programming.techie discovery server, and make sure you don't add any dash or hyphen here inside the package name, or else the IntelliJ won't recognize this as a Java package. So after that, I'm going to create a new class called as discovery server application, and this is going to be a normal Spring Boot application. So I'm going to add at Spring Boot application annotation, and we're going to have a public static void main method. So I'm going to create this method here, and inside this method I'm going to copy the existing text, which is spring application.run, and here instead of the inventory service application, I'm going to call it as discovery server application.class, and I'm going to pass in the command line arguments to the run method. Alright, so now we have the basic discovery server application. To make it a Eureka server, Eureka discovery server, all we have to do is we have to add enable Eureka server annotation on top of this class, and that's it. That's all you need to do to create the discovery server. Apart from this, you also need to add the application.properties. In the application.properties, you need to add some couple of properties. So for that, I'm going to go to the resources folder, click on new file, application.properties, and the first thing I'm going to do is I'm going to define eureka.instance.hostname. This is going to be localhost, and I'm going to type in it's going to be eureka.client.register with Eureka as false, because as this is a discovery server, we don't want to register with Eureka, right? Because this is a discovery server itself, we don't want the server to register itself as a client, right? As this is the server, we don't need to register as a client, and that's why we set it as false. And the next thing is eureka.client.fetch registry is also going to be false. Again, because as this is a server, we don't need to fetch the registry of the server because it's already maintains its registry locally. So whenever the client tries to register to the discovery server will send the local copy of its registry, right? The client will store the registry in memory in its own storage. So usually when we are defining the client, we will set the Eureka client fetch registry as true by default. As we are configuring a server, we have to set it as false manually. And the last thing we have to do is we have to define the port on which the discovery server is running. So we are going to define it as server.port is equals to 8761, right? So this is the default port where the Eureka server will run. So that's why I have provided the port as 8761. So now let's go back to the discovery server application and try to run this discovery server. And let's see if it's able to start up without any errors. And you can see that in the logs that we have started the Eureka server and the discovery server application is up and running in 3 seconds, right? So the next thing we have to do is we have to define the Eureka clients. So we have the discovery server. We have to define the Eureka clients. So we have 3 applications: the inventory service, the order service, and the product service, right? So I'm going to open each one of these services one by one, and I'm going to add the dependency for the Eureka clients starter, right? So for that, I'm just going to go to the pom.xml and just copy this dependency, because I just don't want to type this one more time. And I'm going to paste this dependency inside the pom.xml, and I'm going to replace the text Eureka server with Eureka client, right? And the version, we are going to put it directly from the parent pom. So all I have to do is load the Maven changes, and it's trying to download the dependencies from the Maven repository, and you can see that the red text turned to white. That means Maven is able to download the Eureka client starter dependency successfully. Now I can copy this dependency one more time and paste it inside the order service and as well as the product service. So let's do that. I've pasted it inside the order service, and let's open the product service now, and I'm going to again paste this information here. So once the dependency is added, we have to add an annotation on top of each application class of our clients. So I'm going to open the main application class where we have the Spring Boot application annotation. Just below this annotation, I'm going to add enable Eureka client annotation. Similarly, I'm also going to add this annotation also for the order service application class, enable Eureka client. Let's also open the product service application, and I'm going to add the enable Eureka client annotation also here. And now we need to add some configuration in our application.properties file regarding the Eureka client, right? Because as these are Eureka clients, we have to add the properties of the Eureka server. We have to provide the information where we can find the Eureka server. So inside the application.properties of the inventory service, I'm going to just add properties eureka.client.service URL .default zone equals http localhost 8761/Eureka, right? So this is going to be the URL of the Eureka server. So we have to provide it as the default service URL default zone so that our clients can find the Eureka server, right? I'm going to copy this property again to the order service application.properties file and also inside the product service application.properties file. So once this is done, I'm going to restart all the services. So I'm going to open the inventory service application. I'm going to restart the application one, and also for the order service application, I'm going to restart it. And finally, I'm going to open the product service application, and I'm also going to start the product service application. So meanwhile, let's see whether the inventory service application is up and running or not. And we can see that our application is up and running at port 8082. And in here, you can see that our inventory service application is acting as a discovery client, and it's trying to call the discovery server, right? So you can see the log getting all instance registry information from the Eureka server, the response status is 200. That means our client, that's the inventory service application, made request to the discovery server and fetch all the registry at the time of startup, right? And let's see also it's the same for order service application. Yes, it's the same. And also for the product service application, it's not yet done because we just restarted it, because we just started the application, but in some time it should also make a call to the discovery server and fetch all the information about the registry. You can also check the status of our services in a separate Eureka dashboard 8761. Here we can see that we are greeted with a dashboard from Spring Eureka. Here we have the environment as test and the data center as a default, and we have some metadata like the current type and current time and how much time and the uptime, and the renewal threshold and the renews, how many times it has renewed. And here you can see that we have the application as unknown, right? Here the Eureka server identified 3 instances of application, but it has the application name as unknown. This is because we did not define any unique name for our applications, for our order service, the inventory service, and the product service. So that's why our Eureka server is not able to provide any names here. So to be able to fix that, we are going to open I'm going to open the application.properties file, and I'm going to add one more property here called as spring.application.name equals product service. So this is going to be inventory service, right? So it should be inventory service. And similarly, I'm going to copy this property and open the properties file of order service, and I'm going to name it as order service instead of inventory service. And let's open the property file of product service and name this as product service. So after making these changes, let's restart the application. So I'm going to restart the product service application. I'm going to restart the order service. I'm also going to restart the inventory service. So let's see if we are able to see the service name inside the Eureka dashboard. So all the services are restarted successfully. So I'm going to go back to the Eureka dashboard and I'm going to refresh this one more time, and voila, you can see the application names, the inventory service, order service, and the product service. And as I have the Docker environment configured, so that's why we have the host Docker internal. The host name is resolved to as host Docker internal, so that's not a problem. Now, as we saw in the theoretical example, what I'm going to do is I'm going to create multiple instances of the inventory service. Okay, so to do that, I'm going to open IntelliJ, and first of all, instead of running the inventory service on port 8082, if I want to run multiple instances, I don't want to hard code the port number, right? I want to run the inventory service on a random port. So for this reason, I'm going to provide the service.port value as 0. So what Spring Boot will do is, at the time of starting up, it will pick one random free port in your machine and it will run the inventory service application on that port, right? So in this way, no matter how many services we run, it's not a problem. Like, it will try to take a free port and will run the application. So I've changed this to port 0. And what I'm going to do is I'm going to select the inventory service application from the drop down in IntelliJ, and I'm going to click on this inventory service application one more time and click on edit configurations. And inside the edit configurations, I'm going to select this option allow parallel run. So what this will do is it will allow us, IntelliJ will allow us to run multiple instances of the inventory service application, right? So I'm going to click on apply, click on OK. And now I'm going to go to the inventory service application, click on the green button here and click on debug. So now another instance of the inventory service application will be up and running, and you can see that it is running on port, you can find the port somewhere here. So it's running on the port 62170, right? Previously it was running on port 8082. Now this new instance is running on port 62170. right? Let's go to our Eureka dashboard and refresh to check the two instances, and there you can see inventory service, two availability zones. The first one is the service running on 8082 and other one is running on port 0, right? In this way we can display all the instance information in the Eureka service dashboard. Alright, so now I'm going to open the order service, and here you can see that we are still using the hard-coded version of the inventory service details. So now I'm going to replace this localhost 8082 with the name of the inventory service application. So it's going to be inventory-service, right? So I've replaced this with the inventory service. Now let's restart our order service application. So I'm going to go to the services, right click and rerun. Okay, so the order service is restarted successfully. Now let's check whether this order service is configured in Eureka or not. So you can see that the order service is still configured in Eureka, and I'm going to open the Postman client. Usually you have to, I suggest you to wait for 30 seconds whenever you have restarted the service, because it takes some time for the client to register itself in the Eureka server. So that's the reason I usually recommend to wait for 30 seconds before you start to interact with the service. Okay, so now I'm going to open the Postman client and I'm going to send a request to place an order to the order service. Let's click on the send button, and you can see that we are getting a 500 internal server error. So let's open the order service and see what is the error here. It says that failed to resolve inventory service after 9 queries. This is because we have multiple versions of the inventory service, right? So remember, in the theory session, we have multiple instances. Our discovery server will register all the instances and will respond with this particular information whenever order service requests for the inventory service. So in our order service, all this information about the inventory service, right? It has 3 instances of the inventory service. So now it's not understanding, it's confused which instance to call. So in this instance, what it should do is it should go through this list one by one, and it should try to call the instances one by one. So to be able to enable this feature, we have to enable the client-side load balancing in our Eureka clients. So to enable the client-side load balancing, what we have to do is we have to add an annotation when constructing the web client bean, right? So for that, I'm going to open the config package, and I'm going to open the web client config class. And here, instead of creating the bean for web client, what I'm going to do is I'm going to create a bean for web client.builder. I'm going to remove the .build method here, and just below the bean annotation, I'm going to add the load balanced annotation from Spring Cloud Client Load Balancer package. And what this will do is it will add the load balancing, client-side load balancing capabilities to the web client builder. Whenever we are creating an instance of web client using this web client builder, it will automatically create the client-side load balancer, and it will use this client-side load balancing to call the inventory service. So in this way, even though our order service finds multiple instances of the inventory service, like this example, it won't be confused, and it will just try to call this inventory service one after another, right? So let's go back to our web client config class. I'm going to change this web client name to web client builder, and I'm going to open the order service and change the declaration of web client to web client builder, and the reference variable name to web client builder. And now I also have to adapt this web client reference variable name to web client builder dot build, so that we will get instance of web client. And that's all we need to do. So what I'm going to do now is I'm going to restart the order service application, rerun in debug mode. So once the application is restarted, I'm again going to wait for some time, for 30 seconds, before starting to make the request one more time. So now I'm going to open the Postman client, send the request one more time, and now you can see that the order is placed successfully. That means our order service is able to successfully load balance the inventory service instances and made a call to the inventory service. In this way, we can use Eureka server and Eureka client to implement the service discovery pattern. Okay, so now what we are going to do is we are going to do some disruptive tests, like we try to break some things and test how our system will behave, right? We will try to take down the discovery server. So what we are going to do is we are going to try to take down the discovery server. That means I'm going to stop the discovery server and see how our applications and how our services are going to behave, right? So I'm going to open first the Eureka dashboard. You see that it is working fine, so it's up and running, and I'm going to open IntelliJ, go to services, and I'm going to stop the discovery server application, right? So let's open the browser one more time and restart localhost 8761 site portal one more time, and you can see that now the discovery server is down, right? So now let's test whether our order service is still able to find the inventory service or not, right? So I'm going to click on send one more time, and you can see that our order is placed successfully, because if you remember, as part of the theory session, we discussed that while trying to make a call to the discovery server, the client will store a local copy of the registry. Inside the local copy of order service, we have the inventory service information, right? The inventory service is running with port 8082 and it's also running with port 62170. So now what I'm going to do is I'm going to stop these both instances of the inventory service. So I have stopped this instance, and I'm also going to stop the inventory service running on 62170. So again, this instance is stopped. Now I'm going to start this instance one more time, the instance of the inventory service application, and now it should run on a different port than 62170. Yeah, so it's running on 64432, but it's not able to register, it's not able to find the discovery server, so that's why we are receiving some errors, right? Like the transport exception error. So now let's see how our order service will behave, right? I'm going to send the request one more time, and you can see that now we are getting the 500 error. So I'm going to open the order service application logs, and you can see that we are getting again a transport exception because the order service first tried to check for the inventory service in its local copy, and it's not able to reach any of these services, right? So what it did is trying to again contact the discovery server to fetch the registry information, but it found out that the discovery server is not running, and that's why it's throwing an error, right? So now what I'm going to do is again go back to the discovery server application, and I'm going to run this discovery server one more time. So now our discovery server application is up and running. I'm going to go back to the portal one more time, localhost 8761. I'm going to refresh, and now you can see that the dashboard is up and running, but still the services are not registered in the discovery server. So we have to wait for 30 seconds until the services send the next heartbeat to the Eureka server. So let's wait. Yeah, so after waiting for 30 seconds, you can see that our inventory service, order service, and product service are back up one more time. And now I'm going to open the Postman client, and I'm going to click on the send button, and now you can see that the order is placed successfully. So you can see that even though we have taken down the discovery server, the order service is able to call the inventory service because it has stored the local copy of the registry. So this is it for the inventory service. So in the next video, in the next part, we're going to discuss about the next component of the Spring Cloud service, that is the API gateway, right? I will see you in the next video. Until then, happy coding techies. So in this part, we are going to discuss about another component in microservices landscape called as API gateway. So this is how our present architecture looks like, right? Like if the user wants to access the product service, we are now calling some arbitrary port where the product service is running on. So we're making a call to localhost some random port /API/product to access the product service. Similarly, to access the order service, we are calling another port and calling the request and making a request to /API/order. This is fine for a dev environment, but on a productive environment, this will not work, right? As we have already discussed before, the microservices environment can have multiple instances and the application can run on different ports also. right? So for this reason, we cannot rely on hard coding these values when we want to call the services. So the solution for this is to introduce a component at the start of our architecture landscape called as a API gateway, which is responsible to route the request from users to the corresponding services. So let me scroll down, and yeah, this is how it looks like. So we will have an API gateway which acts like an entry point into our system landscape, right? And if the user wants to call the product service, the user just calls the normal API gateway with the normal URL, like it can be onlineshop.com, right? And to be able to call the product service, all we want to do is call onlineshop.com/API/product. And then in our API gateway, we can configure the rules such that if we receive a request with the URL parameter as /API/product, then route it to product service. And if the user wants to call the order service based on the request URL as /API/order, we can route this to order service. And also similarly, if you want to access a discovery server behind the API gateway, we can also configure a rule such that if it contains /Eureka in the URL, then please route this request to the discovery server, right? So this API gateway will, as the name suggests, acts like a gatekeeper to whatever requests which the user wants to make to our services. So not only that, it can also address some additional cross-cutting concerns in the microservice landscape, like authentication. So if you want to make sure that all the requests are authenticated, we can configure that in API gateway. So what API gateway can do is it can contact the authorization server or whatever authentication mechanism you want to implement. So it can also take care of authentication and security. So that's how we're also going to implement in this project. We will make our API gateway talk to the Keycloak authorization server and will implement the security aspects. Apart from that, it can also act as a load balancer. So if we have multiple instances of product service, and if the user makes a request to the product service, it will make sure which instance of the product service to call, and it will retrieve the response from that instance and send it back to the user, right? Apart from that, it also tries to implement the SSL termination. So usually if you are making a call to any external service, sure to include the HTTPS scheme there by following the TLS protocol. So if we call the API gateway from the outside with the TLS scheme with HTTPS protocol, the API gateway, as it's already part of the microservices network, right? We don't need HTTPS here, as this is completely internal communication. So we can just perform HTTP communication without HTTPS. So that's why usually the SSL connection will be terminated at the time of at the entry point of the request, right? So this will be terminated at the API gateway level. This is also implemented for us automatically by all the API gateways. So in the market, we have different kinds of API gateways. We have one popular API gateway called as APG, and the other one is a Kong API gateway. But in this project, we are going to make use of Spring Cloud's own implementation of API gateway called as Spring Cloud Gateway. So now let's go ahead and have a look at how we can implement the API gateway in our project. To understand more details about Spring Cloud Gateway, I'm going to open the Spring Cloud documentation by opening the spring.io project Spring Cloud URL. And in here, I'm going to search for Spring Cloud Gateway. And you can read more about what is Spring Cloud Gateway here. And here, these are some features listed for the Spring Cloud Gateway. It's built on Spring Framework 5, Project Reactor, and Spring Boot 2. So this is a very important thing. It's not built on top of Spring Web MVC, but it's built on top of Spring Web Flux, which is built on top of Project Reactor. And we also have different features to be able to match routes on any request attribute, predicates and filters, which are specific to routes, circuit breaker integration. We will have a look at it in the coming parts. We can also have integration with the Spring Cloud Discovery client, and we can also have the support for request rate limiting and URL path rewriting. Right, we will have a look at some of these features in this tutorial. So to get started, I'm going to open start.spring.io website, and we need to first get some dependency information. So once we get this information, we can create the API gateway for ourselves. So for that, I'm just going to click on add dependencies, and I'm going to search for gateway. So I'm going to select this dependency, I'm going to click on explore, look for the pom.xml, and here I'm going to just copy the dependency information here called as Spring Cloud Starter Gateway. Just make sure to copy this, and now I'm going to open my IntelliJ IDE, and what I'm going to do is I'm going to create a new Maven module under the root Maven project. So I'm going to click on new module and make sure to select the option Maven here and click on next, and I'm going to call this project, this Maven module, as API Gateway. Click on finish, and now inside the pom.xml of API Gateway I'm going to add a new line, and I'm going to type in dependencies, and I'm going to paste in the dependency information from which I copied from the start.spring.io website. I'm going to force Maven to download these dependencies. So for that, I'm just going to click on this load Maven changes button. So IntelliJ will take some time to download the dependencies. So once this is completed, I'm going to open the API Gateway folder. So go to source main Java, and I'm going to create first of all a new package called as com programming techie .api gateway, and I'm also going to create a new class called as API gateway application. So this is going to be a Spring Boot application, and I'm going to again add the public static void main method by typing spring application.run. I'm going to pass in the API gateway application.class name, and finally I'm going to provide the arguments here. So we have added the dependency for API Gateway, we have configured the main application class, and the next thing we are going to do here is to add the dependency for the discovery client, right? Because as our API Gateway is also one of the component inside the microservice landscape, it also register the API Gateway as a discovery client, right? So for that, I'm going to just go open the pom.xml of product service, and I'm just going to copy the dependency information of the Spring Cloud Starter Netflix Eureka client, and I'm going to paste it inside the pom.xml of API Gateway, and make sure to again reload the Maven changes by clicking on the Maven icon. And now I'm going back to the API Gateway application, and I'm going to enable Eureka client annotation so that the Eureka client features will be activated inside our API Gateway. And after that, what I have to do is I'm going to create a new file inside the resources folder called as application.properties. Alright, so in this application.properties file, so first of all I'm going to define the Eureka server URL by typing eureka.client.service URL .default zone equals http localhost 8761/Eureka, right? So this is the service URL for the Eureka server, so that the API Gateway can make a call to this particular URL and register itself as a discovery client, right? And after that, I'm going to type in the spring.application.name property as API Gateway. Just to have some additional information, I'm going to increase the logging level of the API Gateway application. So I'm going to add logging.level.root is equal to info, and I'm going to type in logging.level.org.springframework.cloud.route definition locator. So this is the class which is responsible to define the routes and also identify the routes for the incoming requests. So I'm going to put this logging level information as info, and finally I'm just going to copy all the information here until the cloud.gateway, and for the cloud.gateway package I'm going to define the logging level as trace, right? So by adding this information, we are going to have some more logs, and we can understand what is going on behind the scenes whenever a request is made to the API Gateway, right? And after this configuration, all we have to do now is define the routes So if I open our architecture diagram one more time, whenever the user wants to make a call to the product service, we can make sure we can understand that it should go to the product service by inspecting the URL, right? So if the URL contains /API/product, then we have to route it to product service. Similarly, if the URL contains /API/order, we have to route it to the order service, right? We have doing this based on some certain rules. So we can define these rules inside API gateway as routes, right? If I open the documentation of Spring Cloud Gateway on the learn, and by opening the reference documentation, you can read about Spring Cloud Gateway in much more detail of what I can cover in this tutorial. The glossary section, here you can see how everything works. We have routes, which is like a building block of gateway. So each URL we want to route through the API gateway, we will create a corresponding route. And we can have a predicate as well as a filter. Like a predicate lets you define the matching criteria for all the HTTP requests. And lastly, we also have filters where you can modify the requests which are coming into coming into the API gateway. So we can modify the request as well as the response. That means you can add additional URL parameters, and you can also add some additional headers to the response when we are trying to process the request and response information. So now what we are going to do is we are going to define a route inside our project. So I can define a route. So here what I want to do is I want to define a route for the product service. So I'm going to type a comment called as product service route, and to define the route I'm going to type in spring.cloud.gateway.routes. We can define some list of routes here. So I'm going to create a number of multiple routes. So for that I'm just going to add the index as 0, and for each route I can define an ID, right? So an ID is going to be product service. Usually it would be the name of the name of the service which we are defining. And after the ID, we can also define the URI which we want to map to this particular service. So for this going to be HTTP product service. API gateway also acts like a load balancer. We can also ask API gateway to load balance this request by typing LB. So in this way, the API gateway will also do some client-side load balancing, and it will try to access the available instance of the product service, right? And after this, lastly, we are going to define the map URL parameter which should match this particular service. So for that, I'm going to type in Spring Cloud Gateway.routes of 0 dot predicates. So we can pass multiple predicates to the route. So we're going to define only one predicate. This predicate is going to be a predicate of type path, right? And so I'm going to type path equals /API/product. So whenever we receive a request with path predicate as /API/product, then our API gateway will route this particular request to the product service. So this is what this actual 3 lines means. So in this way, we can also define multiple routes we can also define the route for order service. So for that, I'm just going to copy this whole information one more time. I'm going to paste this and rename the product service route to order service route. And this is a second route we are defining inside our application properties file. So I'm going to change the index 0 to 1. And I'm going to change the ID from product service to order service. Also going to change the URL from our product service to order service. And lastly, I'm also going to change the path from /API/product to /API/order. So if you want to know more information about the kind of predicates we have, you can refer to the documentation section inside the Spring Cloud Gateway. So if I open the route predicate factories section, you can see different kinds of routes. So we can define an after predicate, a before predicate. We can define a predicate based on the cookie if it contains some attribute inside a cookie, and we can also define a predicate based on the method. So if you want to just handle the post request for a particular service, you can also define the predicate as a method here. And we have the path predicate where we have used, so based on the URL path, we are defining the routing scheme. So we have different kinds of routes, so just make sure to check this documentation section if you want to do something differently. So now what I'm going to do is I'm going to open the API Gateway application and let's try to run our API Gateway application. Alright, so we are getting an error whenever when starting up the API Gateway application. It says web server failed to start, port 8080 was already in use. So we are running the product service application on port 8080, and the API Gateway application also uses port 8080 by default. So what I'm going to do now is change the port of the product service. So for that I'm going to open the application.properties file, and in here I'm going to type in server.port equals 0, so that it will take a random port available to the machine. So I'm going to restart the product service, rerun in debug mode, and also start the API Gateway application one more time in the debug mode. So now you can see that the product service application is started on port 61795, and the API Gateway application is able to start successfully on the port 8080. And now let's open our Eureka server and check whether we are able to see this API Gateway in the dashboard or not. So open the Eureka server, localhost 8761, and I'm going to refresh the dashboard, and you can see the API Gateway is registered in our Eureka server as a client. So that's perfect. So what I'm going to do now is make a request to the product service through the API Gateway. So for that I'm going to type in http localhost 8080/API/product, and I'm going to make a GET request. So I'm just going to click on send, and you can see that we are receiving the response back from the product service. So it's not like the product service is running on port 8080, it's running on port 61795. So let's test whether the product service is really running on the 61795 port or not. So I'm just going to copy this URL, create a new tab, and change the port from 61795 from 8080 to 61795, and make a request one more time, and you can see that we are still getting the response. So that means the request went through to the API Gateway and reached the product service. So we can also verify this inside the logs. So I'm going to open the logs and of the API Gateway application, and if you just scroll down, you can see some detailed information about the logs. So we can see that the pattern API/product matches against value API product, that means which is defined for the product service. And you can see that in the log says the route matched is for product service. It's trying to make a GET call to this product service. You can see much more information about the logs, how it is matched, how the routes are matched, and you can get a good good idea of how the API Gateway is working behind the scenes by enabling the logs, right? So let's also test whether the API Gateway is working fine for the order service or not. So I'm going to open a new tab, change the HTTP method to post, and I'm going to type in HTTP localhost 8080/API/order, and I'm going to just paste the request body which I've used before. And now I'm going to click on send, and you can see that we received the response, order placed successfully. So I'm going to open the API Gateway one more time, and here you can see that we see the logs that a route is matched for the order service, and it's trying to make a post call to the /API/order endpoint. So in this way we can define the routes inside the API Gateway. So in the next section what we are going to do is we are going to also access the Eureka server. So to access the Eureka server, right now we are going to the localhost 8761 port. So what I'm going to do now is also try to access the Eureka server through the API Gateway, right? So for that, what I can do is I can open the application.properties file of API Gateway, and I can define another route for the discovery server. So I'm going to copy this route information one more time and change the comment as discovery server route, and the ID I'm going to define as discovery server. And for the discovery server, I'm going to define the URL as localhost 8761, and the path is going to be not /API/order, but I'm going to access the Eureka server in a path /Eureka/web, right? As of now, we are calling 8761 without any additional URL parameters. So what I'm going to do now is I want to access Eureka server at http localhost 8080/Eureka/web, right? Whenever I call this particular URL, I want my request to be routed to the Eureka server, right? So that's why I added the path predicate as /Eureka/web. I'm going to also change the index to 2 instead of 1. Right, so now I'm going to restart the API gateway application. So I'm going to now rerun API gateway application, and so our API gateway is restarted successfully. So now I'm going to open the browser, and now I'm going to type in localhost 8080/Eureka/web, and I'm going to, if I press enter, we are getting a 503 error. This is because what our API gateway is trying to do is it's trying to call localhost 8761/Eureka/web, but there is no route in the Eureka server for the path Eureka/Eureka/web, right? So what the API gateway is trying to do is it's trying to pass in these URL parameters also to the Eureka server, right? As there is no route for Eureka server for this Eureka/web, we are getting a 503 error, right? So what our API gateway should ideally do is whenever it receives a request at localhost 8080/Eureka/web, it should call the Eureka server at localhost 8761, right? It should make a call without the URL parameters, right? So how can we do that? So previously I mentioned that we can modify the requests in our API gateway with the use of filters, right? So we can make use of filters to actually remove the URL parameter, and you can change the path of the path of our request, right? So let's do that. I'm going to open the application.properties one more time. So what I'm going to do is I'm going to define a filter for this particular route. So for that I'm going to type in Spring Cloud Gateway .routes of 2 .filters. So I'm going to define a filter. So this filter is going to be called as set path, and the set path, as the name suggests, it will try to change the path of the URL request, so path of the URL. So instead of /Eureka/web, I'm going to define the URL path as just /, right? So whenever we make a call to the API gateway with /Eureka/web, it will just forward this request to HTTP localhost 8761 without any URL parameters. So after we have defined this filter, I'm going to again restart the application. So after the application gateway, after the API gateway is restarted, I'm going to open the browser one more time, and now I'm going to type in /8080/Eureka/web. Okay, so we are still getting the 503 error. So let's open the logs and check what may be the reason here. So if you see that we have, so if you observe the logs, that the discovery server route definition is matched successfully, but you can see that inside the round robin load balancer class, it says that no servers available for service localhost, right? Because as we only have one instance of the discovery server, it's not able to actually load balance the request to the discovery server. Yes, because as we have defined the text LB, we wanted to also load balance the request to the discovery server. This is not working as there is only one instance. So here what I can do is, instead of putting LB, I can put it back as HTTP, and let's try to check if it is working fine or not. So I'm just going to restart the API gateway one more time, rerun in the debug mode, and let's now test whether this is working fine or not. So now if I open the browser and go to localhost 8080/Eureka/web, you can see that we are able to access the Eureka server through the API gateway, but we are getting a plain HTML instead of the CSS and the other static resources, because we defined the route only for the Eureka server but not the static web resources, right? It should not only load the HTML but also some other static resources like CSS and JavaScript files. So for that we have to define another route for the Eureka server just for the static resources, right? So what I'm going to do is I'm going to copy this route one more time, and I'm going to define this route as discovery server static resources route, right? So I'm going to change the index from 2 to 3 and change the ID as discovery server static. And here I don't need the filter anymore, but instead of the path /Eureka/web, what I can do is I can just add double stars. So whatever request which is made from the path /Eureka/star, it will be routed to the discovery server. So whatever request we make on the path /Eureka/star, it will be routed to the discovery server, right? So I'm just going to again restart the API gateway application, and once the API gateway is up and running, I'm going to open the web browser one more time and I'm going to refresh, and now you can see that the CSS is able to load successfully, and we are able to access also the discovery server through the API gateway. That's it from this tutorial, guys, and in the next part we are going to secure our microservices by using Keycloak. So we are going to implement the security through the API gateway. So I will see you in the next video. Until then, happy coding techies. So now let's talk about securing our microservices architecture. We have an API gateway in place, and we also have our services, the product service, order service, and the inventory services. So now what we want to do is we want to secure the services. As of now, you can access any of the services, any of the API endpoints without any authentication. We would like to introduce this authentication some kind of authentication mechanism to be able to access the service endpoints, right? So for that we are going to make use of an authorization server called as Keycloak. So using Keycloak we can outsource our authentication and authorization related configurations to Keycloak, and we don't need to implement the authentication mechanism by hand in our microservices. So before going ahead and learning more about how to configure Keycloak in our project, I would like to recommend you to watch the Spring Security Auth to Keycloak video before going ahead, because I've explained all the OAuth 2 related concepts in that video, and I'm not going to repeat those concepts one more time. So now let's go ahead and install Keycloak in our machine. So for that I opened the keycloak.org website, and in here I'm going to click on the section guides, and I'm going to, in the getting started section, I'm going to click on Docker. So we're going to mainly use a Docker image to run Keycloak. I'm not going to install this manually. So I'm just going to copy the docker run command here, and I'm going to open my IDE and open the terminal section. You can also run it on your terminal. I'm going to copy this command, docker run command, where we are running the Keycloak image on port 8080, and we are exposing the port 8080 from the container, and we are providing the environment variables Keycloak admin user as admin, admin password as admin, followed by the image name. So this is the kwai.io Keycloak 18.0. This is the image name, and we are running on a dev profile. So that's why we have the start dev command here. Before running this command, I'm going to make a small change here. Keycloak is by default running on port 8080 inside the container. We want to access this Keycloak not on port 8080 on our host machine, but on a different port, because on port 8080 we have our API gateway running, right? So for this reason I'm going to change the port 8080 to 8181. so that we can access the Keycloak on port 8181. And finally, I'm going to press enter. What this will do is it will first check whether the Keycloak image is present in your Docker registry or not. If not, it will first try to download the Docker image, and after that it will start the container. So once the Keycloak server is up and running, I'm going to open the browser and go to the URL http localhost 8181. So this will open Keycloak in our browser. So what I'm going to do is I'm going to click on the administration console link. This will take us to a login page. Here I'm going to type in the username and password we have provided while running the container. So that would be admin and admin. So here we are taken to the homepage of Keycloak, and in Keycloak we have some concept called as realm, where you can group all your clients, your OAuth clients, into a single logical entity called as a realm. So by default, Keycloak provides us a master realm, and we can also create our own realm. So what I'm going to do is I'm going to click on add realm, and I'm going to provide the realm name as Spring Boot microservices realm, and I'm going to click on OK. And in this realm we can create our clients, our OAuth 2 clients. So for that I'm going to click on the clients section here, and I'm going to click on the create button. And in here I'm going to provide client ID as Spring Cloud client, and I'm going to click on save. This will take us to a another screen where we have many fields, and in here we can configure what kind of client we can have. So by default we can have different kinds of client. We can have a client, we can have a public client, we can have a confidential client, we can have a bearer only client. So for this project we are going to select the confidential client, because as we are not going to make use of any websites to make the authentication, we are going to call the services through Postman client. So for that it's enough to select the access type as confidential. Again, if you're feeling lost, have a look at my Spring Security OAuth through Keycloak video. I've explained all these details: what is an access type, what is a client, what is a resource. All the concepts I've explained in that video in detail. So I've selected the access type as confidential, and here we have one option called as standard flow enable. I'm going to disable this option. I'm also going to disable the direct access granted enabled option, and I'm going to select the service accounts enabled option. So what this will do is it will enable the client credentials grant, and after enabling this I'm just going to click on save. This will create a client secret. We can see the client secret by going to the credentials tab, and I can just copy this client secret and I can come back to this client secret whenever I want to authenticate using this client secret. So after configuring Keycloak, what we have to do is we have to provide the URL of Keycloak in our API gateway. So for that I'm going to go to the realm settings and click on OpenID configuration, and in here I'm going to copy the issuer ID, the object of type issuer. So this would be http localhost 8181/realms/springboot microservice realm, right? I'm going to copy this URL, and I have to provide this URL inside our API gateway, because we are going to configure our API gateway to talk to the Keycloak server, right, as we have discussed before. So the next step is to configure our API gateway as a Spring OAuth 2 resource server, and to also enable the Spring Security so that we can configure the API gateway with Keycloak details. So for that I'm going to open the pom.xml of my API gateway project, and just below the dependency of Spring Cloud Starter Netflix Eureka client, I'm going to add another dependency with the group ID as org springframework.boot, and the artifact ID is going to be Spring Boot Starter OAuth 2 resource server, and I'm going to remove the version tag because I want the same version as the parent. I'm going to copy this dependency one more time and change the artifact ID from Spring Boot Starter OAuth 2 resource server to Spring Boot Starter Security. And to enable IntelliJ to download the Maven dependencies, I'm going to click on this Maven icon, and once the dependencies are downloaded, you're all set to go ahead and configure the issuer URI in your API gateway application. So for that, I'm going to open source main resources application.properties file, and below the routes configuration, I'm going to type in spring.security auth 2 resource server.jwt.issuer URI. Right, and this issuer URI we have copied previously from the discovery document. So from this URL, this Spring Boot microservices realm well-known OpenID configuration, from there I'm just going to copy this issuer URI and I'm going to paste it in here. Just a small overview of how this will work. Spring Boot at the time of starting up the application will read the discovery document, and from this discovery document it will fetch all the endpoints to authorize to all the endpoints to do the authorization. So we have this authorization endpoint as Spring Boot microservices realm protocol OpenID connect auth, and we have a token endpoint where Spring Boot can make a call to this particular endpoint and verify whether a token is valid or not. So instead of configuring all these values in our application.properties, what we can do is we can just configure the issuer URI, and Spring Boot will do the work behind the scenes for us by reading the OpenID configuration and will receive all the information it needs. So the next thing I'm going to do is to create a security configuration class inside our API gateway. So I'm going to click on new class, and instead of creating a package, I will type in the package name as config.securityconfig. This is one of the shortcuts which was suggested to me by one of the subscribers. So thanks for the hint. Always nice to learn new shortcuts. So once we have created the security config class, I'm going to add the configuration annotation, and we want to enable the web security for the WebFlux project, right? So for that, I'm going to type in enable WebFlux security. So we have added enable WebFlux security. This is because we are, if you remember, the API gateway, Spring Cloud Gateway project is based on Spring WebFlux project, but not Spring Web MVC. So that's why we need the enable WebFlux security annotation here. So the next thing I'm going to do is to create a bean inside the security configuration class called as Spring Security Filter Chain. So for that, I'm going to create a bean. And this bean is going to be of type Spring Security Web Filter Chain, and I'm going to type in Spring Security Filter Chain, and this method is going to take a method parameter of type server HTTP security, and inside this method now we have to configure the WebFlux security details. So for that, I'm going to what I'm going to do is I'm going to first disable CSRF, because as we are only communicating through the REST API, through the Postman client. So I'm going to disable the CSRF here, and I'm going to add some exchange information here by typing authorize exchange. The second option where I can provide the exchange information. So I'm going to type in exchange and create a lambda, and in here I'm going to provide some more details of how WebFlux should handle the security. So first of all, I'm going to add some path matchers here. So the path matchers is going to be for the path Eureka/star. So if you remember in the last tutorial, we have created for the route configuration for the Eureka discovery static resources. So whenever we are accessing the static resources, we want these calls to be not authenticated, right? So whenever we're retrieving the CSS and JavaScript files, we don't want to send some kind of token with it, right? So for that, we need to exclude this call from our security configuration. So that's why we are adding the path matchers to this is URL pattern, and we are going to permit all the calls to this URL pattern by typing .permit all. And after that, for any access, we want all the calls to be authenticated, right? For only the Eureka static resources, we want to permit all the calls, but any other calls, we want to make sure that those are authenticated, right? And after adding this information, we are also going to enable the resource server capabilities in our API gateway. So I'm going to type .auth2 resource server, And this resource server capabilities, we also need to enable the JSON Web Token capabilities. So for that, I'm going to type in server HTTP security dot OAuth to resource server spec, and in here I'm going to access the method JWT from this class. So for that, I'm going to make use of Java 8 method reference. So I'm going to type 2 colons and then select the method JWT in here. And after that, I'm going to type in server HTTP security dot build, so that this will create an object of type security web filter chain, because this is what we are expecting out of this method. And finally, I'm also going to add the return statement to this method. So now we have enabled security configuration in our API gateway, and we have also configured our API gateway to talk to the Keycloak to authorization server. So as you may observe, this is very simple to configure the gateway to talk to the Keycloak. Just need to add the dependency for the resource server, and you need to add a property file for the issuer URI, and everything will happen in the background. All our routes will be protected by Spring Security along with Keycloak. So let's test whether all the endpoints are really secured or not. So for that, I just restarted the API Gateway application. You also make sure to restart the application before the test. So I'm going to open the Postman client. I'm going to create a new tab, and I'm going to test whether the product service is still accessible or not. So I'm going to type in localhost 8080/API/order. So I'm going to select the HTTP method as get, and I'm going to click on the send button. And now you can see that we are getting a 401 unauthorized error, right? Because we didn't provide any authentication details. So in this case, we have to provide a bearer token, a JWT token. So for that, what we have to do is we have to create the token. We have to request the token first of all from Keycloak by providing our credentials, and then we have to provide those credentials to the API gateway through the authorization header in the type of bearer scheme, right? So for that, I can click on the authorization tab, and in Postman we have a nice functionality to directly contact Keycloak and get the token. So for that, in the authorization type, I'm going to click on the drop down menu, and I'm going to select the type as OAuth 2.0. And in here we can provide the information about our Keycloak client we have configured a while ago. So in the configurations options, we can provide a name, any name for the token you are going to create. The grant type I'm going to select as client credentials, because the client's credentials is the correct grant type whenever we want to have a machine-to-machine communication. And in the access token URL, we have to provide the endpoint of the token endpoint, which we have seen in the discovery document. So I'm going to open this one more time. And yeah, so if you remember, we have opened this OpenID configuration URL, and in here I'm just going to copy the value for the token endpoint, which is HTTP localhost 8181/realms Spring Boot microservices realm /protocol /OpenID connect/token, right? So I'm going to just copy this and paste it in the section of access token URL. So I'm going to just paste it again, and the client ID, I'm going to provide it as the client ID we have created. And the client secret, I'm also going to provide the client secret, which I will get from my Keycloak realm. So let me open the Keycloak portal one more time. So I have to log into my Keycloak account one more time. So let me log in with the credentials admin. And now once I'm logged into the Keycloak, make sure that I'm in the microservices realm, Spring Boot microservices realm, which I've created before. And I'm going to click on clients and click on Spring Cloud Client. And here I'm going to open credentials, and then you just have to copy this secret what you have here, right? So I'm going to copy this secret and I'm going to paste it inside my client secret section. The scope, you can just leave it as it is, the default as OpenID and offline access. And the client authentication also you can leave it as send as basic auth header. And now after configuring all these details, you can click on get new access token, and you can see a message called as authentication complete. And once the authentication is completed, what Postman is going to do is going to request Keycloak for the access token. And here you can see this is the access token which we received as a response from Keycloak. right? So I can now click on use token, and this token will be used now whenever we are making a call to our microservices. So when I click on the send button, now you can see that we are getting 405 method not allowed error. Yeah, this is because I'm trying to access the order service, but I want to access the product service to get the product information. So let me change the URL and click on the send button one more time. And now you can see that we are getting the response back from our product service, and we are able to access this through our API gateway, right? So in this way we can secure our API gateway. So let's also do the test for the placing an order. So I'm going to change the URL as http localhost 8080 API and order. I'm going to select the HTTP method as post. I'm going to create the same body as I've created before, and in the authorization tab I'm going to select the token which I've created in this call, right? So for that I can just select the type as OAuth 2.0 one more time, and I can select the token. Here in the available tokens I can click on manage tokens, and I can select this token and click on the use token button so that we can use that particular token when making this call. So I'm going to click on the send button now, and now you can see that we are getting the order placed successfully as the response. That's perfect. So both our product service and order service are now accessible through Keycloak. So the next thing we are going to do is to try to access Eureka from the browser. So, and let's see how is this going to behave, right? So I'm going to create a new browser tab, and I'm going to type in http localhost 8080/eureka/web. You can see that we are getting a 401 error. So to fix this, we have to enable some kind of authentication also on our discovery server. So we cannot use the authentication mechanism with the token because, as you may have already observed, previously we are trying to contact our product service and the order service through the Postman client. Now we have to contact the Eureka discovery server through the browser, right? We cannot send the token, we cannot change the request through the browser and send the token manually, right? So for this we need to enable basic auth in discovery server so that we can provide the username and password while accessing this discovery server URL. So for that I'm going to open my IDE, and I'm going to go to the discovery server pom.xml, and I'm going to add the dependency with group ID org spring framework.boot, and here for the artifact ID I'm going to type in spring boot starter security. Similar to the previous dependencies, I'm going to remove the version because I want to download it from the parent. Let's force IntelliJ to download the dependencies by clicking on the Maven icon. And now finally I can create the security config class inside our discovery server. So for that I'm going to open source main java, and I'm going to create the security config class by typing config.security_config. Now I'm going to add the configuration and enable web security annotation on top of the security config class, and the security config class is going to extend the web security configurer adapter class because now we are using Spring MVC. So for Spring MVC security we can make use of web security configurer adapter class instead of the classes from webflux. So this class now should override a method called as configure. So I'm going to type in override public void configure, and this is going to take a method parameter of type authentication manager builder. Let's also create the reference variable of this authentication manager builder, and inside this authentication manager, and inside this method I'm going to type in authentication manager builder dot in memory authentication with user as Eureka, and dot password as password, and I'm going to add a basic authorities called as user. So we are just going to rely on the in-memory authentication for the discovery server. So that's why I added the in-memory authentication scheme. We have an error here because this method is going to throw a exception. So let's add this exception to the method signature. So now we have a basic auth created in our security config. So let's add some additional configuration to our class. So by overriding another configure method, so I'm going to type in @override public void configure, and this time I'm going to add the method parameter as HTTP security. And inside this configure method, I'm going to configure a basic security, a default security details like HTTP security.csrf.disable and authorize requests.any request and authenticated. And lastly, I'm going to add the HTTP basic authentication, because enable the HTTP basic auth. And also the CSRF method is going to throw an exception. Let's add this exception to the method signature. And now we have a basic security configuration with basic auth enabled. And this basic auth, we are going to rely on the in-memory authentication, right? And one thing I don't like here is we are trying to hard code this username and password inside our code. So what we can do is we can externalize these properties to the properties file. So what I'm going to do is I'm going to open the resources application.properties, and I'm going to type create two properties called as eureka.username. It's going to be Eureka, and eureka.password is going to be password, right? I can also try to generalize this a bit more, and I can try to access this Eureka username and try to send this Eureka username and password through the environment variables. So for that I can type $Eureka_username is going to be username, $Eureka_password. So in this way, if we have configured the Eureka username and password as environment variables, we can just pass it while running the discovery server, and this will be picked up at the time of startup. And now inside the security config class, I'm just going to remove this Eureka and password, the hard-coded strings, and I'm going to make use of the values which we have configured in the properties file. So for that, I can use the value annotation to read these properties. So I'm going to type in $Eureka.username, and this is going to be stored inside a variable called as username. And again, I'm going to copy this full configuration to the next line and define the field for the password called as Eureka.password, and I'm going to rename this variable as password. Let's use this username and password inside the in-memory authentication configuration. So for the with user method, I'm going to provide the username, and for password method, I'm going to provide the password field as a method parameter. So, and lastly, we also have to define a password encoder whenever we want to define a username and password. So for that, after the in-memory authentication method, I can type in with .password encoder. And for this case, for this use case, I'm going to go with the no-op password encoder. No-op password encoder. This is deprecated, but just to make the demo purpose easier, I'm going to make use of no-op password encoder. But in the production, you have to not use this no-op password encoder. As this is for demo purposes, I'm using this, but I strongly suggest you to use a password encoder like a bcrypt password encoder or some other strong password encoders in your production code. Please don't use this, because I'm not using bcrypt password encoder because this needs some more configuration in the project, and that feels like diverting the actual goal of this project, because I want to show you how the microservices project works together, and I don't want to go in more depth than what I'm covering. So that's why I'm not covering how to configure bcrypt password encoder here, but I will leave a link down in the description if you're interested how to configure bcrypt password encoder. I will leave a blog link where I found, so that you can have a look at it and understand how to configure bcrypt password encoder. So moving ahead, I'm going to create the no-op password encoder, and I'm going to type the method .getInstance, so that we will get a basic no-op password encoder. So this is nothing but your password will not be encoded, it will just be displayed in plain text, right? So that's why this is not recommended, but for demo purposes, as I said before, I'm going to use this. So let's move forward. What I'm going to do now is restart the Discovery Server application. So now let's open the Discovery Server application. So I'm going to rerun my application in debug mode, and now I'm also going to, so once this is up and running, so without any errors, yes, it's able to start without any errors, I'm going to restart all my other services, thus all applications and the API gateway application in debug mode one more time. Order service, for example, is not able to reach the Discovery Server because we have enabled authentication. So what we have to do is we have to provide the username and password inside the Discovery Server URL, right? So for example, if I open the application.properties of API gateway, we have our Eureka client service URL default zone, and this is pointing to the URL of Eureka dashboard. So what I'm going to do here is I'm going to add the username and password information as part of the URL. So I'm going to type in Eureka password at localhost 8761/Eureka. Right? So this is similar to the JDBC URL scheme, providing the username and password as part of the URL. So I'm going to add the same configuration also to our other services. So let's copy the whole property key value pair and replace it in all our services. So I'm going to open our inventory service, application.properties, replace this property. And similarly, I'm going to do this for order service and as well as the product service. So now I've configured the URL in all our services. So let's try to restart all our services and see whether we are able to start these services without any errors. Alright, so now you can see the order service is started without any errors. That means our order service is able to access the Discovery Server through the basic auth scheme. That's very good. So now let's try to access HTTP localhost 8761, and you can see that it is prompting us for the username and password. So let's try to type Eureka and password as our credentials and sign in. And now you can see that we are able to access our Discovery Server through the basic auth. And here you can also see that our dashboard is showing us all our services as we are expecting. So that's it for this part, guys. So in the next part, I'm going to discuss about the next component in our microservices called as circuit breaker, and we are also going to integrate the OpenFind client. We are going to replace the web client with OpenFind client. So I will see you in the next part, and until then, happy coding techies. So in the previous video, we saw how to secure our microservices using the Keycloak authorization server. So now let's continue our project by introducing another component called as circuit breaker. So a circuit breaker is mainly used when we want to have a resilient communication between our services. So if you remember, we have our order service and the inventory service, and we are calling the inventory service from our order service using the web client, which is like asynchronous communication. So the problem with the synchronous communication is like we can have many problems while calling the inventory service from the order service. So one of the problems is like the inventory service may be not available, it may be down. That is one problem. And the other problem is like this calls we are making from our order service, like for some reason the inventory service may respond slowly to the order service, right? So by design, the remote service calls can be slow. So if something goes wrong in the inventory service, like if due to a performance issue or database issue, we can expect slow API calls while calling the inventory service, right? So when we face these kinds of problems in a microservice environment, we have to make sure that our system is resilient. We don't want the request to terminate abruptly, right? We have to fail fast, and we have to provide some kind of resiliency to these kinds of issues. So this circuit breaker pattern is nothing but a set of states we maintain in our application. So let me scroll down and open this flow diagram, right? So by default, if the communication between the services is working fine, that means if we don't find any issues, the state of the circuit breaker will be in a closed state, right? So if a circuit breaker is in closed states, communication will be allowed as it is. And imagine that if our inventory service is not working as expected due to maybe temporary network issues or something, what will happen is the circuit breaker will go to a state of open. So in the open state, what will happen is, as we already know that the calls to inventory service is not working, it doesn't make any sense to keep on calling this inventory service, right? So until and unless the issue is solved, it doesn't make any sense to keep calling the inventory service like in the above example. For this reason, the circuit breaker will change to a state of open. That means it won't allow the calls from our order service to the inventory service anymore. Right? So it will not allow it for the certain number of time, for the certain number of duration. We can configure it ourselves. So during this period, either it can just throw the error message or it can also execute some fallback logic. Right? So for example, if the inventory service is not available, what we can do is we can cache the response from the inventory service and we can just use the cache, right? Maybe this is not a good idea, this is not a good example, but we can maybe try to execute some fallback logic, right? If the inventory is not available, maybe, I don't know, like we can try to execute some fallback logic, and we can execute this with the help of circuit breaker when the state is in open. When the state is in open, after a certain number of after a certain duration, the circuit breaker will change the status into half open. That means it will slowly start taking the request from to the inventory service, and it will check whether the requests are going through or not. Right? If the requests are still not going through, it will change the status to open. That means it will not allow the calls and it will just execute the fallback logic. Right? And if the requests are executed successfully, then it will change the status of the circuit breaker back to closed. So this loop will be followed like whenever we are making the calls to the inventory service from our order service. So as you saw this theory, now let's go ahead and implement this circuit breaker logic in our project. So to implement this logic, we don't need to write the logic ourselves. We have a library called as Resilience4j, which will help us with the circuit breaker logic. So I can open the website of the Resilience4j. So this is a lightweight, easy to use fault tolerance library, which is inspired mainly by Netflix Hystrix. If you are aware of the microservices landscape, we used to mainly use Hystrix as the fault tolerance library. So Resilience4j is mainly like a newer alternative to Netflix Hystrix, right? So we can make use of this library in our project by using a Spring Cloud project called as Spring Cloud Circuit Breaker. We'll be mainly using this project to implement the fault tolerance using the Resilience4j. So if you see, Spring Cloud Circuit Breaker can have multiple implementations. One is with the Netflix Hystrix, Resilience4j, Sentinel, and Spring Retry. We'll be mainly using Resilience4j in our project. So I'm inside the IDE and I'm going to open the order service, as we are going to mainly implement the circuit breaker pattern inside the order service. So for this, I'm going to first add a dependency called as Spring Cloud Circuit Breaker. So for that, I'm just going to add another dependency just below the Spring Cloud Starter Netflix Eureka Client dependency. I'm just going to copy this dependency and change the artifact ID to Spring Cloud Starter Circuit Breaker Resilience4j, as we'll be mainly using Resilience4j here. And after that, we also need another dependency called as Spring Boot Starter Actuator. So for that, I'm just going to change the artifact ID to Spring Boot Starter Actuator, and also the group ID to Org Spring Framework Cloud to Org Spring Framework Boot. And yeah, so once I added this artifact ID in the group ID, the Maven dependencies will be downloaded by clicking on the Maven icon if you are using IntelliJ. So once we have added these two dependencies, we can go ahead and configure Resilience4j in our project. So I'm going to open source main resources application.properties, and the first thing I'm going to do here is first to enable actuator, right? So using actuator, we can have a look at different kinds of health metrics for our application. So for that, I'm going to type in management.health.circuitBreakerEnabled equals true. So first I'm going to enable the circuit breakers endpoints in the actuator, and after that I'm also going to type in management.endpoints.web.exposure.include, right? So for this, I'm going to type star so that our actuator will expose all kinds of endpoints. By default, it will only expose the health metrics endpoints. So I want all the endpoints to be enabled to us, right? So for that, I've just provided the value star here. And I'm also going to type in management.endpoint.health.show details. So the health show details property is by default set to never. So we're going to always show the complete health details of our application. So that's why we're going to use this configuration. And now we can go ahead and define the resilience 4J properties. So for that, I'm going to type resilience 4J properties. And for these properties, I'm just going to copy and paste some properties so that you don't watch me type all these properties. I will just explain what are these properties and why we have to use these properties, right? So the first property is called as resilience 4J circuit breaker instances inventory and register health indicator, right? We want to register a health indicator so that we want to see the different states of circuit breaker. We have mentioned before, right? The circuit breaker maintains different kinds of states: closed, open, and half open. So to be able to see those states, we have to first register the health indicator for our resilience 4J library. So that's why we provided this property as true. Then after that, we also have to provide an event consumer buffer size as 10. So that means how much buffer size it is going to take for the events. We have to provide it as 10. And after that, what our circuit breaker will do is it will make sure that it won't open the circuit breaker right away, right? So if resilience 4J understands that a call to the inventory service is failing, it won't change the state from close to open right away, right? It will wait for some number of requests to fail. Like for example, if only 5 requests are failing, if only 5 back-to-back requests are failing, then only we will change the state from close to open. Right? So to be able to count this number of requests, we have to provide the sliding window type as count based. Right? So resilience 4J will use a sliding window algorithm to be able to determine when to close and open the state of the circuit breaker. So for this, we have to provide the sliding window type as count based. Right? And the sliding window size as 5. That means after 5 failed requests, the circuit breaker will try to change from the closed to the open state. And the failure rate threshold will be 50%. That means when the 50% of the calls are like failed, then the rate threshold, we are setting it as 50%. And after that, we will also configure how much time we can wait in the open state, right? Before going to the half open state, we don't want to allow all the calls. We have to execute the fallback logic. So for this, we can configure the resilience 4J to wait for 5 seconds in the open state before changing to the half open state, right? So the next property is permitted number of calls in half open state, right? How many calls we have to allow in the half open state so that resilience 4J can check whether the communication between our order service and inventory service is working fine or not. So this is going to be 3 calls. We will allow only 3 calls in the half open state. If the communication is still failing, then resilience 4J will change the status to the open, right? Like how we see here, when the circuit breaker understands that 3 calls are failing, then it will change the status to the. So, and lastly, we are also going to configure the property automatic transition from open to half open enabled. It's true. So we want to automatically transition, like enable the transition between open to half open. After adding all these properties, this is the only thing we have to do after configuring these properties. Next, what we can do is we can configure our code to make use of this circuit breaker. So we'll see how to do that next. All right. So to add the circuit breaker logic to our code, I'm going to open the order controller. This is the place where everything starts, right? Whenever we are trying to place the order, the request goes to the place order method inside the order service, and inside the order service we are actually making the call to the inventory service here, right? We can also add the circuit breaker logic inside the order service, but just for my convenience I'm adding it to the order controller, right? So about the place order method, I'm going to type annotation called as circuit breaker. And to this circuit breaker annotation, I'm going to provide an attribute called as name. So this name, I'm going to provide it as inventory, right? So what this will do is resilience 4J will apply the circuit breaker logic to this particular place order method, like whatever calls, whatever API calls which are being made inside this place order method call, it will apply the circuit breaker pattern here, right? So this is all you need to do to implement the circuit breaker pattern in your project. So one thing we also understood is we want to also implement a fallback logic whenever the calls are failing, right? Whenever the circuit breaker is in the state of open. So for this reason, as a fallback logic, what we can do is we can provide a fallback method to the circuit breaker annotation, so that whenever the circuit breaker understands that they are failed calls, it will just execute the fallback method, right? So for this, I'm just going to add another attribute inside the annotation called as fallback method, and here we have to provide the name of the fallback method. So for this, I'm going to provide the name as fallback method, and what I'm going to do is I'm going to create another method with return type as string, because we need to have the same return type as the original method, and I'm going to provide the name as fallback method, and I'm also going to make use of the same method signature. We'll take an order request, and additional to that, we also have to add another method parameter called as runtime exception, because whatever exception is raised from this particular method, from the place order method, we will also consume this exception into the fallback method. So in here, I'm going to return a status message, something like, oops, something went wrong, please order after some time, right? We are going to provide this particular error message. So instead of showing something called as a runtime exception, or maybe timeout, or HTTP status failed, some exception, we can just provide a good error message to the user. So this fallback method will be executed by the circuit breaker. So now it's time to test our implementation, whether the circuit breaker is working fine or not. So for that, I'm just going to start all my services. Also make sure you start all services, and let's start testing in the next step. So all my services are up and running. I'm just verifying everything is fine or not in the Eureka portal. So everything is working fine. So now I'm going to open Postman, make a call to the order service, and let's see what will be the response. I'm just going to first make sure that I have a valid access token. So I'm just going to click on get new access token and click on proceed, click on use token, and I'm going to send this request. And you can see that we have received the status as order placed successfully, right? This is perfect. So now what I'm going to do is I'm going to stop the inventory service, right? Just before stopping the inventory service, I'm just also going to show you the status of actuator by typing localhost 8081/actuator/health. And here you can see that we have the information about the circuit breakers, and the circuit breaker state is closed. So I'm going to go back to my IDE, and I'm going to stop the inventory service. So the inventory service is now stopped, and let's try to make a call to the order API one more time. So I'm going to send the request to the order API one more time, and you can see that we have received the fallback error message, and I'm going to first check the actuator health. So actuator endpoint, I'm going to refresh, and you can see that the state is still closed. So I'm going to execute this command one more time, execute this API call 4 more times. 1, 2, 3, 4, 5, right? We have executed 5 times, and quickly I'm just going to refresh, and you can see that our circuit breaker is already changed to the state of off open, right? So the circuit breaker will stay in open state only for some time, like we have configured to stay in open state for how much time? So it's for 5 seconds, right? I think we are too late. After 5 seconds, it's changed the state of the circuit breaker from open to half open, right? And now you can see that now let's start the inventory service, And after starting the inventory service, once it is up and running, just make sure to leave the inventory service for 30 seconds because it will take 30 seconds to register the inventory service back with the Eureka server. So I'm just going to leave this inventory service for 30 seconds so that it will warm up and just send the request to the Eureka server. And after 30 seconds, let's try to request the order endpoint one more time. Okay, after 30 seconds, I started placing the calls again, and now you can see that we have received the response order placed successfully. And if I open the health endpoint and refresh, you can see that the status is still in half open. Now let's try to make some more calls to place the order. And you can see that we have made more than 3 calls here. So now let's see whether the status is changed to closed or not. And you can see that the status is changed from half open to closed. Right. So in this way, we can implement the Resilience 4J in our library and the circuit breaker design pattern in our project. Alright, so now let's go ahead and implement some advanced use cases. Now we saw how our Resilience 4J library will handle requests when the inventory service is not up and running, right? When the inventory service is down. So now let's also try to simulate the slow network connection case, right? So imagine that our order service is calling the inventory service, and for some reason the inventory service is not communicating, like not responding in time, right? Maybe it's slow due to a database performance issue. So how will Resilience 4J can handle this situation? We can introduce a timeout, right? That means order service will wait for the inventory service response for a certain duration of time, maybe 5 seconds or 6 seconds. And if the inventory service is not responding even after 5 seconds, it will terminate the call. It will not wait anymore, and it will just throw a timeout exception. So to implement the timeout, we can open our IDE, and we just have to add some properties in our application.properties file. So this is going to be Resilience 4J timeout properties. I'm just going to type in Resilience 4J .timelimiter.instances.inventory, right? And I'm going to provide the timeout duration as 3 seconds, right? So we want to wait a maximum of 3 seconds before terminating that call, because maximum of 3 seconds before terminating that call and throwing the timeout exception, right? So to implement the timeout, I can open the order controller class one more time, and all I have to do is I'm going to add an annotation called as time limiter. So this is again coming from the Resilience 4J library, and the name I'm going to provide it as inventory, right? So one important thing we have to remember is, like, we have to provide the same name, inventory, as you've provided inside the properties, right? So after instances, we can provide some certain key, right? You need not provide only the name as inventory. You can provide any name you like, but just make sure that you use the same key inside the annotation, also the name attribute. So whatever attribute you have added here, you should also add the same attribute inside the name property for time limiter and as well as the circuit breaker annotations. So after adding the time limiter annotation, we also have to change the method signature of the method. So instead of returning a string, we have to return a completable future of string, because this will make an asynchronous call. We have to return a completable future. So I'm also going to change the return type of the fallback method to return a completable future. Instead of returning just a normal string, I will be providing completable future dot supply async, and then I will add this string here so that it will return the string. It will execute this logic inside a new thread, and it will return a completable future. We also want to do this same thing inside for the place order method. So I'm just going to copy this message, order placed successfully. So we can change the return type of the place order method to return a string instead of void. So I'm just going to change the return type as string, and I'm just going to scroll down, and just after the save method, I'm just going to add the return statement as order placed successfully. right? So this place order method is now returning the response string as we expect, and let's go back to the order controller method, and now I'm going to execute this place order method in a separate thread. So for that I'm going to type again completable future dot supply async, and I'm going to call the place order method from inside this supply async method call, right? I'm just going to return this particular completable future back to the method, and in this way we can implement the timeout. So this place order method will be executed in a different thread, and whenever the timeout is increased, like whenever the time limit has increased, it will just throw a timeout exception, right? So to be able to reproduce this slow behavior, we also have to change the logic inside the inventory service. So for that I'm just going to open the inventory service, go to the inventory service class, and inside the isInStock method I'm just going to add a log statement. So for that I'm just going to add the slf4j annotation. I'm going to type log.info wait started, something like this, and another call as wait ended. Alright, so now I'm going to simulate a slow behavior here. So for that I'm just going to add thread.sleep, and I'm going to call the thread.sleep method here with a timeout of 10 seconds. So here the execution will stop for 10 seconds and it will then start executing the remaining logic. So in this way we can actually simulate a slow behavior inside the inventory service, and the sleep method is going to throw an exception. So for that we can make use of sneaky throws exception, just so that this exception will be consumed. Don't use this sneaky throws exception in your production code. I'm just adding it for this demo purposes. Usually in the production code you should be able to catch this particular exception and rethrow this exception. Okay, so now as we have simulated this behavior, what I'm going to do now is I'm going to restart my order service and the inventory service, right? So go ahead and rerun in debug mode, and also the inventory service I'm going to rerun in the debug mode. So once these two services are started, again just make sure that you provide 30 seconds, you wait for 30 seconds until the service is visible inside the Eureka server, and then let's try to place an order and see how this is going to behave. So now I've opened the Postman client, and just make sure to access a new token when you're making this new call. So I'm going to click on the send button for the place order API post call method. So let's click on the send button, and you can see that we are getting a 500 error. So let's see what is this error. And yeah, you can see that we are receiving a timeout exception, right? So that means the order service is waiting for approximately 3 seconds before throwing a timeout exception. But here you can observe that in the inventory service you can see the log wait started, and after throwing the timeout exception, this log of wait ended is printed, right? So let's try this. Let's see this one more time. I'm just going to clear the console also inside the order service application, and I'm going to send this request one more time, and let's wait until we get the exception. So okay, I'm going to open this logs, and you can see that we are seeing the wait started log, and after some more seconds we saw the wait ended log, right? And meanwhile, as the response is taking more than 3 seconds, like more than the timeout duration, our order service has terminated the call, and it threw the timeout exception. It's not able to, and it's not waiting for the response from the inventory service anymore, right? So in this way we can implement the timeout using Resilience4j library. So now we are going to implement another use case, that is retry. right? So whenever there is a slow response, or like whenever there is no response coming in from the target service, we would ideally like to retry the call, right? Like in this case, we would like to retry the call to the inventory service is in stock endpoint, right? So now we are going to go ahead and implement the retry mechanism, how to do it in the Resilience4j library. Alright, so to implement the retry mechanism, I'm going to open the application.properties file of the order service, and just below the properties for the timeout, I'm going to add a new comment, Resilience4j retry properties, and I'm going to type in resilience4j.retry.instances, and I'm going to call the inventory property, and I'm going to define the max attempts as 3. That means we have to attempt the retry for 3 times, and after that I'm going to again call the same property, inventory.wait duration would be 5 seconds, right? So we have to wait for 5 seconds before retrying this particular call, right? So if we don't receive the response in 5 seconds, we will just do a retry for 3 times. And if this retry is still not working, then we will just let the circuit breaker handle the actual request flow, right? And after adding these properties, we need to add another annotation on top of our controller class. So I'm going to type at retry, and here I'm going to provide the name attribute as inventory, right? Similar to the circuit breaker and the time limiter annotations, I'm going to also provide the name as inventory, and the retry annotation is going to pick the properties which is defined with this key, and which is going to apply this configuration whenever it's retrying, right? So I'm going to restart the order service one more time. So I'm going to rerun in the debug mode, and after the order service is restarted, again let's make sure to wait for 30 seconds. So the order service application is now up and running. So what we can do now is I can go to the Postman client one more time, and let's try to request another new access token. I'm going to click on get new access token method. I'm going to click on the proceed button and click on use token, and let's try our luck whether we are able to trigger the retry mechanism or not. I'm just going to click on the send button, and you can see that it is taking some more time to actually get the response. So let's have a look at logs, what's happening here. So I'm going to open the inventory service log, and here you can see that already we are getting the wait started logs more than one time, right? And again it started printing the wait started log one more time, and finally it's printed the wait ended log 3 times, right? So that means the order service has tried to call the inventory service exactly 3 times with a wait duration of 5 seconds, and that's the reason why you see the timeout exception now. You can also have a look at these statistics, how many times the circuit breaker has restarted and how many times the circuit breaker has timed out. You can check this everything inside the actuator metrics. So I'm going to open the web browser, and I'm just going to refresh here the actuator health metrics, and if I just scroll down, you should be able to see this, but not here under the health metrics. But let's go to the actuator endpoint. So just localhost 8081/actuator, and if you can just scroll down, you can see the metrics about circuit breakers. If you want to see the metrics about circuit breakers, we are actually interested in the events about the retry events, right? So if you just scroll down, you can see one object called as retry events. If I click on this particular object, so you can see all the retry events which are triggered by Resilience4j, right? So it's actually triggered the retry exactly 3 times. You can also check how many times the time limiter is triggered by the Resilience4j. So this is going to be time limiter events. Yeah, so this is the events which we have created exactly 3 times. There was a timeout, and all these events are registered here through the actuator, right? So So this is it for this video, guys. In the next video, we're going to continue and implement much more interesting patterns in our microservices project. So until then, happy coding techies. Alright, so in the last video, you saw that we have configured circuit breaker in our application architecture. So we have made the internal communication between our services resilient. So whenever our service is down or whenever we are facing a performance issue, we can be sure that we will have some kind of fallback mechanism, or even in worst cases we will do a retry, and maybe if it takes long time, then we will do a timeout of the request, right? So we'll have some kind of resiliency in our system. But how exactly can we track down these issues, right? So for sure we can have a look at the logs, but actually in a production grade application where our services can receive thousands of, it's not really possible to understand and debug this point of performance problems through logs, right? Because we can have thousands of log entries in our millions of log entries in our system. So for this reason, there is a design pattern called as distributed tracing, which is nothing but it helps us to track the request from the start to the finish. Right? As the name suggests, it helps us to trace the request from the start to the finish, so that if a request is failed at any point of time, we can understand why it failed and maybe also where it failed. So now let's go ahead and understand how we can implement distributed tracing in our project. Before going ahead and implementing distributed tracing, first let's understand what really is distributed tracing, right? So imagine our example, the user will place an order in our system. So this request will first reach the API gateway, right? And after that, API gateway will proxy this request, send this request to the order service, and the order service will make a call to the inventory service. So this is our request flow. So to be able to track the request all the way from API gateway to inventory service, we need some kind of mechanism to trace this request, right? So for this reason, we have something called as a trace ID in distributed tracing, right? So the trace ID is nothing but a unique identifier which will identify the request which comes into a system. Along with this trace ID, we also have something called as a span ID. So this span ID is nothing but the number of trips the request is going to take inside our systems, right? We have one trip to API gateway and another trip to order service, and lastly we have another trip to inventory service, right? So all these trips, we have a unique identifier for each destination, right? For the API gateway, we'll have a unique identifier called as span1, right? We call it as a span ID. And for order service, we also have another span ID called span2, for example. And for inventory service, we also have another span ID, right? So a span ID indicates is like a unique identifier for each request inside our individual systems, but the trace ID is a unique identifier for the whole request. By using these kinds of mechanism, traces and spans, we can trace the whole request lifecycle in our services, and we can also understand if at all a service is responding slowly, or like if it is having some performance issues, we can easily identify using the trace ID and the span ID. So now let's go ahead and implement this mechanism in our microservice project, right? So for this, we are going to make use of a project inside a Spring Cloud ecosystem called as Spring Cloud Sleuth. So the Spring Cloud Sleuth, actually it's like a distributed tracing framework which helps us to generate the trace ID and the span ID whenever we receive a request to our microservices. Also need some kind of UI to visualize this information. For this reason, we have a tool called as Zipkin, which will help us to visualize this information. To get started, I'm going to add the Spring Cloud Starter Sleuth dependencies to our project. So first of all, I'm going to start with the API Gateway project, and in here I'm going to add the dependency with the group ID as org spring framework.cloud, and for the artifact ID, I'm going to type in Spring Cloud Starter Sleuth. Right, so this is going to download the Spring Cloud Starter Sleuth dependency, and after that I'm just going to copy this dependency one more time, and I'm going to type in the artifact ID as Spring Cloud Sleuth Zipkin. right? So the first dependency will download the Spring Cloud Sleuth dependency, and the second dependency is going to download the Zipkin library. So I'm going to copy these two dependency information, and I'm going to do paste it inside the rest of the projects, right? So I'm going to start with the discovery server. Alright, so I've added these dependencies inside all the services. So the next step is to configure the properties, configure the Spring Cloud Sleuth properties in our application, in our services. So for that, I'm going to start with the API gateway. So inside the Spring main resources, inside source main resources folder and the application.properties file. First of all, we need to configure the Zipkin properties inside our API gateway project. But before that, we have to download Zipkin to our machine, right? So if you go to the zipkin.io website, under the quick start section, I'm going to scroll down to the Docker section, and I'm just going to copy the Docker run command here, and I'm going to open the terminal and paste in and run this command. As you can see, I already have the Zipkin container up and running, so you can just run this command and it will start, the Docker will start the Zipkin container on your machine, right? And make sure that you are exposing this Zipkin container on the port 9411. Go back to the application.properties inside our API gateway project, and in here I'm going to type in spring.zipkin.base URL. I'm going to type in http localhost 9411, right? And after that, I'm also going to add another property, spring.sleuth.sampler.probability as 1.0. So this sampler probability, we have set the value as 1.0. That means we want to send 100% of the requests which we are receiving to our system to Zipkin, right? We want to start tracing 100% of the requests which we are receiving to our system. Alright, so now I'm going to copy this property and paste this exactly into all of the services. So I'm going to open the properties file of our discovery server. I'm going to add this. Also, let's add this inside our inventory service, our order service, and lastly the product service, right? So that's all we need to do to enable Spring Cloud Sleuth, to enable distributed tracing in our microservices project. So let's go ahead and test whether the distributed tracing is really working or not. So for this, I'm going to first start off by starting the discovery server. Let's see if it is able to start up or not without any errors. Alright, so you can see that the discovery server is started without any problems, and I think it's able to also connect to Zipkin. And now I'm going to start off all the rest of the services. Alright, so if you see the logs, so if you observe the logs, you can already see that we have some additional information in our logs, right? For each log entry, we have adding some kind of additional information, right? So first of all, we are showing the service name, what service we have, and we have two blank spots here, right? So here, this is the place where we see the span ID as well as the trace ID of each request. So I'm going to open the Postman client, and I'm going to first of all make a request to the product service. First of all, for that, I'm just acquire a new access token. For that, I'm just going to click on get new access token and click on proceed, and then click on use token. And then now I'm going to send this request to the product service. And here you can see the unique identifiers here, right? We received this information to the product service. This request contains a span ID as well as the trace ID. Now let's go ahead and also place an order in our system. So for that, I'm going to go to the Postman client one more time. I'm going to acquire a new access token one more time, and then click on. So as you remember that we have added a slight delay in our inventory service. So for this reason, we are not getting the response right away. For sure, we will get a timeout exception inside our order service. So because that's good, we can actually have a look at how this timeout exception is going to be handled through the distributed tracing. Let's open the Zipkin UI and visualize this information. So I'm going to open my browser and go to localhost 9400/Zipkin. And here you can see the homepage of the Zipkin application. And here I'm just going to click on run query. And you can see that it is displaying us the information about the request we have made. You can see that the request has first reached the API gateway, and it actually took 19 seconds for this request to be completed, and it actually made 3 stops. That's why it has 3 spans here. So if I click on the show information here, you can see that first it made a request to API gateway, then it made a request to order service. Right? If I click on show all annotations, you can see some information about this request. You can also see what is the error status of this particular call, what is the HTTP method, the path of this particular call, and we can also see the error message of this particular call inside the order service. So if you want to see more than 10, so by default it's showing 10 results, right? So if you want to see more than 10 results, I can click on the settings button, and the limit I can set as maybe 1000, right? And I can click on the run query, and now you can see all the requests in the last 15 minutes. All right, so now you may get a doubt that are we not able to see the inventory service in this whole call stack, right? You can only see the API gateway and as well as the order service in this particular trace information. And if you check the order service and if you click on the show button for the order service, we're able to see a call to the inventory service here. This is because we are making a call to the inventory service in a different thread, right? We are making use of a circuit breaker here, right? So what this circuit breaker will essentially do is it will create a new thread from our order service, and it will make a call to the inventory service in that new thread, right? So if you take this into consideration, this is not a same request, right? This is a different request. So from our API gateway to order service, we are making one request, and from order service to inventory service, this is completely a different request, as this is running on a different thread, right? So that's why we are not able to see this inventory service information inside the previous trace request, right? If you want, you can try to disable the circuit breaker in our order service. So if I open the order service class, you can try to disable the circuit breaker. But let's try to disable the circuit breaker annotation, and let's see what will happen. And now if you see the API gateway line and click on the show button, you can see all the information here, right? We can see that the API gateway is making call to order service and the order service is making call to inventory service, right? So you can see that in the whole call to the order service, the inventory service is taking 292 milliseconds and the order service is taking 625 milliseconds, and the whole request is taking 637 milliseconds to complete, right? And you can also have a look at the span IDs for each of the services. So for the inventory service, the span ID is 755, starting with 755. Let's see if we are able to find the span ID inside the logs or not. So I'm going to open the logs of the inventory service. I'm going to search for 755, and you can see that the span ID is visible here, right? And here we have the trace ID which starts with 2ACE. Let's see whether this is the same trace ID we see in the Zipkin UI or not. So, and you can see that the trace ID here is starting with 2ACE. And similarly for the order service, the span ID starts with AF82F. And let's go to the order service, and you can see that the span ID is also the same here, right? So when we are making a call in a single thread without creating additional threads, we can trace the request from start to the end. But if you are trying to create an additional thread on top of an additional thread, then this is not really useful, right? You need to create your own spans for that, right? So let's see how to create our own span to be able to understand this information, right? So let's try to enable this circuit breaker one more time. So I'm going to go inside the place order method of the order service, and Spring Cloud Sleuth provides us a mechanism to actually create our own span IDs here, right? So we can do that by using the tracer class from Spring Cloud Sleuth. So I'm going to type in private final tracer, which is actually coming from the Spring Cloud Sleuth. So I'm going to make use of this tracer reference variable, and just before making a call to the inventory service, I'm going to type tracer dot next span dot name. We are going to provide a unique name to this particular span we are going to create, right? So I'm going to call this as inventory service lookup, and let's store this written variable inside a local variable called as inventory service lookup. So just before the call to the inventory service, I'm going to type tracer dot with span, and here I'm going to provide the span as inventory lookup service lookup dot start, right? And what this will do is it will execute the whole code. First I have to assign this inside a try finally block, and I'm going to, inside the finally block, I'm going to type inventory service lookup dot end, and I'm going to move all the code below this into this try with resources block. Let's format this so that it looks nice. So let's assign this particular with span call to another reference variable called as tracer dot span in scope, and let's call this variable as is span in scope, and that's it. So we have to execute the whole block of code inside this try with resources block. So what will happen is Spring Cloud Sleuth will assign this particular span ID, which we have created in the previous step, to this particular piece of code which is executed inside this block. Okay, so let's restart our order service. So after you have restarted the order service, let's go back to the Postman client and make sure to acquire a new access token before you place the order. So after getting a new access token, click on the send button, and you can see that the order is placed successfully. Let's go back to Zipkin and click on run query, and under the API gateway row, I'm going to click on the show button, and you can see that as we have added back the logic for the circuit breaker, we cannot see the inventory service here anymore. So let's go back to find trace and run query one more time, and I'm going to select the order service and click on the show button. Now you can see that we can already see the span ID we have created called as inventory service lookup. So in this way we can create our own span IDs. If you want to trace any particular piece of code, you can create your own spans manually and assign that particular span ID to whatever logic you want to execute. So that's it for this video. In the next video, we are going to have a look at how to implement event-driven architecture in our microservice system. We are going to make use of the Kafka message queue to implement the event-driven architecture. So I will see you in the next video, and until then, happy coding techies. Welcome to part 8 of the Spring Boot microservices series. So in the previous video, we saw how to implement distributed tracing in our application. Now let's go ahead and see how to implement event-driven architecture in our microservices project. Right? So before we continue, so let's understand what exactly is event-driven architecture. Right? So in our order service, we are communicating with the inventory service in a synchronous manner, right? Like we are making a HTTP request to the order service to place an order, and the order service is again calling the inventory service using the HTTP request again, using the REST API, using the REST call. right? So this kind of communication, as we know, is called as synchronous communication. The order service will call the inventory service and it will wait for the response from the inventory service. Once it receives the response, it will send it back to the user, right? So this is called as synchronous communication. We can have another kind of communication called as asynchronous communication, where the order service will make a request to the inventory service and it will not wait for the response, right? So it will just fire the request and it will forget about the response. So this kind of communication is called as asynchronous communication. This kind of asynchronous communication can be enabled by using event-driven architecture. It is nothing but performing asynchronous communication with the form of events, right? So whenever we receive an order to our order service and the order is placed successfully, our order service will raise an event. So in this scenario, it can be like an order placed event, and we can place this order placed event object as a message inside the Kafka broker, and our notification service, which is the consumer. Here order service will be a producer of the message and the notification service will be a consumer. So it will consume this message and will process this message accordingly, right? So usually if you want to implement the functionality, it's like sending out notifications either in the form of email or SMS. We're not going to implement this functionality in the notification service. So what we're going to do in this part is to set up this event-driven architecture. Right, so now let's go ahead and install Kafka in our local machine. So for the installation, we are going to use Docker and Docker Compose to create the Docker containers. So for this, I'm going to first open the Apache Kafka Quick Start Guide from Confluent developer website. So here I'm just going to select the option Docker, and the first thing we are going to do is to copy the Docker Compose file, because we already have the Docker Compose file ready inside this Confluent developer website. So what I'm going to do is in the setup Kafka broker section, I'm just going to copy this whole file and I'm going to open my IDE, and in the root folder I'm going to right click and click on new file, and I'm going to name this file as dockercompose.yaml. Let's add it to the Git repository, and I'm just going to paste in the whole code which I've copied from the Confluent developer website. So in this Docker Compose file, we are using a version 3 and we are mainly downloading two services. The first one is Zookeeper. For Zookeeper is used to orchestrate the Kafka clusters. So we need a Zookeeper instance to orchestrate the Kafka cluster, even if you are just using a single Kafka cluster. So we have defined the Docker image from Confluent Inc. So we're using the version 7.0.1. And the container name we are defining as Zookeeper, and we are also providing a couple of environment variables. The first one is Zookeeper client port, so we are defining the port as 2181 and Zookeeper tick time as 2000 milliseconds. This tick time is nothing but the interval with which it will send, the Zookeeper will send heartbeat messages, right? So this is something similar to what Eureka is doing, like we have this heartbeat messages for every 10 seconds. So similarly, Zookeeper, we can also configure this tick time Zookeeper as 2000 milliseconds. Next we have the Apache Kafka broker itself. So this Kafka is called as broker, is defined by the tag called broker. So we are using again the Docker image from Confluent Inc. and with version as 7.0.1. The container name, we are defining it as broker, and we are also defining the ports on which this Kafka cluster will run. So the single node cluster will run. So we are using this 9092 port, and we are also exposing this port out of the Docker container. We don't need this comment, so I'm just going to remove this comment. And this Apache Kafka container also depends on the Zookeeper container. So that's why after the Zookeeper container is up and running, so we will also start with our Kafka container. And lastly, we also have the environment variables. We have the broker ID, it's set as 1. We have the environment variable for Kafka Zookeeper Connect. So here we are just referring to the container of Zookeeper by first referring the container name as Zookeeper, as we defined here, followed by the port. So this 2181 as we defined inside the zookeeper client port environment variable. And lastly, we also have this Kafka listener security protocol map environment variable, which is defining the listener security protocol. We are using this plain text and plain text internal, and we also have the Kafka advertised listeners. So these are all the listeners which are configured inside our Kafka cluster, and it's also sent as a metadata to the clients. We are defining it in the plain text format. We are defining it as localhost 9092, and also we are defining it using the host name as plain text internal 29092. As this is a single node Kafka instance, we are setting this offset topic replication we can do as 1, and also this transaction state ISR as 1, and also the transaction state log replication factor as 1, because we are setting it as 1 because we are just using a single node here. If you are using multiple nodes in a cluster, you may want to also change these values to suit the number of instances you have. So this is the configuration of Docker Compose. So to download the Docker images and to run the Docker containers, what we can do is I'm going to open the terminal and make sure you are in the root folder, and you can type docker space compose up -d, right? So press enter. So the first thing it will do is it will first check whether the image is existing in your machine or not. If not, it will first try to download, and it will start the containers. As I already have the images on my machine, it's not downloading. So when you're running this command, maybe it will download this image and it will take some more time. But you can see that these two containers are started, and you can also verify that they are running fine or not by running the command docker ps, and you can see that these two containers are up and running successfully. You can also verify the logs of our Kafka broker by typing docker logs -f, and I'm going to add the name of the Kafka broker, and you can see that the logs looks fine. There are no errors. So that means our Kafka broker is up and running successfully. So now we can go ahead and configure Kafka in our order service. Alright, so now let's discuss about the Spring framework which we are going to use to integrate with Apache Kafka. So the library is called as Spring for Apache Kafka. So this Spring for Apache Kafka project applies core Spring concepts to the development of Kafka-based message solutions. It provides a template as a high-level abstraction for sending messages. It also provides support for message-driven POJOs with Kafka listener annotations and a listener container. So this is the description which we have inside the Spring project website. So what it says is, like, of course we are going to use this library to use it inside our Spring Boot projects, and we are going to, and this project is mainly going to provide the functionality using a class called as a Kafka template class. So using this Kafka template class, our producers, in our case this order service, can send the messages to our consumers. In this case it's the notification service, and the consumer side, and from the consumer side we can define this consumer, like this notification service, as a listener by adding this Kafka listener annotation. So we can use all these features inside our project to integrate with Kafka from our Spring Boot projects. So let's go ahead and install this library in our project. So for that I'm just going to click on the tab Learn, and I'm going to click on the reference documentation section, and in here I'm just going to scroll down until I find the dependency information. So under the quick tour you can just copy this dependency information under Maven, and I'm going to open the project in my IDE, and I'm going to copy this dependency inside the pom.xml of the order service class. I'm going to paste it in here, order service project, and let's click on this load Maven changes icon. And the next thing I'm going to do is to configure our order service to listen to the Kafka broker which is running on our machine. So for that I'm going to open source main resources, application.properties. I'm just going to scroll down until the end of the properties file, and in here I'm going to add the property add the comment as Kafka properties, and I'm going to type in spring.kafka bootstrap servers. So these are the list of servers where we can find Kafka installation. So as we are using local installation, we can just provide the URL as localhost 9092, right? After adding this property, Kafka will be automatically configured in our Spring Boot project. The next thing we can do is I'm going to open the Java folder, and inside the order service, we are going to make a call to the Kafka cluster whenever an order is placed, right? So for that, I'm just going to inject the Kafka template class into our order service. So I'm going to type in private final Kafka template, and just below the call to the order repository.save method, I'm going to type in Kafka template.send, and this send method contains takes different arguments. So what we are going to do is we are going to use this argument which contains the topic which takes the topic name as the first argument, and the actual data we want to send as the second argument. So I'm going to select this method, and we are going to send the message to a topic with name as notification topic, and here we want to send out the order number. We want to send out the order number as a message to the queue, so that in the notification service we will understand what is the order number which was created, right? So for this reason, instead of sending out the order number like this, like order.getNumber, what we can do is we can create a new class called as an order placed event and send out this object as a JSON message, right? So for this, what I'm going to do is I'm going to create a new package called as event, and inside this package I'm going to create a new class called as order placed event, right? And this is going to be just a plain Puja class. So I'm just going to add the data annotation and allocs constructor, noaux constructor, and this is going to contain just one field, and I'm going to type in private string order number. Back to our class, order service class, I'm going to wrap this order number with the new order placed event object. So let's pass this order number as a constructor argument, and now what Kafka template will do is it will send this order placed event object as a message to the notification topic. So if you observe this method call Kafka template.send, that we are getting a warning from IntelliJ that we are making an unchecked call to this send method, right? So if you observe the Kafka template class, I'm just going to hold Control and click on this Kafka template class so that it will open the sources, and you can see that this Kafka template class accepts two generic arguments, key and value, and we did not define this key value pair when actually defining the Kafka template variable. So for that, we can define the key and value pair as string and the order placed event. Why these two? Because we are providing the notification topic as a string and we are providing this order placed event as a value. So this topic name is going to be string, which is a key, and the order placed event is going to be the value. So let's update this Kafka template declaration with the key value pair. So I'm just going to type in string as the first key argument and the order placed event as the second generic argument as the value, right? And we can also define the notification topic as the default topic for our order service, right? So if you want to send multiple messages to Kafka. So instead of typing this notification topic for every message we are going to send, we can define this notification topic as a default topic, so that Spring Boot will understand that we have to always send the messages unless we explicitly provide a different topic name. So Spring Boot will understand that it should always send the messages to this notification topic. So we can do that by going to the application.properties file, and we have to add the property spring.kafka.template default topic as the notification topic. And other than that, we also have to provide information to our Spring Boot project how to serialize these key and value pair when sending to the Kafka broker, right? So we can define some serializers through Spring Kafka project. So I'm going to add a property called as spring.kafka.producer.keySerializer, and we are going to provide the serializer class as org Apache Kafka common serialization.string serializer. So using this particular property, Spring Boot will understand how we have to serialize this particular key and send it to the Kafka broker. So likewise, we also have to define the serializer for the value, that is the order placed event. So by default, it's okay like if we send this order placed event as a JSON object, right? So to be able to convert this Java object into a JSON, we also have to define the serializer. So for that, I'm going to add the property spring.kafka.producer.valueSerializer as JSON serializer class, which is coming from org Spring Framework Kafka support.serializer package. Right? So that's all we need to do to configure our order service. So now let's go ahead and create the consumer, which is the notification service, and configure that service with Kafka. Alright, so now let's go ahead and create the notification service notification service module in our project. So for that we need the starting code. So for that I'm going to open the start.spring.io website, and I'm going to generate one Spring Boot project. So I'm going to use the group ID as comprogramming.techie, artifact ID as notification service, and I'm going to use Java 17 and packaging as jar, and I'm going to add some dependencies here. The first one is going to be Lombok, and we are also going to use Spring Web. Lastly, we're also going to use Spring for Apache Kafka. So I'm just going to search for Kafka and add this dependency. Now I'm going to copy the pom.xml because that's what I need to create the service. So I'm just going to click on explore and just copy everything, copy all the information right from the properties until the end of this pom.xml. Right? So I'm going to copy this whole code and I'm going to go back to my IDE. Now I'm going to create a new module. So this is going to be a Maven module. So I've already shown you the process of creating the module, so I'm just going to not explain this one more time. So I'm going to click on next. I'm going to call this as notification service, and make sure you have the parent as microservice new and not any other project. So or else if you select, for example, order service, it will create this notification service inside the order service. So we don't want that. So that's why make sure you select the module as microservices new, and the artifact and coordinates and the version is fine. So I'm just going to click on finish, click on add. So this will create a new module inside our microservices new project. So let's verify whether this module is added correctly by opening the pom.xml, and let me close this annoying pop-ups. And inside the modules tag, you can see that our notification service module is added successfully. So I'm going to go back to the pom.xml of the notification service, and in here I'm just going to paste the code which I copied from the start.spring.io website, right? So I think we don't need the properties tag. I can just copy this java.version. I think I don't need the properties tag as it's already there inside the pom.xml. Here we are providing the java.version, so let's add this property inside the original tag, and I'm going to remove the properties tag and click on this load Maven changes icon. So now let's go ahead and also build some Java classes inside our notification service module. So inside the source main Java package directory, and I'm going so inside the source main Java directory, I'm going to right click and create a package called as com programming.techie, and in here we need to create the notification service application class, which is the main Spring Boot application entry point class. So for that I'm just going to create a class called notification service application class. I'm going to add it to the Git repository, and instead of typing out the code, I can just use the start.spring.io website to copy the initial version of this notification service application class. So I'm just going to copy everything inside the class here, go back to my IDE and paste this inside the class, right? So now we have the Spring Boot application class up and running. Now what I need to do here is I have to define a Kafka listener inside this project. So I'm going to do this inside the notification service application class itself. I'm going to write the annotation Kafka listener, and this Kafka listener is going to listen to the topic called as notification topic, because this is the name of the topic which we gave to our order service class. So if I open order service, and here you can see this is the name of the topic we have configured. So I'm going to use the same name of the topic, and I'm going to define a method called as public void handle notification, and this method is going to take the order placed event object as the input argument, right? So for that we have to define this order placed event, but we don't have this class inside our service. So what I'm going to do is to create a class called as order placed event, and I'm going to simply copy the existing logic of the order placed event. So I'm just going to open the order service and find out the order placed event class. I'm going to just copy everything from here, paste it inside this order placed event from notification service, right? So you may have one doubt that why I'm creating two classes inside the order service and also the notification service, but why can't we share this class between these two services? In general, it's recommended not to share any classes between these two services because we want to keep these services independent and clean. So it's always recommended, especially if you're trying to receive and send the payloads, to have your own version of these classes inside your own services. And now let's go back to this order handle notification method inside the notification service application class. And in here, I'm just going to we wanted to send out an email notification. We want to send out an email notification, and as we are going to keep this project pretty simple, I'm not going to add any business logic here. You are free to do it on your own. Like, you can add the necessary dependencies and you can try to expand the functionality of this project, but I'm just going to focus on the microservices part. So I'm not going to add the logic here, but I'm just going to add a log message to acknowledge that we indeed received this message inside the notification service. So I'm going to make use of the SLF4j annotation from Lombok, which uses the SLF4j library to provide a logger implementation. So I'm going to add the log messages as log.info, received notification for order, and I'm going to add a placeholder for this and define the placeholder value as order placed event dot get order number. Right, so whenever a message is placed and an order placed event is raised, we are going to place a message from our order service into the Kafka topic, and the notification service is going to listen to this Kafka topic, and it's going to just print out this message, received notification for the order number. Right, so let's run this notification service now and test whether everything is working fine or not. And one thing I forgot to configure here is our notification service. So we didn't add any application.properties file here. So I'm going to do that by quickly clicking on new file, application.properties. So I completely forgot to add the Eureka client, sleuth and Zipkin support to our notification service. So for that I'm going to go back to the start.spring.io website, and in here I'm going to add some more dependencies. The first one is going to be Eureka Discovery Client for Spring Cloud Discovery. I'm going to add the dependencies for Zipkin, for Spring Sleuth, Cloud Sleuth. So after adding all these three dependencies, I'm going to click on Explore one more time, and I'm going to copy the relevant dependencies from the pom.xml, starting from this Spring Cloud Sleuth Zipkin, Spring Cloud Starter Netflix Eureka Client, and finally Spring Cloud Starter Sleuth. So I'm going to copy these three dependencies, paste them inside the pom.xml. Let's add this below the Spring Kafka dependency and click on this Maven icon to load the Maven changes. So Maven will try to download these dependencies in the background, and now we are ready to add the necessary configuration inside the application.properties file. So I'm just going to drop in some configuration code here. So the first one is the familiar Eureka client service URL and the default zone. I'm going to provide the same default zone I have provided for rest of the services. I'm going to provide the application name as notification service, and we are also going to run this notification service application on a random port. So that's why I provided the server.port as 0. And we are also going to enable the Spring Sleuth integration. So for this, the Spring Sleuth integration enabled is going to be true. And we also have to provide the URL for Zipkin so that it will send out the trace information to Zipkin. So we have provided the URL of Zipkin installation, and we also have provided the sampler probability as 1, as we did for the remaining services. Right. So the one more property we have to add is to configure Kafka in our notification service project. So for that, I'm just going to make use of the property which I've defined inside the order service. So I'm going to open the application.properties file. So I'm going to copy all these 4 properties which I've defined inside the order service, and I'm going to paste them inside the notification service like this. And we have to make some modifications to these properties. So we have defined the serializer on the producer side, because as we want to serialize this key and value pair and send it to the Kafka broker. And on the consumer side, we have to deserialize this information, right? Like whatever information which is coming as part of the as part of the Kafka broker, we have to deserialize that, read this information. So for that, we have to define a deserializer for key and value objects, right? So for that, we can make use of the property spring.kafka.consumer instead of producer. And here we have to provide the key as .key deserializer, right? And we have to provide the name of the deserializer as string deserializer. So I can select the string deserializer class here, and likewise we also have to select the JSON deserializer, JSON JSON deserializer for spring.kafka.consumer.value deserializer. Yeah, so now our Spring Boot application will understand how to deserialize the incoming key and value pairs. That's good. And one thing we also have to keep in mind here is inside our order service, let me go into the order service, and here we are trying to serialize this order placed event with fully qualified name as com programming techie order service dot event dot order placed event, right? But coming to our notification service, let me open this order placed event again. The fully qualified class name is going to be com programming techie dot order placed event, right? So whenever we receive this information from product service to the notification service, Spring Boot will not understand how to map these two different order placed events which has two different qualified names, right? So for that we have to provide the mapping type on side in the producer side and also the consumer side. So on the producer side we will define what exactly is the type which we are sending for the order placed event, and on the consumer side we will also define what is the exact type we are expecting. So for this reason I'm going to go back to the order service application.properties file, and I'm going to add a property called spring.kafka.producer.properties, and here we are providing the JSON type mapping as JSON type mapping, and as part of this JSON type mapping we are providing one token value followed by the fully qualified class name of the body we are sending as part of the message, right? So the token value I have provided as some random value as event, and we have provided the fully qualified class name of the order placed event class, right? So in this way Spring Boot will understand what is the JSON type mapping of the order placed event, right? So we also have to define this property inside the notification service. So I'm going to add this property again here, and this time this is going to be spring.kafka.consumer.properties, right? And the Spring JSON type mapping should have the same token as we defined inside the order service properties file. So it's should be the same token as event, and the fully qualified class name can be the fully qualified class name of the order placed event inside the notification service. So that's going to be com.programming.techie and followed by the class name, right? So it's com.programming.techie.order placed event. So let's verify if it is the same or not. So it's com.programming.techie order placed event, right? So now Spring Boot will understand how to map these two different classes which has two different fully qualified class names. So now that's all we have to do on our order service and notification service. So we can go ahead and start all these services now and test whether the functionality is working fine or not. So let's go ahead and do that. Alright, so now you may have observed that we are getting an error when starting the notification service application class. So it says an illegal state exception, no group ID found in a consumer config, container properties or Kafka listener annotation. A group ID is required, right? So what this is saying is that we have to define a group ID, because we have to define the consumer group and also define a group ID on the consumer side inside the application.properties of the notification service project. So for that I'm just going to define arbitrary ID called as notification ID, and I'm going to assign it to the property spring.kafka.consumer.groupID equals notification ID, right? After defining this property, let's start the notification service application one more time, and this time this this class should be starting successfully without any errors. And let's see, it looks like our application is started successfully, and you can see that we have adding the log message, adding newly assigned partitions, notification topic, right? So it's subscribed to this notification topic, so that's good. Now let's try to place an order. So I'm going to open Postman, And first of all, we need to get a new access token from Keycloak. So I'm going to click on this authorization tab, and I'm going to scroll down and click on get new access token. Click on proceed. So now we have the latest token, and let's click on this use token button so that it will be added to this header section. And looking at the body, we have created order line items with SKU code as iPhone 13, and let's click on send, and you can see that we got the message order placed successfully. So now let's check the order service if we see any errors or not. So we don't see any errors, at least in the order service. And in the notification service, we can see a log message, received notification for order, and we are able to see the order ID here. We are able to see the order number here, right? So this is how we can develop the event-driven applications using microservices and using the Kafka message broker. So I hope you learned something new, and in the next part, we will go ahead and Dockerize all our services using Docker Compose, and in the subsequent part we will migrate this Docker Compose to Kubernetes and then also refactor the architecture to suit to Kubernetes, right? So I will see you in the next video. Until then, happy coding techies. Welcome to part 9 of the Spring Boot Microservices project series. So up until the last part, you saw how to develop our microservices around different components, and now let's concentrate how to run these services together. So as part of the first step, we are going to Dockerize all our services and then run them together using a tool called as Docker Compose, right? So I'm not going to go into the basics or fundamentals of what is Docker and what is Docker Compose and how to work with them. I'm assuming that you have some basic understanding about both Docker and Docker Compose. And if you want me to make a video like a Docker tutorial for Java developers, so just give me a comment down below. I will try to cover everything about Docker, how to run your Docker images especially for Spring Boot applications, and what is the best practices of maintaining the Docker files and running the Docker files, and what are the latest ways to use the Docker files and all. So if you're interested, just drop a comment below and I will try to make a video for that. So let's go ahead and start Dockerizing our project. Alright, so the first thing you need is you need an installation of Docker Desktop on your machine. So if you're using a Mac or Windows operating system, then you can just make use of either Docker Desktop for Mac or Docker Desktop for Windows installations. You can find out all these here inside the Docker Desktop website, inside the Docker website. So after installing Docker Desktop on your machine, you also need to register for Docker Hub. This is where you will push your Docker images after you have built the Docker images on your local. I would suggest you to register for an account in the Docker Hub, and once you have installed Docker Desktop, make sure you also sign in. Inside the Docker Desktop, you will see an application like this, and once you are logged in, you can see your account at the top here like that. This is a free account. You don't need to pay for this account or anything like that. Alright, so now I'm back inside my IntelliJ IDE. So let's start with Dockerizing one of a service in our project. So we will start with the API Gateway project. So I'm going to make use of the existing code. I'm just going to explain how we can Dockerize our project. I'm not going to type in every command and along with you. So whenever you are stuck, you can refer to the GitHub project, and if you have any doubts, you can refer to the branch part 9 here. So you will find the complete source code of all the Docker Compose files and all the Docker files and all the configuration inside this particular part 9 branch, right? So let's go back to our project, and I'm going to expand the API Gateway folder here, and let's start with building a Docker file. Let's start with Dockerizing this API Gateway service. So for that, first of all, I created a file called as Docker file inside the root folder of the API Gateway project. And if you have a look at this Docker file, it is a very plain, simple Docker file. So we are using this OpenJDK 17 as a base image. And after that, we are copying the jar file, which will be present usually inside the target folder, into the container. and we are calling this jar file as app.jar file, and after that we are providing the entry point command as java jar app.jar, right? So whenever the container is starting up, it will run the command java -jar and it will point to this app.jar file. So let's try to build this Docker file. So for that I'm going to open the terminal and make sure I'm inside this API gateway folder, and to build this Docker file I'm going to type in docker build -t and -t. So that means we are building this image and we are providing a tag for this image, right? So what is the tag we can use is API gateway Docker file, and we have to provide the location where the Docker file exists. So we are going to provide the present folder as the location by providing the dot here. So that means Docker will understand that the Docker file exists in the present directory, right? So if I press enter, so first of all it will try to download this OpenJDK 17 image from Docker Hub. So you can see that this Docker build phase is completed successfully. So now let's see how this image looks like. I'm going to type in Docker images, and these are all the images I have in my local. So we are mainly interested for the API gateway Docker file image. So you can see that this is built for 57 seconds ago and it has a size of 471 MB. As you can see that our Docker image is of size 471 MB. So we are not actually following some best practices here, and our Docker image size is also pretty big. It says 471 MB. There is some improvements we can do. So let's see how to do that in the next section. So one of the drawbacks we can think about this Docker file approach is, first of all, we are making use of JDK instead of JRE. So that's one thing. And the other thing is, no matter what small change I do in my API gateway project, that means if I try to update from one dependency, one version of this dependency in the pom.xml, or change the application.properties, this Docker file will build the whole image one more time, right? It does not have any contextual understanding of what changed and what should be built, what's the only part which should build. So for this reason, to improve the process of building the Docker files, Docker has introduced something called as multi-stage builds. So let's have a look at how to improve our Docker file using the multi-stage build mechanism, right? So for that, I created another file called as dockerfile.layered, and this file contains a bit more code than the Docker file we saw before. So let's see what we are doing here. So you can see that first of all, we are making use of the JRE, this Eclipse Temurin 17 JRE instead of the OpenJDK, and we are providing an alias for this base image called as builder, right? And after that, we are creating a work directory called as extracted, and after that, we are similar to the Docker file. We are adding this jar file inside the target folder into the container, and we are calling it as app.jar file, right? And next step is we are running a command called as java -d jar mode equals layer tools, right? So what exactly this will do is, as part of Java 9 or Java 10, I'm not sure, Java supports extracting different layers from the jar files. So if you have a look at our Spring Boot application, it is divided into different layers, right? So if I open the target folder and if you try to open this jar file, you will find there are different layers to our Spring Boot jar file, right? So those layers will be, all the dependencies will be stored in a folder called as dependencies. All the Spring Boot loader information is stored in the Spring Boot loader project, in the loader folder, right? And all the snapshot dependencies are stored in the snapshot dependencies folder. And all the source code, application properties, everything which is inside the source main Java folder will be stored inside the application folder. So for our Spring Boot applications, these are the different layers which our Spring Boot jar will provide, right? So by running this command, java -d jar mode layer tools, what it will do is it will extract all the layers, these 4 layers from our Spring Boot jar, and it will store these 4 layers, 4 folders, you can say, inside the folder called as extracted. right? So for this reason, we are providing also the command called as extract, which will extract all the layers from our jar file and store it inside the extracted folder. So this is the first stage of the Docker build we want to do. And we want to do a second stage also, right? So we want to copy all these layers from our extracted directory, and we want to run, and we have to copy this inside another folder, right? So for this reason, we are creating another stage. So similar to the first stage, we are making use of the Eclipse Temurin JRE, and we are now creating another work directory called as application, and we are copying all the required layers, all the required folders from the extracted folder into our application folder. So this is the 4 steps we have. We are copying the dependencies folder, Spring Boot loader folder, snapshot dependencies folder, and application folder. So after copying all these folders, we are exposing the port 8080 and just running this command java jar launcher, right? When we run this container, it will follow all these steps, and this is a better way of building the Docker files. So now if all you have changed is just a version inside the dependencies, so the Docker will understand that, okay, the only file which is changed is inside the dependencies folder. So let's build only this particular dependencies folder, or just copy this dependency folder into our application work directory, and rest of all will be the same, right? So in this way, you can save the build times. You can save some time when building the image. Alright, so now let's go ahead and try to build this layered Docker file. So for that, I'm going to open the terminal, and I'm going to type in the command docker build -t, and I'm going to provide the tag name as API gateway layered. And as we are using not the default Docker file, but we are using a different Docker file called dockerfile.layered, I'm going to provide the name as -f dockerfile.layered, because if you don't provide this command, it will always try to build the Docker file, the default Docker file, right? So next thing I have to do is provide the present directory. So for that, I'm just going to provide it as dot. And now you can see that Docker is trying to build our image in multiple stages. So first of all, it's trying to add the app.jar file into the working directory of extracted. After that, it's extracted all the layers from the image, and it's trying to copy all the folders into the application folder, right? So now let's investigate how this image is looking like. So I'm going to provide the command docker images. Here you can see that this API gateway Docker file, which we built using the default Docker file, is 471 MB, and this API gateway layered image, which we built using this dockerfile.layered file, is just 316 MB. This is already good. And we also have this multi-stage builds where you can build only the parts which I've changed in the application. So now in the next section, we will see how to build the Docker images from your source code without using any Docker files, right? How to build the Docker images automatically without using the Docker files. So now let's go ahead and check that. So we can make use of a library called as gib from Google, which is mainly used to build containers from our Java applications without using a Docker file, or maybe without installing the Docker itself. You can read more about gib in this getting started page. So it mainly provides some plugins using Maven or Gradle, and you can see that it will take the source code of the project and it will try to use this local daemon, local Docker installation, and it will try to understand what is the build context, and it will build the container image, and it will also push this image to a container image registry. So in our case, it is Docker Hub. So it will do all these things as part of our build through a Maven plugin. So let's see how to install this Maven plugin in our project. So I'm going to open the pom.xml, the root pom.xml under the microservices new project. So I'm going to open this pom.xml and I'm going to add this plugin section, right? So where the group ID is com Google Cloud Tools, and the artifact ID is gib Maven plugin. The present version we are going to use is 3.2.1, which is the latest version. And we also have to provide some configurations here So inside this configurations tag, we have to provide what is the base image we want to use, right? So inside this Docker file layered, we saw that we are using this Eclipse Temurin 17 JRE as the base image. So we also have to provide the base image using the from tag, and I'm going to provide this inside the image tag called as Eclipse Temurin 17 JRE, right? So when you provide this, Gib will make use of this as the base image. And we also have to provide the to tag. So as I mentioned before, Gib will try to take your project and will understand the build context, and it will build the container image and also push it to the container registry, image registry, right? So for that, we also have to provide what is the address of this container image registry. So as we are using Docker Hub, I have provided the name of Docker Hub here. It's like registry.hub.docker.com, followed by my username of the account I created. And the next thing we are going to provide is the name of the project it is trying to build, right? So if you add this plugin on the root folder, the root pom.xml, this plugin will be available for all the projects, right? So if I'm trying to build the API gateway image, so I have to provide the image name as API gateway, right? So for this particular reason, I'm going to use the Maven property called as artifact ID. So if I open the API gateway pom.xml, the artifact ID is API gateway, right? So in this way, we can make use of the artifact ID to build the Docker images. So after adding this plugin, you don't need to do anything. The Docker Gib Maven plugin will try to build all the images. So for that, all you have to do is to have to type one command. So we can see what is that command. But before that, we can see the different goals which are part of this plugin. I'm going to click on this Maven icon. And if you open this microservices new project and go inside plugins, you can see the plugin called as Gib. And if I expand this, you can see the different goals which are part of this plugin. And the goal which we are interested is Gib build, right? So this will build the Docker image, and it will also push the Docker image to the Docker Hub. And if you want to just build the Docker image without pushing it, you can make use of the Docker build goal. Now let's try to create the Docker image using the Gib build command. So for that, I'm just going to open the terminal. I'm just going to clear this, and I'm going to go back to the previous folder under the microservices new folder, and I'm going to type in Maven clean compile Gib build, right? So if I try to run this command, it will try to build all our projects. And you can see that we are getting this 401 unauthorized exception, right? Because we want to push this Docker image to Docker Hub, but we didn't provide any information about what is the username and what is the password, right? So for this reason, we have to provide this information under the settings.xml file. So let's open this. So if I open my settings.xml file, you need to add this particular tag under the servers tag. So I'm going to provide, so I have to add this particular server tag, followed by the ID as registry.hub.docker.com, the username as your username which you have provided in the Docker Hub, followed by the password, right? So once you have added the necessary information here, and you should try one more time, and I'm going to run this clean compile Gib build command one more time. Alright, so this time you can see that the build is successful. It took 42 seconds to run everything on my machine, and you can see that these images are created successfully by typing the Docker images command, and you can see all the images which are built in my local. And let's also verify whether these images are pushed into Docker Hub or not. So I'm going to open Docker Hub, and I'm going to sign into my account. Okay, so I have logged into my account, and you can see that all these services, notification service, API gateway, so on, they are pushed a minute ago. So they are pushed now into the Docker Hub. So we can make use of these images, and we can try to run all these, download all these images and run those containers using Docker Compose. So now let's go ahead and see how to make use of Docker Compose to run all these containers. Alright, so now as we have all our Docker images in the Docker Hub, the next step is to create the Docker Compose file, right? So for that, we can refer to this docker compose.yaml file under the root folder of the microservices new project. So if I open this Docker Compose file, so let me collapse all the sections so that I can explain first. So you can see that we have different services as part of this Docker Compose file. The first service we have is the group called as MySQL Docker Compose config. So if I open the architecture diagram one more time, you can see that our order service and the inventory service is making use of the MySQL databases, right? And our product service is making use of MongoDB, and the auth server is actually Keycloak, which is actually will use another MySQL DB instance, right? So if you want to run the Keycloak, you also have to provide the database instance. So for that, I'm also going to use MySQL, right? So first of all, we are going to set up all these external services in our Docker Compose file. So that's why we have these two instances for MySQL database. So the first one we have is called as Postgres order. So this is the service which is present, which is dedicated only for our order service, right? So we are providing the container name as Postgres order and the image as Postgres. So it will download directly from the Postgres Docker image registry. And we are also providing some environment variables. The first one is PostgresDB. The PostgresDB is going to provide it as order service, followed by the username and the password, right? And we also have to provide the environment variable called pgdata, where it will store all the database related information, right? So for this, we are going to store it under the /data/Postgres folder. Next, we also have to provide the information about volumes, right? So if you want to run a database, usually Docker containers doesn't store any data inside them, right? So whenever you want, so usually the Docker containers are ephemeral in nature. So if you run a Docker container and try to insert a table and try to create a table and insert a record, and if you restart that Docker container, the data will be lost, right? It will not be persisted. So for this reason, we want to create something called as volumes, where you can map the data folder inside the Docker container into a folder in our host, right? So I want to create a volume so that all the data inside the /data/Postgres folder will be stored inside my own machine in a folder called as Postgres order, right? So this looks something like this, right? I've already created and run this Docker Compose. That's why I have this Postgres order folder ready. So basically you will see that all the data will be created like this in your folder. And we want to expose the port 5431. By default, it will use 5432 port, but we want the Postgres order service to run on 5431 inside the Docker container. And also I want to expose my host, my own machine's 5431 port to access this Postgres order database, right? And as we are not using the default port, I also have to provide the command as -p 5431 so that Docker will understand that Postgres should run on port 5431, right? I also have provided the restart setting as unless stopped, right? So similarly, we also have another instance for the inventory service called as Postgres inventory. So we have the container name as Postgres inventory, the image, and all the environment variables we discussed before, and also the volume information. And here I'm going to use the default port 5432. So that's why I've just provided this ports information without adding any command here, right? Because I want to use the default port for the inventory service. And next we have the Docker Compose configuration for MongoDB. So I'm going to call this container as Mongo. So that's why we have this container name as Mongo. And I'm going to make use of this Mongo image 4.4.14. And here also I'm going to provide the restart policy as unless stopped. And I'm going to expose the ports 27017, which is the default port of MongoDB. And similar to PostgresDB, I am also going to create a volume to map all the data which is inside the /data/db folder inside the MongoDB container into the Mongo data folder inside my own machine, right? You can also see this here to the left side. This is the data. This is how it looks like, this folder. Next, I'm going to create some configuration for Keycloak. So first of all, let's start with the Keycloak MySQL image. So this container name is going to be Keycloak MySQL, and this image is going to be from MySQL 5.7. And similarly, I'm also going to create a volume from the folder var lib mysql to this mysql keycloak data folder on my local machine. I'm also going to provide some environment variables like MySQL root password, database, user, and password. Right? So now let's go to the next configuration for keycloak itself. So the container name is going to be keycloak. I'm going to make use of the image keycloak 18.0. So this is the full image name I'm going to use. And the environment variables, we have provided some environment variables about the database and also the keycloak admin user and the admin password here. So we are going to make use of the ports 8080 here. So that's why I have provided 8080 as both ports inside the container and also the outside the container. And similar to the databases, MySQL, Postgres, and MongoDB, we also want to copy the data from realms. So we also have to copy some metadata about the realms we created from opt keycloak data import to the realms, right? And we are also running some commands called as start dev and import realm, right? So if you run this import realm command, what it will do is it will download automatically this realm information from our host machine to the Docker container. So if I open this realms command, you can see that I've added this realm export.json file, which is actually the complete metadata about keycloak. So if you remember in the previous parts, we have actually created the realm, the client, and also all the information inside keycloak. So I've exported all this information into this JSON. And so if you start this container, keycloak container, you don't need to create this realm, then the clients one more time. Everything will be present at the time of startup. And we also are depending upon keycloak MySQL. So if you want to start keycloak, Docker Compose will make sure that it will start it only after the keycloak MySQL container is up and running successfully. Right? If for some reason keycloak MySQL container is not running or it has some issues, it will stop the keycloak container. So now let's move ahead. Now we came to the Zookeeper and the Kafka broker configuration. I'm going to skip this because I've already explained this about this configuration in the previous part about the event tree and architecture. So I'm just going to skip this part. So now let's go ahead to the next configuration called as Zipkin. So here for Zipkin, I'm going to provide the image name as OpenZipkin/Zipkin. I'm going to provide the container name as Zipkin, and I'm going to export the default ports for Zipkin 9411 from our Docker container into our Docker host. Alright, so now let's go through the services which we developed in our microservices project. So this will be our discovery server, our API gateway, and all our other services. So we'll first start with our Eureka server. So the image we are going to use is the discovery server image, which we built as part of the maven compile gib build command. So I got this image name by logging into my Docker Hub portal. So let me open my Docker Hub, and in here I'm logged in to my Docker Hub account, and if I click on discovery server and click on tags, you can see that I did not create any tag, but usually it's a better practice to create a tag. So as I did not create any tag, it's updating in the latest tag. So it's using a default latest tag. So what I did was I'm just copying this information here, this name, and I just pasted it here inside the image section, right? So this is the image name we want to use. So what Docker Compose will do is it will download this particular image at the time of startup, and it will try to build this Docker image, right? So we have given the container name as discovery server, and we have also defined the pull policy as always. So whenever we try to start up Docker Compose, it will pull this image every time, and it will build this image, right? So the ports we are using 8761. As you know, 8761 is the default port of Eureka server, and we are adding one environment variable called as Spring Profiles Active Docker, right? So we are providing this profile name as Docker, and what we are doing inside our project is, let me open the discovery server project, and in here I created another properties file called as application docker properties. So this will be active whenever the environment variables, like whenever the profile which is activated will be Docker, right? So if you look at this application docker.properties, so we have defined the server.port as 8761, and we also are defining the Spring Zipkin base URL as http zipkin:9411, right? The difference between application Docker and application properties here is the Zipkin base URL, because when you're running the discovery server on local, we have this Zipkin URL as local, so that's why we have put it as localhost, the host name. But as we are now running our Zipkin in a different container, we want to point to that Zipkin container using the container name, right? So that's why we created the separate Docker profile, and we have defined the Zipkin URL as Zipkin:9411. So in this way, it will point to this Zipkin Docker container. So let's go back to the Docker Compose YAML file, and this particular discovery server container will depend on Zipkin, because first we have to make sure that Zipkin is up and running, and then only the discovery server can start. So now let's go ahead to the API gateway service. So we have similarly for the discovery server, the image name as API gateway with the tag as latest. The container name is API gateway. The pull policy is also, I'm setting it as always. And here the ports, I'm exposing the port 8181 because 8080 is the default port for API gateway, as we are already using 8080 for Keycloak. As you can see here, I want to expose the API gateway on port 8181, right? And we are also defining the environment variables similar to the discovery server, Spring profiles active as Docker, and we are also adding another property, logging level, for the Spring security as trace, right? So if I open the API gateway and the application docker.properties, you can see that our server.port is 8080. The Eureka client service URL for the default zone, I have provided it as username as Eureka, password as password, and instead of localhost, we are pointing to the discovery server running on the Docker container. So that's why the host name is the container name discovery server, right? Similarly for Keycloak, I have changed the resource server JWT issuer URL as http Keycloak 8080 instead of localhost 8080 as defined inside the application.properties file. So if I scroll down, you can see that the JWT issuer URI, we are pointing to the localhost 8181, which is the local Docker installation, right? So for the Docker container, I have provided the host name as Keycloak 8080. And similarly, we also have the Zipkin base URL as Zipkin:9411. So let's go back to our Docker Compose file. And similarly, we have the product service. So I'm not going to repeat this information one more time. So this product service is mainly dependent on the Mongo database, the discovery server, and the API gateway, right? So this makes sense because our product service will run only when all these three services are up and running successfully, right? If any of these services is not working, then also our product service will not start up, right? And coming to the order service, it's same again. We are making use of the order service image with the latest tag. And one interesting thing here is we are providing this Spring data source URL as the property, and this URL is JDBC PostgreSQL order 5431 order service, right? So I can also define this inside the application docker.properties directly. So let me open the order service, source, main, resources. I've also defined the Spring data source URL here, but if you want to override this information through the Docker Compose, you can do it by using this data source URL variable, right? And this order service is dependent on Postgres order, our Kafka broker, Zipkin, discovery server, and the API gateway. So if you go to the application.docker properties for order service, you can see that I have additionally defined the driver class name as PostgreSQL.driver, the data source username and password, Zipkin base URL pointing to the Zipkin container, the Eureka client which is pointing to the discovery server, and the another property we are adding is the spring.kafka bootstrap servers property, and this is pointing to the Kafka broker Docker container, and we are using the port 29092 instead of 9092. So if I open the application.properties here and scroll down, you can see that on just application default application properties we are using localhost 9092, as here we are communicating from our host machine, like this on my machine I'm communicating with the Docker container, Kafka running inside the Docker container, right? But in this instance we want to communicate from one Docker container, that means this order service inside a Docker container, to a Kafka running inside another Docker container, right? So in this instance we have to use the 29092 port. Why we have to use this port? So let's go to the Docker Compose and let me go back to the Kafka broker environment variables, and here you can see that we have this Kafka advanced listeners, right? We have defined two listeners here, plain text as localhost 9092. That means if I want to communicate with the Docker host, I will use this localhost 9092, and if I want to communicate between two other containers, I'm going to use the plain text internal property, right? And this is broker 29092. So that's why we are using broker 29092 when configuring the application docker.properties for the order service. I hope this makes sense. So let's move ahead to the Docker Compose file. Let's go to, now we are done with the order service. Let's see the inventory service. So again, the same, we have the container name as inventory service, image name as inventory service latest, pull policy as always, and we are also defining the data source URL for our inventory service by providing the host name of the Postgres inventory database, and as we are using 5432 as the port name, I'm providing 5432, and this inventory service is dependent on Postgres inventory service, discovery server, and the API gateway. Let's also check the application.docker file .properties file, and you can see that I have provided server port as 8080, Spring data source URL, driver class name, username, password, and all the servers we have the same information here. And I think I have defined something wrong here. It should be just Eureka instead of Eureka, yes. So yeah, that's it. So now if I go back to the docker compose.yaml file, we have our last service, notification service. Here also we have the container name as notification service, image name as notification service latest, pull policy as always, and we are now dependent on Zipkin, the Kafka broker, discovery server, and the API gateway, right? I hope this whole Docker Compose file is understandable to you. If you're not aware of, Docker Compose, I can make a full-fledged video tutorial for you. Just let me know in the comment sections. And so now all we have to do is start up all our services using the Docker Compose command. So now let's go ahead and do that. So now I have opened the terminal, and here I'm going to type the command docker compose up with -d flag, right? So what this will do is it will pull all the images which are required for all the services which are defined inside the Docker Compose file, and it will run those containers, and it will run the containers for those images in a daemon mode. If I just now type enter, you can see that it is trying to pull first the services. So now it is trying to pull all the services from the Docker Hub, and once they are in, so it's trying to Docker Hub, and then after pulling it will start running all those containers. Once everything is done, you will see that the containers are up and running with the state of started, right? You just have to give some time so that all the containers are up and running. And once they are up and running, I think we can go ahead to Postman and start making calls to our microservices project. Meanwhile, you can also verify you can also have a look at the logs to understand how is everything going on in the background. So for example, I can check the logs of Kafka broker. So I can just type docker logs -f broker. And here you can see that looks like our Kafka broker is up and running without any errors, right? So that's good. Let's see one of our microservice whether if it's running fine or not. So I'm going to type docker logs -f order service, and you can also see that our order service application is started without any problems. So that's also good. Now what I'm going to do is I'm going to open Postman. Alright, so I opened Postman, and as you know, the first thing we have to do is I have to get the access token from Keycloak, right? So with the previous videos, we already have created this setup, but what we have to do is we know that we define this client ID, but we also have to get the client secret for this client ID, because as we are using Docker container now, so every time we restart our Docker container, it will try to create a new client secret, right? So for that, first we have to open our Keycloak. I'm going to open localhost 8080 and I'm going to click on administration console, and here I'm going to type in the password we provided in the Docker Compose section. So that's going to be, so let's go ahead and check it. If I scroll down to Keycloak, so it's going to be admin and admin, right? So let me log in with these credentials, and you can see that I'm able to log in without any problems, and I am logged in by default into the microservice realm, right? So you can see that I did not create any realm, so it's automatically taken from the realm export.json file, right? It's already automatically copied this file during the startup of the Docker container, which is nice and convenient for us. So let's go to the client section here, and inside the Spring Cloud client, so I'm going to click on credentials and I'm going to regenerate the secret, right? And I'm going to copy this information, go back to Postman, and I'm going to replace the client secret with this information, right? And I'm going to click on get new access token, and you can see that this is successful. I'm going to click on proceed, and I'm going to use this token to use this. And yeah, now let's go ahead and try to call the product service. So I'm just going to click on send, and you can see that we are getting a 401 unauthorized exception, right? This is strange because we just got this client secret and also the access token. So to understand what went wrong, I'm going to open my IDE, go back to the terminal, and we are going to inspect the logs of the API Gateway project, right? Because this is the entry point to our microservice project, right? So I'm going to type docker logs -f API Gateway, right? So you can see that we are getting an error, JWT claim validator. The ISS claim is not valid. Authentication failed. The ISS claim is not valid. Right? So what is trying to tell here is our token is not a valid token, right? So how we can, so to debug this further, what we can do is we can copy this token, and I'm going to open a website called as jwt.io, right? I'm going to go to this website. I'm going to click on learn more about JWT. I think this is not the one. Maybe I'm just going to scroll down and I'm going to paste my JWT here, right? So that I can inspect and find out what went wrong, because in our API gateway it is saying that the ISS claim is invalid, right? I want to understand what is this ISS claim and why it is not valid, right? So that's why I'm going into the jwt.io website, and here I pasted my token, and let's verify what is this problem. So if you check the payload section, you can see that the ISS is HTTP localhost 8080 realms Spring Boot microservice realm, right? This is fine when you're running the application on your local, but as you can see, we are making this token, we are sending this token with ISS as localhost, right? So if you send this ISS claim, what the API gateway will do is it will try to contact its own localhost, right? So instead of contacting its localhost, it should contact the Keycloak server, right? So for this reason, instead of providing localhost, we have to send the token with ISS claim as Keycloak, right? So how we can do that is I'm going to go back to Postman, and here instead of providing the access token URL as HTTP localhost 8080, I'm going to provide this as Keycloak 8080, right? I'm going to point to the Keycloak container, Docker container, which is running in our machine, right? So now let's try to get a new access token, and you can see that we are not able to contact this Keycloak anymore because we are trying to contact the Docker container directly with the host name, right? So to be able to contact this Docker container from our host, what we have to do is we have to make some small changes in our system. So I'm going to open a file called as host, and I have to inform my host, my Windows host, to redirect all the traffics from Keycloak to a local host, right? So I'm going to add in 127.0.0.1, and I'm going to type in as Keycloak, right? So if I change my host file, which is in C Windows System 32 drivers etc hosts, so you have to change it in an administrator mode. So if you add this particular line, our postman will be able to contact the Keycloak Docker container, right? So if I click on get new access token, you can see that the authentication is now complete. So by adding this particular line, we are able to communicate from our local host to the Docker host through the host name, right? Or else there will be some DNS problems. So we need to add this particular entry inside your host machine. Keep this in mind that you need to do this only when you want to contact the Docker container from your local, right? You don't need to do this when you are doing it in a production. And if you are using Windows, if you are using Mac or Linux, you should actually change the /etc/host file. We can find it inside the /etc folder. So now let's use this token. So I'm going to delete the previous tokens, and I'm going to click on use token here, and now I'm going to click on send, and now you can see that we are getting a response back from product service, and this is the record which I've saved to the database. This is fine. Now let's try to test the order service. So I'm going to change the URL as order, and I'm going to change the HTTP method as post. I'm going to click on body and click on raw, and I already have this particular request body ready with me. If not, you can just type in this particular request body by pausing the video, and now I'm going to click on send. So we just have to wait for a couple of seconds, and then you can see that we are getting the message order placed successfully. That's perfect. But let's really see whether everything is working fine or not. So I'm just going to exit from the docker logs command. I'm going to clear out this terminal, and first of all I'm going to verify the order service, because that is the service which is actually we are calling, right? So let's check the logs, and you can see that it's able to call the Kafka container, like the Kafka topic, like Kafka broker, and send out our message, right? I don't see any errors. It looks like it was able to successfully connect to the Kafka broker and send out the message. That's fine. Now let's clear this out again, and I'm going to inspect the logs of notification service, right? So I'm going to type in docker logs -f notification service, and right here you can see that we are receiving the logs, received notification for order, and followed by the order ID, right? That's perfect, because that means our message is also received in the notification service, and all of our services are working well, right? So this is the end of this video, guys. I hope you learned how to Dockerize your applications and run those containers Docker containers using Docker Compose. In the next video, we will refactor this Docker Compose to Kubernetes, and the next part, and after that, we will also refactor our microservice application to use Kubernetes future instead of relying on futures like Spring Cloud Gateway. Right? So I will see you in the next video. Until then, happy coding, techies. Welcome to part 10 of the Spring Boot microservices project series. So in the previous part, we saw how to Dockerize all the applications inside our microservice architecture. So in this part, we will mainly concentrate on introducing monitoring across all our services and how to view the status of our services in a dashboard, right? So to monitor our services, we will be mainly using two softwares. The first one is Prometheus, which will scrap all the metrics from our Spring Boot applications and it will store it in an in-memory database. And we will visualize these metrics using another software called as Grafana. Right? So now let's go ahead and understand how to implement monitoring in our microservice project. So this is how the process will work. So our Spring Boot application will make use of the actuator endpoints. So we have this Spring Boot actuator, which will expose all the metrics of our application, like the JVM metrics and other metrics we want to maintain. It will be exposed by our Spring Boot application using Spring Boot actuator. And the Prometheus software we will set up will poll our Spring Boot actuator endpoint for every predefined seconds and store it inside the in-memory database, right? So this Prometheus will act like a data source for Grafana, which provides a UI dashboard. So Grafana also polls Prometheus. So whenever there is a new entry, Grafana will update it and will show the metrics in our dashboard. So let's set up this whole infrastructure in our project and see how to implement monitoring. Alright, so now I'm inside my IntelliJ IDE, and the very first thing I'm going to do is to add the necessary dependencies for our services to enable Spring Boot actuator. Right? So for that, I'm going to open start.spring.io website, because here I can add the dependencies through the UI and I can, explore and I can view the pom.xml and copy the dependencies from there, right? So this is a very reliable way to get the dependency information. So I'm going to add the dependencies first of all for Spring Boot actuator, and I'm also going to enable the Prometheus support for our application, Spring Boot application. So for that, I'm going to type in Prometheus, and here you can see that this Prometheus dependency uses micrometer to get all the metrics and expose it in the Prometheus in the format so that Prometheus will understand, right? So that's what it says here: expose micrometer metrics in Prometheus format and in-memory dimensional time series database with a simple built-in UI, right? So I'm going to select this particular dependency. And let's see the pom.xml. So for that, I'm going to click on this explore button. This will open the pom.xml. So here I'm mainly interested in this Spring Boot starter actuator dependency and also micrometer registry Prometheus dependency. So I'm going to simply copy these two dependencies, go back to my project, and I'm going to add this inside all of the services, right? So I'm going to add it inside the API gateway, inside the discovery server, inside the inventory service, the notification service, product service, and lastly, the order service. Right? After adding all these dependencies in all our projects, I'm just going to click on this particular Maven icon so that these dependency will be downloaded to our machine. So after everything is downloaded successfully, we need to enable the actuator endpoint in our application, right? So, but before doing that, I think IntelliJ is saying that this Spring Boot starter actuator is already present in the order service. So let's search for that. And I think we have already added the actuator before, so we can remove this dependency now. And let's update the Maven configuration one more time. That looks fine. So the next thing we are going to do is to enable the actuator endpoints in all our microservices, right? So for that we need to add a dependencies in the application.properties file. So for that I'm going to first open source main resources folder, and I'm going to open the application.properties file, and here I'm going to type in management, the property name management.endpoints.web.exposure.include, right? So by default all the health endpoints will be exposed by actuator. So I also want to include the Prometheus endpoint, so that's why I'm going to type in the value as Prometheus. So by adding this value you can access the /actuator/Prometheus endpoint from our service, right? So I'm going to add a small comment called as actuator Prometheus endpoint, right? So I'm going to copy this and I'm going to paste this inside all other services. So first of all I'm going to copy this inside the discovery server, the inventory service, the notification service, and the order service. And you can see in the order service we are getting an error that it is a duplicate property key, because we have already enabled all the endpoints for the actuator by using the star wildcard, right? So I'm now going to remove this because we don't need this endpoint, because we don't need this property. So I'm going to go ahead with the next service, the product service, and paste the same property information inside the product service. So after adding these dependencies and also after updating our configuration with inside the application.properties file, the next step is to build the Docker images using the gib Maven plugin. So for that I'm going to type in the command maven clean compile gib build. So I'm going to use this particular maven clean compile gib build command, and now our application will be built using the gib Maven plugin. And this gib Maven plugin will create the Docker files and will push it into the Docker registry as we saw in the previous video. So I will be back once the build is completed. Alright, so now the build is successful. So the next step we have to do is to install Prometheus and Grafana. So as we are using Docker Compose, we can make use of the pre-existing Docker images and spin up Prometheus and Grafana as part of the Docker Compose orchestration. So for that I'm just going to scroll down until the end of the Docker Compose file, and I'm going to paste in this configuration for both Prometheus and Grafana. So let me explain this Docker Compose configuration. So I'm going to name this particular node as Prometheus, which stores all the Prometheus configuration, and the image I'm going to use is this Prometheus image with version 2.337.1, which is the latest version of the Docker image. The container name, I'm going to use it as Prometheus, and I'm going to provide the restart policy as until stopped. And I'm going to export the ports 9090 because as I want to run Prometheus on these ports, and I'm going to add a volume which actually copies the configuration, the Prometheus configuration, from a file called prometheus.yaml. And this particular file is not existing yet. We will create it shortly. So we are instructing Docker to copy this prometheus.yaml file from our host machine to the /etc/prometheus prometheus.yaml file during the container startup. And this Prometheus service will be dependent on the product service, inventory service, order service, and the notification service, because we want to mainly monitor our main services, main services which contains the business logic. So that's why I have added these 4 services. But if you want, you can also add the other services like the API gateway and the discovery server, right? So that is the configuration for Prometheus. Coming to Grafana, I'm going to use the image Grafana OSS with the version as 8.5.2, and I'm going to provide the container name as Grafana. and I'm going to use the port 3000 to expose Grafana. And I'm going to link this to the Prometheus service, and I'm going to create a volume which maps the Grafana folder to the /var lib Grafana folder inside the Docker container. And finally, I'm going to add some additional environment variables which defines the username and password as admin and password. Right? So these are used when we want to log into Grafana UI. So we will see how to use that how to do that shortly. Right? So after adding this configuration inside the Docker Compose file, the next step is to create the Prometheus configuration file. So for that, I'm going to right click on the root folder and create a new folder called as Prometheus. And inside the Prometheus folder, I'm going to create a new file called as prometheus.yaml. Let's add this into the Git repository. And for this configuration file, so let me paste this. So let me paste some configuration file. And I will walk you through the whole configuration. So first of all, we are going to provide some global settings here. So first one is going to be called as scrape interval. In the previous diagram I showed you, Prometheus will be scraping our Spring Boot application for every predefined set of seconds. So this interval we have set as 10 seconds here using the scrape interval field, and for every 10 seconds we are also going to evaluate the internal rules inside the Prometheus, right? But we don't have any rules set up, but this is the default configuration we can use, which evaluation interval has 10 seconds. So what this will do is, if there are some custom rules inside Prometheus, these rules will be evaluated for every 10 seconds. Right? And next we have to define the scrape configuration. So inside the scrape configuration, we can define multiple jobs. And as I mentioned before, we will be setting up the jobs to scrape our main business services, that is the product service, order service, inventory service, and the notification service. Right? So we have 4 jobs. We have total of 4 jobs. And for each job, we are going to first provide the metrics path. Right? So this metrics path is nothing but the actual URL which the Prometheus has to call. For our product service, this is going to be /actuator/Prometheus, because this is the default URL for all our Spring Boot applications. Right? So this metrics path is going to be the same for all the jobs, as you can observe, because this is the default URL. And inside the static configs, we have to provide the target URL. So for product service, that is going to be product service :8080, because product service is running on the port 8080. And we are going to define a label called as product service application. Right? Similarly, we have also the job configuration for order service. I've defined the target as order service :8080, because this is the URL where the order service is running. Similarly, we also have the inventory service and the notification service. So this is the main configuration of Prometheus. So now let's go ahead and run our Docker Compose command. Alright, so let's start our Docker container. So let's start all our services using the Docker Compose command. So I'm going to type in Docker Compose op -d. So this will run all our services. So let's wait until all our services are up and running. So you can see that all the services are up and running. Now I can check the logs of Prometheus and Grafana to see whether they are running fine or not. So I can type in docker logs -f Prometheus. And here you can see the command, you can see the message, service is ready to receive web requests. That's good. So let's check also the logs for Grafana. So I'm going to type in docker logs -f Grafana. And here you can see that also Grafana is working fine. It's trying to access some default dashboards, but it's fine as we did not create any dashboards yet. So this is also fine. So I'm going to first open a web browser, and I'm going to open localhost 9090, and here you can see that we are able to access the default Prometheus UI, and here I can search for some default metrics which are exposed by our Spring Boot actuator endpoints from our microservices. So I can search for different kinds of events. So I will first search for this logback events total and click on execute. And here you can see that it's trying to read all the logback events metrics which are exposed by the inventory service, the order service, and the product service application. Not only that, you can see the status of our services by clicking on this status and service discovery, and here you can see all the different services which are identified by Prometheus. So I can also go to the status and targets, and you can see that the inventory service is in the status up and it's working fine. It looks like the notification service is not working. We will get back to this later, but let's see how to set up Grafana and visualize all the metrics. So to configure Grafana, I'm going to open the URL localhost 3000, and this will open a default Grafana dashboard. So as we defined the username and password as admin and password, I guess. So let's go to the Docker Compose file, and yeah, so the username is admin and the password is password, right? So I'm going to type in admin and password, and I'm going to log in. And here you can see the default Grafana homepage. The first thing you can do here is you have to first add the data source for Grafana, right? As I mentioned before, Grafana needs a data source to visualize the metrics. We will be using Prometheus as a data source. So let's click on add your first data source option here. And here you can see there are different kinds of data source you can add. The time series databases, we can use Prometheus, Graphite, and InfluxDB. So I'm going to use Prometheus, and I'm going to name this as Prometheus microservices, and I'm going to define the URL as http prometheus:9090, right? Because Prometheus is the name of the container, Docker container, which is running, and as this is running inside, Grafana is running inside a Docker container, I'm going to provide the name of the container so that it will communicate with Prometheus using the host name. Right? So after adding this configuration, I'm just going to scroll down and click on save and test, and you can see that the data source is updated and the data source is working fine using this status notification. That's fine. So the next thing I'm going to do is I'm going to create a dashboard, right, to visualize all our services. So we can create our own dashboards, but this is not so nice because creating a dashboard is not an easy task. It needs a lot of configuration. So what I can do is I can import some existing dashboard configuration. So for that, I'm going to open my GitHub repository, and when you open my GitHub repository, and when you open the branch part 10, you can find a JSON file here called as grafana dashboard.json. So click on this JSON file and copy everything which is inside this particular JSON file. So all the way down, I'm going to copy everything, and I'm going to paste this inside the import via panel JSON text area, right? And I'm going to click on load like this, and here I'm going to select the Prometheus data source, right? So Prometheus data source going to be Prometheus microservices because this is the data source we created, and I'm going to click on import, right? And now you can see a beautiful dashboard with all the information like the uptime, and the start time, when is this particular service started, and what is the heap memory which is used, and what is the non-heap memory which is used. And you can also see the CPU usage and the average load of the services, and you can see different kinds of statistics. For the JVM statistics memory, you can see the heap space allocation for different spaces in our garbage collector, and different kinds of metrics and dashboards. You can visualize it here, right? So you can switch between our services using this instance. So the present view you're seeing is for the inventory service. You can switch to the product service, for example, and you can see that the statistics has now changed. The heap space is used as 3.6%, and here you can observe that as our product service is not using any relational database, it's not using the default Hikari connection pooling, so that's why you see this as none. Whereas if you open order service, you can see that you can select the default Hikari connection pools, as we are using the MySQL database. So this is how you can monitor your services using Prometheus and Grafana. I hope you learned something new. I will see you in the next video, and until then, happy coding techies.